Hello.
Good morning, Magnus. How are you?
I'm very well. It's so good to be here. I'm really excited because I get to sit here and listen to some great architects today. It's one of my favorite things to learn from friends.
Yeah, that's awesome. I think everybody, welcome to the Software Architecture Virtual Conference. My name is Mahesh Chan. I am speaking from Philadelphia here in USA.
Yeah.
It's a nice weather, sunny, 80 degrees. Um, we still have some coronavirus cases going on. Looks like things are looking a little bit better.
Yeah.
There's already some other issues going on, but today we are not here to talk about. How's everything there in Malmo, Sweden?
It's really good, actually. So it's a sunny afternoon here. It's Friday afternoon. Everything is lovely. And we have, expectations of a warm and nice summer and things ahead. Things are looking up and up, I would say, all in all. There has been, of course, some disturbances, and the reason we're not traveling, right? This would have been nice to have as a physical conference to meet up, but I guess
Right.
no one is doing that right now. We're all virtual. So being virtual is pretty exciting as well, because you get to very easily connect with some good friends. We have a good strong lineup of really good software architects here today, right? We're gonna cover the software architecture spectrum in many different ways. We're gonna try to shine a light on this field, this work role of software architect.
Yeah, I mean, that's what this is all about, because software architect is one of the most popular, most paying role in the software world, right? Everybody wants to be either an architect or a project manager.
Yeah.
So let's talk about this. Let's a little bit. You want to share your experience as an architect?
Yes, I was gonna say, I think just a little, like a few years ago, I think software specialist or software architect became the most sought after work role in the world. It passed by things that have been, for decades have been dominating, like airline pilot and doctor and, physical physician, right? Surgeon. Those kinds of work roles have been dominating in many years. But now software architecture is on top. And that's a very exciting role that many people want to work with. And I've had the opportunity to work in this field now for a decade and a half, and it's a wonderful field to work in. So really, that it's an exciting area, and I'm happy to be able to share some of that here today.
Great. So yeah, let's you wanna start with the slides. Let's
Yeah,
talk
yeah.
about a little bit. I
We have,
think first you and
yeah,
I going to talk about what a software architect really is, what they do as in software architects, what they do, what their job is, day-to-day job,
yeah,
and we'll share some of our experience. I
sure.
myself, he be, I was lucky. I start, when I would start working, I worked in a, smaller companies. When
Mhm.
you work with the smaller companies, you end up direct working with the customers, direct working with the owners, stakeholders, and you start building your your own ideas and innovation, and then that's how you kind of that's the first step towards being a software architect. So
Absolutely. I get that. I was fortunate as well, I suppose. I started as a developer. Obviously, that's the entry point. I was a developer, and I started moving more and more towards, with experience, more responsibilities added. And I found that architecture is actually, I thought I was going to become a building architect once, to build physical buildings. But then
yes.
I decided maybe not to pursue that as a career path. But then when I joined and the other field of developer, I came into this field, and then I decided maybe architecture in software was the way to go instead. So that's pretty cool.
There you go.
Uh, Define wise, when
Yeah,
you are,
so
yeah,
what
when you
is software architecture, right? When you
are,
think of software architecture, what
yeah,
is it? Let's just yeah.
yeah. So when you define what kind of what software architecture is, it's obviously different from building architecture. It's a very physical thing when you build a bridge or a house or something. But software architecture is more like a map of what you can build in terms of a software system, more of how it's built, how it's supposed to be built, and how it works and how it hangs together. And it's quite different from architecting a building, of course.
Yep.
But it's a very important and central piece of any construction that you ever make, because without it, you're going to be pretty lost when you won't have a shared vision, a shared goal when you're building something. So it's a very important piece. So the question is, why is it so important? So I'd like to check with you, which you had some really strong visions there in terms of that it has to be something that you build that we can actually create in the first place, right?
Right. So when you build a software, right, you said building, like real building or house, or, you can kind of compare some parts of that with the software also. When you see the software, first, it's important because you need to think about whatever you're building. Is it feasible? Let's start with some of the properties, right? You have to look at, as an architect, you look at, is it feasible? Feasible means the company or the owner you are building a software for, can they really pay for that, right? You cannot build something if there's no money for that. So feasibility is very important. Feasibility includes not only just financial, but also from the resource and time perspective and technology perspective, right?
Yeah.
Then
it's very
yeah.
exciting to try to build something, very complete and very complex, but along those lines, not only feasible to actually build within the budget frames and time frames that you have, but with these properties as well, simplicity and friendliness are also incredibly important.
Yeah, software has to be simple. Simple, I mean, it doesn't mean simple doesn't mean the functionality wise, but imagine if software is, when you architect a software, it's not just for you or your current team. This software may be running for 5 years, 10 years, right? On CSharpCorner, we wrote this product like in 2003, and it still works, right? So you have to look at when you're building something, it's simple, so anybody new developers join the team, they can easily understand that. You don't want to complicate things if it doesn't need to be, right? It has to be friendly, because during the time it's going to change and it's going to start talking to other software as well. And now obviously it depends on the software. Some are just simple software, some are just simple console app, right? Some are just web services. They have certain roles to play, but anything we design, make sure they're simple and friendly. Friendly means they can communicate and talk to other software as well.
So I was thinking about those things when you said this earlier to me, that when you reach a certain point with a product, it's time to let it go. It could be that it's something that's running for more like a let's say you're running some kind of a campaign software. Maybe you can build it quick and relatively dirty because you're just using it for a short period of time. But that's not the reality for many software systems. The reality for lots of them is that they are actually targeting longevity, that they could stay around for quite a long time. So obviously, if you're building one or the other, it depends on how solid you build the structure. But if you're building something that's going to be around for a long time, it needs to have that sustainability property that you talked about.
Correct.
Yeah, definitely, 100%. And so now that you've built something, we were able to build it. It was feasible. You could build it. It's out there. It's running, and it's stable. It seems like it's working. Here's a problem. How can you be super successful? I know some of the story behind the scale of CSharpCorner, right? It started out pretty small, and then it grew into millions and millions of visitors and millions of bloody users and everything. It's crazy, right? It's huge. And you had some scalability challenges with it.
Yeah, if you are when we are architecting a new software, you have to think of users. Who is the user? How many users? What is the potential, right? Some softwares, they're designed just to work for few people only, right? But if you're building a web application or website like CSharpCorner, there can be millions of users using it every month, right?
Exactly.
Look at Facebook, and look at Facebook. There's literally 2.6 billion people use
Yep,
Facebook.
yep. Yeah, Facebook
So
had to go so far as to start building their own data centers, which is, of course,
exactly.
a unique extreme in the world, but still, most
Yeah,
of us.
and so that's why, when you are designing this, architecture, you have to look at that and make sure it's scalable and expandable, right?
This is
You
the
know,
challenge, right? It starts
yeah,
small, with something that was feasible, something that you could build with enough effort, enough investment, money, time, get it out there, get it started. Now, down the line, if when you are successful, I'm not going to say if, when you are successful, when you become a huge success, right? You get so many customers and visitors and whatever it is on your site, or you using your service, all of a sudden you're a mega success. Great. But the challenge with that is that success can be your kind of worst enemy. If you
yeah,
haven't built a software architecture that you can scale, that you can change things in, that you can remove a piece and add a new piece and grow, then you're going to be in trouble. So you have to apply some really good practices from the beginning, right? That's
yeah,
actually something that we are going to have a good presentation, second presentation today, right? Andy is going to talk about that. Build an architecture which can grow. It's not everyone who starts to build with an enterprise scenario from the beginning. You start as a small business, and then you grow, and then you grow more, and then all of a sudden you're a success, and crap, your architecture falls apart because it wasn't built for thousands and thousands of visitors.
yep, that's
This
right.
can be a real challenge. And
Yes.
yeah, it's very exciting times to be in, but it can be a problem if your system is not scalable enough. You may be losing business when you are a success, and nobody
Yeah,
wants.
and when people come
Mhm.
and they grow and your traffic is growing, users
Yeah,
growing, there's no time for you to rewrite again. That's the point. That's the problem, right? I seen so many startups fail or companies fail because they were unable to scale their systems.
that's right. That's very important. And now on the far end of that, we're talking from something feasible, affordable, small, growing, 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 becoming successful. Sure, that's not the reality for many people. They start sort of on the opposite end of things. They start more on the enterprise side of things, which is actually going to very soon be our first presentation of today. In the enterprise space, but actually important for everyone. But for enterprises, it is an absolute go, no go thing. They have to have the security in check. They have to have traces and audits and be compliant and these kinds of things. And those are extremes that you also have to take into account.
Yeah. So today, any software you build today, I
Yep.
call it secure first code. Okay. I said, as a software developers, we don't think of security when we are building our first screen, when we are building our first part of the software. What I call it, our software should be secure first, accountable first approach. Forget the code first. Okay. Coding is, we already have master coding now. In the
Yep.
past 20 years, 25 years, we know how to code. Now we need to, as a software architect, if you want to become a software architect or you are an existing architect, you
Yep.
need to think from day one. If you are storing your user ID, password, email, how are you storing them so they are secure?
Yeah.
How are you transferring them so they are secure? How is your password? Is that readable through the web? That's
Person,
very important. And
personal
same,
identifier
exactly.
data, data sovereignty, and all kinds of rules that you have to take into account when you're building something.
Yep.
Maybe
And then,
you can
yeah,
get away with a few things, maybe when you're small enough, but once you get large enough, you're going to get slaughtered if you're not compliant, right?
correct.
You're going to get compliancy requirements from the customers that you work with, and you're going to have to prove that you are compliant in order for them to be able to do business with you at all,
Yeah.
which is a
And
whole ball game.
and
Yeah.
you hear these stories all day. Oh, this company got hacked, this company, Target got hacked,
Yep.
Equifax got 330 million people's Americans data got stolen, include credit card, social security. So that has to be your day one architecture requirement, right? And then
I actually had hair standing up on my arms when you said that Equifax thing. It's like, ooh, it's
Yeah,
scary.
like somebody has my literally my all credit cards, my bank account, my password, social security. So literally they can go and buy a car on my name today. That's what
Yeah,
happened, right? It's
exactly.
because somebody architected the system wrong. Okay. And the same thing with the accountable. We have to trace everything, the audit logs, the exception handling, the error handling, logging, all that has to be part of your day one architecture. That's
So
how good architects do this, build software.
exactly right. Yes. And so that having that said, there are a lot of things that we as architects have to take into account. And this picture here is not for everyone to sort of read every line and understand and memorize. And we're not going to do a quiz. But the point of this is that there are these things and more things. There are so many things that we as architects have to take into account, have to remember to evaluate when it comes to security, code reviews, code quality. How can we deploy this thing and integrate and scale? There are so many things, right?
Yeah, I mean, yes, when a lot of architects they miss the point that software architecture is not just, you know, building the architecture design and document, right? It's more about software architect is the centerpiece. The person software architect is the center. I say quarterback for a football team. It's a captain for a cricket team. They are the guy who are the glue between the business side, the project management side. So they include in the requirements, make sure the business is what they're talking about, that's clearly defined and easily understandable by the developers who are writing the code, because
Yep.
if that part is wrong, everything is wrong.
Everything is wrong.
And
You're
architects should also make sure the technology decisions they are making, make sure they don't pick older technology that's not gonna be workable in next 2 years.
exactly
So
right.
yeah, and then obviously the communication. As a software architect, not only you have to know how to good write good, speak good, but also how to present, because you're going to eventually present to the business stakeholders, you are going to present to end customers, and you have to be also a leader and people person. Because as you said, Magnus, we were talking earlier, you
Yep.
said it that if you can't make your developers happy, your team happy, you
Mhm.
won't be, they won't, you won't get productive from that.
Exactly. We're going to dive into some of those maybe less expected questions during the panels. We're going to talk about that. We're going to talk about how to make people happy and how to be sort of the center point between business stakeholders and end users and technical people. How the architect has to be the glue in the center of all of this. Like
Yep.
you said, the quarterback. Very, very valid points there. So finally, we have arrived at a picture of different kinds of architects, and we have several architects here today ready to present for us one after another. We're going to introduce them one after another, and we're going to talk. We're going to hear them listen, and we're going to ask them some questions about their experience as architects. They're going to share their knowledge with us. It's going to be great. So I think we have all of these represented today, right?
Yes, we do. And I think so just quickly, application architect, we call somebody who's architecting is an application, just an application. For example, you can be a .NET architect, you can be a Java architect.
Yeah,
That means you're only building something in Java. Then there's a
exactly.
web architect. They are responsible for building a website or web application. Then cloud architects are there, like yourself. Magnus is cloud architect. So they are kind of handling the Azure and AWS. And then security architects, their focus is just how to keep control, manage and build enterprise and cloud and software security.
Yep.
And then the last one is enterprise architect. And you want to talk about a little bit more about cloud and enterprise architect, and then invite Naveen.
Yeah, exactly. So we have all kinds of architects again, right? And now in modern times, often we have the back end system that used to be a server somewhere on premise in the company, right? But we are seeing more and more now that companies are taking a bet at the cloud as their back end system. So the cloud architect that's someone who a person like me, right? I'm a cloud architect. Uh, and we're going to listen to a great cloud architect here later today, Vishwas. And cloud architecture has become a very central thing because it's become the glue of the user experience. Because a user experience today, there's some kind of a web presence. There can even be an application, a client, right? Depending on who is using the system. But customer facing is probably a web, and then together with that web, maybe a mobile experience.
Yep.
But the web and the mobile experience need to have a backend. And oftentimes today, more often we find that people are starting to put this backend, this shared backend in the cloud as a cloud backend system. So that's a very, very important piece in modern systems design today to use the cloud.
Yeah, and then I think we also have, then you need some kind of web API or some kind of API or microservices that communicating between the backend data and the front end. So we have a session on microservices as well, where one of our architects is going to talk about microservices architecture.
So we have a very, very exciting schedule ahead of us. We're definitely going to enjoy all of this. I'm going to sit here glued to the screen and listen to all the great architects present. We're going to call the first one. And we're going to start big. We're going to start really big with the biggest systems you can imagine. We're going to start with the enterprise. And speaking to us today about the enterprise is a very good friend and enterprise architect, Naveen. Welcome to the show, Naveen. Oh, I can't hear you.
Naveen.
He is still talking, but I cannot hear you.
I did math.
There you are.
Yes. So that is the whole logic I'll put in my presentation. How one piece does not fit an enterprise, so we have to think about whole ecosystem. So that is the way we have to think about security, software, technology, business process, and rather the whole enterprise as an enterprise architect. So that is the core learning I have to share.
And Naveen, I believe you are joining us from Finland. How's things there? How are things there?
Okay, Finland is getting warmer, like 12 degrees in daytime, and nights are still cool, 4 to 5 degrees, and things are pretty good. Although the population is very, small in number, so the corona is there. Corona is there, but it's not so much cases. So it's sort of stagnant. Yeah. So it's
good to know.
But,
so
all right.
you will don't blink. You will miss the Finnish summer. It's gonna be 1.5 days, and then
yeah, that is a very popular saying. So we have been here since last year, so we know that the summer is just the moment you buy your tracking suit and you start preparing for the summer camp, it's gone.
Yeah, then it's gone. Exactly right. So
all right, it's all you, Naveen.
Yeah, you can go ahead and take it away and talk to us about enterprise architecture.
Sure. So I just want to share my screen. Good. So good evening, good morning, and good noon, everyone. For those who are joining across the globe, and welcome to this very interesting session. So although we had a very good kickstart of the session telling all about the architecture, so let's start with the very big entity as per Magnus. It's the whole enterprise, how we put and describe an enterprise into an architecture. So it's like a very big mansion or very big palace. There will be different segments, barracks, artillery rooms, people where the generic public says all about King's Palace, Queen's Palace, everything. So it's like a big mansion or palace, and it's all architecture, from where they get water, from where the food comes from, fire arrangements, everything. So that is all about enterprise. So let's think about who is an enterprise architect. I just give you the hint. So enterprise, as we know, is a group of people working for a common cause. So that cause is defined by the leadership. They are into consulting. They could be into buying or selling the services, buying or selling products, or pure consulting, or any of the services. So that is called as an enterprise. And when this enterprise, all their goals, that is the business vision, strategies, process, and guidelines are documented well in a very, mandatory way, so that anyone could go through, okay, this is company X, their vision is to sell this product. Okay, this product, to develop this product, they have the set of standards that this product complies to these standards, and to follow these standards, to attain these standards, all the employees of the companies of that entity had to follow certain processes and guidelines. So how these terminologies support each other to create an entity which is an enterprise. So enterprise is at different scale. They could be small, they could be medium, they could be large enterprises, and their requirement of documentation or adherence to specific set of standards depend on which domain they are. For example, there is a in banking or financial industry, there is a SOX standard. In hospitalization, it's a HIPAA standard. There are other, if in US there are national security, there are NSA standard, there are ITAR standards. So there are different standards different entities could adhere to or could get complied with. For example, GDPR is a standard for data private data protection about the customers. So all these standards relate that they should follow the products, they should use the products or develop the products that they are in standards. And the one guy, including his team, so enterprise architect generally they don't work alone, they work in tandem, they work with the team. And who is their end consumer is their CEO or CIO. So either the CEO or CIO, they sponsor the enterprise architecture group, because creating an enterprise architecture is a very time consuming, and it's on the scale of economy, it's a very costly affair. But once you have that enterprise architecture built up for an entity, it's very easy to change the shape of the organization, like introducing new services to the customer on the go. So that agility comes with having that enterprise architecture in place. So we will take up with the small examples. Let's first see what this enterprise architect basically does. So, as I said, the enterprise architect works with CXOs. They know the business processes, that this our company, they had the set vision to deliver X and X service in this domain. It could be banking, it could be civil aviation, any domain. And then they know that what is the information flow between the different actors and stakeholders, how the information comes into the enterprise, where does it stay and where it goes, if it goes to archive or reporting or auditing purposes. Then they understand, basis on the information flow, they understand the data architecture. How does the data relates to the information? What are the standards or policies that apply on the data? Who can see the data and who not? Then data ultimately is dealt by means of a application. So if I need a data, I need an application interface. So this is the application architecture or application landscape of that entity. For example, for CRM data, we use X technology. For financial data, we use SAP. So there could be different application architectures. And then this application architecture sits on top of technology. Technology is the core underlying layer. It could be cloud, it could be on-premise, it could be Unix operating systems, it could be databases that we use X technology as a standard. So mentioning all that will help if some new projects is launched and some new entity, some new members join the team from outside. They know these are the set standards. We read these documents and we get the clear guidelines which technology stack we have to adopt to maintain or to adhere to the company standards. And then the enterprise architect also knows the program management. So example, there are multiple programs that run in an enterprise at point of time. So they understand that, the correlation between and dependencies between the programs. If one program is running, the second program or the consecutive program cannot start until this finishes because its deliverable is the input to the next program. So they understand these programs, and then overall they are part of the governance. So they govern the whole documentation repository, which is called enterprise repository, where all these standards are written and maintained. That is called as enterprise repository. So they are custodian of this repository. In any standard, if needs change, there is a set process how you get that standard change. So this is enterprise architect. Let's go into deep dive scenario, what exactly they do. So this image taken from the Spark systems. So Spark developed the enterprise architecture tools so that the repository, keeping a repository is easier. So first of all, they do business and IT planning. So one, if a person understands clear relation between a business and the IT, the technology, by means of the information flows, by means of application architecture and technology architecture, that means he is on the path to become an enterprise architect because he's keen to learn and he understands this and continuously develops its understanding about it. Second part is capability modeling. So he creates these models so that it's a snapshot of the skills attained by a company at any given point of time. And if a new product has to be developed, for example, a company is into software development, they produce some CRM software. So now the digitalization demands that the end user should be able to send a tweet to get the required service, say a required report or bank statement or something. So your company's onus becomes to add that module in their software. To add that module, first of all, you will check what are the resources I need to add that module in my existing software. So you create this as Delta project. You check what are the resources available. Anyone who had worked on Twitter APIs is an in-house. Then they check what sort of infrastructure I would require. That is the IT landscape by business area. So what is the infrastructure I require to offer this module? Then they assess the current and future states, that this is to be model, this is to be with this popular or this module add-on. And this module will impact 3, 4, 5 services. On top of that, they run the programs, they understand the dependencies and the change impact of every program. They do the predictive analysis of the outcome and consecution of impact of each parallel program is running. They develop the architecture frameworks or adopt the architecture framework from the market, and then they customize these frameworks which suits best to the company. Then they do the enterprise project planning, running assigning multiple program managers. They follow the methodology. It could be PMP, it could be Prince2. Uh, these are the methodologies being followed worldwide for having a good program project execution. So they follow the methodology defined by the standards and they keep track of that. Then they highlight the technology risk, they create mitigation plans, and they assign owners of these risks and mitigations. And then they understand the technology maturity curves. So if, as I said, now the CRM needs Twitter to be introduced, so they understand that this is the new technology and they have to adapt it which will ultimately bring more collaboration with their either the application users or their direct customers. So that is here to stay for another couple of years. So they are visionary. They understand this from the technology impact they have and the technology OEM network they have. So they go to different events, they understand what new products are coming in and how a typical technology is evolving. For example, email is a one technology. Now it is a generic technology, so it is matured enough. Now we have a secure email. There are different variants of email, but now the email as a service is matured. But in the earlier stages, most of the companies did not have email or the facility or infrastructure to provide email as a service to its users or their customers. So in those areas, in those days, uh, the technology architect played the enterprise architect role. Now it's evolving, the whole landscape is evolving, and there are new positions coming in. For example, CISO. So CISO is Corporate Information Security Risk Officer. He understands the information security so well that he can take care of the whole enterprise risk analysis, information risk analysis, and mitigate, can provide measures to mitigate it. Similarly, new CRO, that's the corporate risk, so he understands other operational risk as well. So these are the new roles, CXO level roles, which have come into picture over the years. Similarly, enterprise architect as a role has become more visible in the careers, different technology related careers. But as Magnus mentioned, after software architect, enterprise architect role is in league, and how to become an enterprise architect. So there is a road. You need to be a SME first. So earlier we understand one technology better way, and we start giving the point solutions. So our company puts us in front of customer to provide solution to their problems. So we try to understand the whole ecosystem where my solution will fit in, and this understanding of the whole ecosystem make us an architect. So architect generally does not give just a point solution, so it's not a off the shelf product. He understands first the business landscape, the challenges, and then he creates the overall solution which answers to most of the or all of the questions and puts added benefits on the table as well. So that becomes an architect. And when we talk about the whole enterprise, set of standards, information technology, business ID mapping, then we become enterprise architect. So it's a long journey, but there are certifications available which can give you more in-depth learning about what an enterprise architect is and more about enterprise architecture. So TOGAF is the one. So I myself am TOGAF certified. I am on the certification standing committee as well with the open group. So TOGAF, there's another framework like Zachman, but TOGAF is more widely accepted. And last year only, as a working group member, we introduced Enterprise Architecture of India. So we call it India, INDEA. So Enterprise Architecture of India. So we working with Government of India, and we are developing and continuously receiving feedback on that. So this is what an enterprise architect does. So basically, it is an evolution of software or technology architect into a business person, and he starts relating business to IT and start understanding more and more about enterprise, so that their enterprise can become more agile, have a set of standards to follow, and can easily transform itself as the need be, because everything is in repository, and they can easily adapt the changes required for bring in more benefits or and a change of dimension of the business, something like that. So that's all about enterprise architecture and enterprise architect. I am glad if you have more questions, you can type in the chat boxes and we will take it up in the. So over to you, Simon.
Well, that was great overview of enterprise architect and architecture and how to become one. What do you say, Magnus?
100%. So this is a big swing to start with the enterprise level of architecture, because obviously, if you run a small startup and you're a startup architect for a small software firm, you don't have to take into account all the pieces such as physical hardware and how that works in the field and how things connect in the network and all kinds of craziness. Those are all parts of the domain of the enterprise architect, which is huge, right?
Okay.
Yep.
Yeah.
That's yeah. So yeah, next let's so every software, it's large software, and if you're playing architect role, design is very important.
Yeah.
And here we have now. You want to talk about the next session and invite Andy?
Absolutely. We will do that. Thank you very much, Naveen, for being with us. And here comes Andy. Hello, Andy. How are you?
Hey guys, can you hear me all right?
Absolutely.
Yes.
All right. It's great to be here with you
Yeah,
guys. This is
you're looking
exciting.
sharp. You're looking
Very
sharp
here.
as an architect.
Where is here?
I am right outside Philadelphia. I'm actually in my office today. I haven't been here in I guess a couple of months, but the power is out at my house because we had these big storms. So I'm actually in my office because the show must go on.
It must go on. You are correct. So we have been talking in sort of the warm-up of this when we started here about how important it is to apply good principles and practices from the beginning, because you might start small and then you're going to grow. And the goal of anyone building a system is to become hugely successful, right? But the challenge with that is to, maybe appropriate, right? Depending on what you're doing. But most of us wants to grow and gain more market and become successful with what we do. And there's a challenge in there to be able to be flexible and repurpose your application when you grow. And so that turns us to the domain of good design.
I think so. I was listening earlier and I thought it was a great point that you guys made about building things right the first time. I think it's actually really important. It's really critical. Yeah. And design is one of those things that, again, you don't want to skimp on in the beginning because it does get hard to retrofit these things back in, right? And it's like I always say, there's a lot of things you want to do on day one. I always say do DevOps on day one, right? I always say, and I heard you guys say it too, I think security on day one, right? Good design on day one. Day one's a tough day, right? Day one is not an easy day. But fitting these things in the beginning when the systems are smaller and designing them right when the systems are smaller really allows everything to grow and make it easier to maintain these systems and to extend these systems. So,
absolutely correct. So I'm excited to hear your presentation, your take on these things, and I think we're going to queue you up here. And you ready to go?
Oh, I'm ready. This is going to be great.
Yes.
All right, we are here watching it.
We are going to be here watching.
Okay.
All right.
So I guess I'll take it away now.
Yeah.
All right. So we're here to talk about design principles and standards in software architecture. And if I get my mouse set up right, let's see. Okay. So real quick, a little bit about me so you know who's talking to you. My name's Andy Schwam. I'm the AVP of Enterprise Architecture at an insurance company in the Philadelphia area. I'm a 10-time Microsoft MVP for developer technologies. I'm also a conference organizer. I organize a conference called Tech Bash. You can check it out at techbash.com. And then here's some other ways you can find me, right? On Twitter, I'm Schwami. On GitHub, you can see my repos, Schwami. LinkedIn, Andrew Schwam. I have a blog, Schwami Says. All this good stuff, right? In addition, I do live streaming Wednesdays at noon Eastern time. And that's probably some, we're an international audience here today, but noon Eastern time, you can find me on Twitch, Mixer, and YouTube, where I build software with all kinds of stuff that we're talking about here today, with good architecture practices and with DevOps and everything else, and web application design and things like that. Another shameless plug I'm going to throw in real quick is I'm also a host of the Dev Talk Show. The Dev Talk Show is also on Wednesdays at 8:30 p.m. Eastern, where Chris Gomez, Rich Ross, and myself, we talk about all kinds of things for software developers. We talk about architecture, we talk about design, we do live demos of writing code. We have guests. Mahesh was a guest recently, and that was great. We talk about all kinds of things. And so if you're really interested in like the whole spectrum of software development, it's a great show to check out. Again, on Twitch, Mixer, and YouTube / the Dev Talk Show. And that's all my plugs for myself. And now, looking forward to talking to you guys about design principles. So I want to start out by talking about why we need design principles. So spoiler alert here, really, this is the most important part of the whole thing. Understanding why is critical. Okay, there's lots of different design principles you can choose or not choose, but understanding why is a really important factor. Okay, and not only is it important that as an architect you understand why, but it's really important that you make sure your teams understand the why. Okay, because if your teams understand the why, instead of you just saying, hey, this is what you need to do, really focus on building up that understanding with them. Okay, and when they understand the why, and when everyone embraces it, you really follow these principles, you really think about these principles, and you really focus on them and take it in. So it's really important. So why? Well, building software is hard. This is not a simple thing to do. It is not a simple thing to do. And in the beginning, and we were talking about this earlier, if we don't build software correctly, we can overcomplicate it, and we can make it even harder, and we can make it even harder to work with. It's hard enough, when we do it right, let's face it. But if we start off incorrectly and we build poorly designed software, it's hard to work with, okay? Maintaining and changing poorly designed software is costly, okay? And when I say costly, I don't just mean money. I mean, yes, I mean money, but I also mean costly in terms of time and in terms of missed opportunities. If you're fixing your software, if you're spending too much time maintaining your software, you're not adding the things that the business units or the business side of the software are looking for. We're not adding new features, right? We're not giving the customers what the customers need because we're busy working on it. So building software is hard. Changing software is hard. And if we design it poorly, we have fragile code, and fragile code leads to bugs. And bugs can be costly. Again, time, money, missed opportunities, okay? And it's really important to focus on that and to embrace that and think about that. Changing bad code is really hard. We want to design quality software. And my mouse didn't switch. Here we go. Does it switch? Come on. Oh, I know why, because I had animations in here and I'm not used to having that. So it's going down the different items. Okay, so what do we want here? This is what we want to talk about. What do we want? Well, I know I want code that is less error prone. I want code that is easier to maintain. I want code that is easier to read, less breakable, more reusable, and more decoupled, right? And if we follow good design principles, we can get to this place, right? So now we understand a little bit about why, we understand about what we want to get, and we're going to talk about some design principles. First, though, I find it interesting. A lot of times we misuse terminology, right? And it's really great to have a ubiquitous language. So we're all talking about the same thing. So we're all using the same words for the same things. And sometimes design principles is one of those things where we talk about the wrong thing. Sometimes people use terms like standards or architectures or implementations and all these different words and principles sort of interchangeably. And they're not really. I mean, there are different things. So design principles are not implementations, right? And design principles are not patterns either, okay? You may use patterns to implement design principles, but design principles aren't really specific about how you achieve the goal of the principle, okay? Design principles are guidelines to have a good design. And when we look at the design principles, it will all make sense. But I will show examples of many of these of how you can achieve the goal. I might show a pattern that you might use or something like that. But the pattern is different than the principle. Okay, the principle isn't specific to how you solve the problem. Oh, and I talked through that, so there we go. Okay, there are lots of design principles. We're going to focus on a few. Now, I don't like to use the word easy and hard, but I don't have another word to replace it right now. So some of these concepts are easier to understand, and they're great for really working with your junior developers, your mid-level developers, and you really want to focus on these with people that have some less experience. Some of these design principles really take time to master, and you have to sort of study them, you have to sort of practice and work with them a while. So we're going to go through a variety of them. And the first one we're going to talk about is, again, we're starting with the ones that are somewhat easier to grasp, I think. The first one is separation of concerns. A separation of concerns pretty much says, don't mix things up. Don't mix things up that don't belong together, right? Don't mix up things that don't belong together. So what does that mean? Well, there's some examples we can use here. A simple example of separation of concerns is that the UI and the database logic should be separated. And that may seem obvious to us, but it's not always obvious. It's really easy to bleed some of these things together, believe it or not. Now, I've seen some really bad examples of what you should not do. For instance, I've seen a database where in the columns of the database where you'd expect to see just the data, there was HTML, right? Brackets, divs, and all kinds of things in there with CSS in the data. And so when you queried the data, you could easily display it in the UI because it had the UI right there. And someone thought that was a good idea at one point. The problem with that is, how do I change the data without running the risk of messing up the UI part? And how do I change the UI without really dealing with all the data? As a matter of fact, if we change the data in this case, we then have to add the UI into it right there, right? And it's really just sloppy and really just messy, right? So we don't want to do that. Another example of separation of concerns is the MVC pattern. And I'm pretty sure Joe's going to be talking about that one later today. MVC pattern is really just designed around separation of concerns. Separate the model, which is the business logic, and the data access and all that kind of stuff. The view is the UI. The controller is the, I guess you'd say like the orchestration, the sort of glue that makes it all run together that handles the requests. I'm not going to get into the details of MVC, but the point is it's a whole pattern very much focused on separation of concerns. So it's really important to look at separation of concerns. Now the next one we want to talk about is DRY. There's lots of acronyms in here. DRY stands for don't repeat yourself. Now, this one is something I think one of the few design patterns that I feel like we're taught really early on in our software development experience. Don't repeat yourself. Repeating code all over your application is problematic. Right? We know that. We don't want to change code when we want to make a change. We don't want to have to go looking in 15 different places and looking for it all over the place. It makes our applications harder to manage. And there's lots of ways to deal with DRY. Certainly we can extract code out, put it into different methods and different classes and things like that to avoid repeating it. But this is, again, is one of those ones that I think we're sort of taught early on in our software development experience. So that's a good one. Next is another acronym, YAGNI. You ain't gonna need it. Don't add complexity that you may not need to your applications, right? Skip the wouldn't it be cool features. Keep your architecture design simple. Now, this isn't as easy as it might seem, and so easily I can just state, don't add complexity that you may not need. But as architects, we have to make tough decisions. As architects, we have to make tough decisions sometimes. We know that there are more features coming down the road, and we think, well, if we're designing the first feature, if I do it in maybe a more complex way than I need today, it will support the features we need in the future. And that's sometimes a good idea and sometimes a bad idea. And so this is where experience as an architect comes in handy. You really want to focus on trying to not build things we don't need. And that sort of goes along with the MVP, minimum viable product concept, goes along with agile and all those kind of things. But we really want to be careful to not build our applications more complicated than they need to be. And that brings us to KISS. Keep it simple, stupid. Now, of course, I didn't write that acronym. I'm not calling anybody stupid except myself, because I've broken this plenty of times. Just as I've broken, by the way, I should say, there's nothing in this presentation. There are no points that I'm making here today that I haven't broken these rules in any time in my career. I have, okay? We all have, and that's okay. Becoming an architect is about growth, right? It's about learning and doing more and doing things better all the time, right? And so by no means, when you watch these presentations from myself and from the future architects that are going to speak today, don't think, well, God, these guys never made mistakes. They all know this stuff, and I don't know this stuff. Well, everyone had to learn it the first time, right? So anyway, let's get back to keep it simple, stupid. The best design is often a simple design. And just because you can make things more complicated doesn't mean you should, right? As an architect and as a developer, I'm more impressed by simple solutions. Looking at something, when someone can do something really simply, it's like, wow, that's great. You know, I wrote that with 10 lines of code, and I had this whole big thing around, and someone said, you know, there's a feature built in. All you have to do is use this one line, and beautiful, right? And that's keeping things simple and focusing on the easy ways to get things done. Now, one line of code isn't always the best way to go. And key here to think about is sometimes more lines of code is better than less lines of code. And sometimes less lines of code is better than more lines of code. You know, just because you can write a whole page as a single linked statement doesn't mean you should. All right, you really want to focus on what's going to be maintainable, what's going to be manageable, and what's going to be understandable and readable. There are all these factors that go into our code. And that brings us to dry, which is don't repeat yourself. Repeating code all over your application is problematic. And of course, repeating slides over is problematic too. And so that was my very lame sort of dad joke there that I have dry in there twice. I know. This is the kind of humor you're going to get with me today. But I hope you can hang in there and appreciate that terrible joke. So let's move on to the solid principles of object-oriented and agile design. Now, this is where I think we're stepping things up a little bit, and it does get a little bit more complicated. And by the way, I'm trying to monitor questions in case there's any. I do see some questions. You know, does that correspond to dependency separation? I don't recall when that question came in, but we're going to be talking about some of that stuff in the next couple of slides. So hopefully we get a good answer to that. And then if not, we can come back and answer that question. Okay, I am trying to monitor the questions, but it's kind of hard with all the screens. So I'm going to do my best. So these solid principles are what I would say sort of more complicated. Now, some of them are easier to grasp, and you really want to get the more junior developers on board with them early. Some of them, again, some of these are a little bit more complicated. Now, these solid principles of object-oriented and agile design, these were basically made popular and famous by Robert Morton, well known as Uncle Bob Morton. And if you're not familiar with Uncle Bob, I suggest you Google him or Bing him or whatever it is that you do and check out some of the things that he says, because he says some really good, smart stuff. He's a leader in our industry, specifically when it comes to principles and patterns and things like that. And so about the solid principles, and he didn't write each of the principles, but sort of, you know, kind of put them together into this solid principle thing. So what Uncle Bob says is poor dependency management leads to code that is hard to change, fragile, and non-reusable. Okay, and that's not what we want. Okay. Now, on the other hand, when dependencies are well managed, the code remains flexible, robust, and reusable. When the dependencies are well managed, the code remains flexible, robust, and reusable. Now that's what we said earlier. That's a lot of what we're looking for. And so these principles are things that I just focus on day in and day out when I'm writing software. I am just so in love with these solid principles. And many developers are. I really see it becoming so popular now. Dependency management is the key to a clean design. So, and every time I try to go to the next slide, it doesn't work. Here we go. The first solid, solid is an acronym, SOLID, and the first one is the single responsibility principle, which you might see referred to as SRP, another acronym. Now, the single responsibility principle says that a class should have one and only one reason to change. Think about that for a second. A class should have one and only one reason to change. Now, when I first learned the single responsibility principle, when I first heard of it, I think I took a slightly different interpretation, like many people do, that says a class should only do one thing. But that's not really what it says. Now, those two things are close, but that's not exactly the same, okay? One reason to change, okay? Because when we change code, we run the risk of breaking it, okay? When we change code, we run the risk of breaking it. And we run the risk of breaking all of the code that calls that, and it kind of cascades down. And so it is clearly simpler to have classes and methods that do one thing, okay? That do one thing. However, they should only have one reason to change. And what does that part mean? One reason to change sounds kind of tricky. Now, I will go into examples for these, and I'll show you what we mean by one reason to change. But by following the single responsibility principle, we write code that is easier to test because it only does one thing, right? And only has one reason to change. It's easier to read. It's easier to maintain. That also means we introduce less side effects. We sort of automatically get separation of concerns, right? Because the code's only doing one thing. And on top of that, one of the bonuses that I always like to mention to people is you have very little merge conflicts in source code, right? Because if you have small classes and they're only doing one thing, you don't have a lot of developers in there at the same time working on different things. So that's an added bonus. Let's take a look at the single responsibility principle, and we'll really focus on the single thing to do and the single reason to change. And so I have some samples, and it didn't go to samples. Let's see if I can get that going there. Okay. Now, just a warning about my samples here. These are not necessarily, this is not a program that compiles. These are just some samples that I have. They're C# files, and but they don't actually compile, so there might even be a mistake in there or something like that. Don't panic on that. This is not a project or a solution. My samples, and I should take a minute here to say my samples are in C#. But these design principles, all these design principles, don't just apply to C# or even just to .NET, or these can be applied across all kinds of software development. Whether you're writing JavaScript, whether you're doing different languages altogether, you can use these single responsibility principles all over the place. I try to apply them to SQL when I can, and I try to apply them all over the place. Now, I do see a question from Andrew that says, doesn't one reason to change almost mean one method per class? Almost, but we'll talk about that a little bit. I think it's a really good question, and these are some of the first questions we ask as we're learning about this. You can take it to that extreme and have one method per class, and that would be pure. I don't think we need to go that far with it. And I've even seen Uncle Bob talk about that we don't really need to. If you want to, I don't think there's anything wrong with going further to the extreme. I like to be pragmatic with how I apply these principles and how I think about them and how we apply them and how I ask teams to apply them. Because certainly having one method per class really does start to get a little crazy. But sometimes it's a great idea. Let's take a look, though, first at what is not the single responsibility. And so you can see I have this little class here called not single responsibility. These files, by the way, are in my GitHub repo. On GitHub, I'm Schwami, and you can see, I think it's called Design Principles Samples or something like that. Anyway, so this is code that looks very much like code that I've written over my career, and maybe code that you've written. And at times, I would think this was great code, you know. So I've kind of moved on, and I don't love this code so much anymore. But what happened? My light just went out. That's interesting. Let's see what happened with the light. Okay, so the first thing is I have this join method. Let's imagine this is part of a bigger application where you're trying to join, become a member of some kind of website, something like that. Now, so the method takes a username and a password. And what do I do next? And I think it's really important to see like the bad examples, and it really helps tell the tale of what we should be doing. So what do I do next? I'm going to do some validation. Now keep in mind, this validation is incredibly poor validation. It's just here for showing some examples. I don't think we would really have something that says the username must be 5 characters to be valid, but let's just play along with my silly examples here. So I'm saying that I have to have a username that's 5 characters, and the username has to be an email address, and my lame way to determine that in this simple example is, oh, hey, there's an @ symbol. It's an email address. Cool, right? And then, and this is where it gets even really bad, my password validation says that the password has to be 5 characters or more to be a valid password. Yeah, pretty lame. But that's okay. I've got validation logic in my join method, okay? And then I go in and say, let's check to see if the member already exists, okay? And maybe I call this members data access thing and find out if the user exists. And if not, you know, I move on and I add the user. And then I go on to even more, which is like, oh, let's go down here and let's build a message, an email message, and format it. Now, this isn't exactly robust formatting, but here it is. I put the text of the email message in there. I formatted it. And then I'm using this SMTP client and I'm sending it. And I think we can all agree that this class does more than one thing, right? It does more than one thing. But what about this more than one reason to change, okay? Well, I might need to change this class because we add an additional validation rule. I might, right? We may say, hey, this password protection policy is pretty weak, admittedly. So let's put some more password protection logic in here. And when we do that, I run the risk, and I really do, as much as this sort of seems like a simple example, I run the risk of breaking this application when I do that. Let's take a look at a different example. What if the marketing department comes along and says, hey, Andy, this thanks for joining message here, well, that's nice, but that's not exactly the message we want. How about we add some style in here and some colors, and we put some little bit more message in here, and we change that. And that's an important thing for the marketing department. But I come in here and I change that. And what happens when I change that is I run the risk of breaking a core feature of my application, the join method. So wouldn't it be great if I can get these things separated and split apart? That's what we're talking about with the single responsibility principle, okay? Scanning just questions here. In my opinion, contextual to what class was created. Contextual to what that class was created. Class was created. I think saying that the feature that we're trying to do should be within the context of the particular class. And so we'll talk about that. I think that's what we're going to talk about. But anyway, so let's move on to how we would fix that. Well, how would we fix that? I have another file here, basically called single responsibility. And in this case, we start out, we still need that join method, right? You have to have that. And so in this case, the join method has a single responsibility. People say, well, no, it has a bunch of responsibilities. It's doing all this stuff. And I would say, well, no, the join method here has a single responsibility, and its responsibility is to orchestrate the calling of other things. Somewhere along the line, this stuff needs to get put together. It needs to be composed into something. And so the join method might call upon a validator class, right, that has a validate method, right, and a membership service that has an add method, and a message formatter that has a format message method, etc., the notifier. And what do these look like? Now, for simplicity's sake, because I don't want to be clicking around so much during this demo, I've got these classes in here together, okay? And so in here I have a membership validator, and it has the validate user. Now I didn't put the code in here, but it's really going to be that same code, right? We could just come right back to that other class and drop that same code in here, right? It's not necessarily about writing more code. It's about moving that code around to different places, right? I might have a membership service that does the add. I might have the message formatter, and its job is to just build out that welcome message and do whatever we want to do in there. Then I might have another class that does notification. Now, let's talk again about single responsibility. This membership class has this add method. Now, we talked about, like, is it one method per class? Not necessarily. I might have a remove method in the membership service. I might have an update method in the membership service, because they definitely would still sort of have one reason to change, right? We're changing the logic around membership. It's a gray area. This is a very slippery slope. You don't want to add too much stuff because it starts to get too complicated. And when we look at the amount of dependencies we start to add, right? This single responsibility join method has a bunch of dependencies, right? And if I can keep the dependencies short and my class starts to not look too complicated, I say, well, add and remove are very similar. They're both calling the same repo, maybe, something like that, right? Well, then there's really not much difference between them, and then my risk is low. But if I start to have lots of methods in these classes, if this membership class all of a sudden becomes something that has so many things, if my message formatter class, this is a better example, maybe I have something called membership message formatting, and I put a few messages in there around formatting messages for joining and removing and stuff like that. But maybe I don't have like other things that users might get responses to. Maybe I would put those into a different formatter class. It's really up to your level of comfort and the level of complexity. And we really want to think about sort of those different things. And I'm just looking at the questions. Let's see. So the question from Tool, sometimes design patterns seem to contradict solid, while sometimes they support it. What is better in the case of conflict? I've read somewhere that no application can be fully solidified. Yeah, listen, this is a great question. And thanks for asking that question and sharing that with us. Everything, in my opinion, is about balance, right? It's about being pragmatic and not being dogmatic, right? And I'll talk about that a little later when we talk about standards. But we have to make some decisions. And this is where I say, listen, in this case, I'm willing to put a few methods in the same class together, right? But it's a feel. It's something that as an architect you grow into and you start to learn where you can slip on one principle and maybe not slip on another. Now, if we had the ultimate time and the ultimate money, we could probably get all these things perfect. But we have a lot of constraints upon us. We have pressure from business and customers that we need to get things done. And so there is a balance that we need to do. Now, Andrew also says, you would make interfaces for each and inject based on service provider configuration. So what Andrew's talking about, and we're going to come back to that, but if you look at this here, where I'm using these objects, right? I'm instantiating objects here. This is not a great design for this. This class demonstrates the single responsibility principle. We will cover what Andrew's talking about with a different principle, and we'll come back to that. I'm gonna keep going now and keep this thing moving. So let's take a look at the next principle, because this is a lot of stuff to cover here. Let's cover the open-close principle, which says that software entities, classes, modules, functions, etc., should be open for extension but closed for modification. Okay, think about that for a second. Software entities should be open for extension but closed for modification. Now, what does that mean? What that means is open for extension. We need to be able to change our classes, right? We have to make changes. We have to be able to add features. We have to change things. How can we do that in a way that's safe? We want to make our classes closed for modification. Now, of course, it's never really closed. Anybody can go in there and change it, right? But when we design it in a way where it's open for extension, we can extend the feature, we can extend the behavior of a class without going in and changing the class, okay? We have to be able to do that. Let's talk about a simple example first. Simple example might be something like a connection string. We don't hardwire, hopefully we don't hardwire our connection strings into our data access code. We put our connection string out in a config file, okay? That means that our code, our feature, or our application in some ways can change without opening up the class that uses the configuration file and modifying the class. I don't have to recompile it. I don't have to make changes to it. I can change the connection string. Now that's a simple example of the open-close principle. Let's look at a more code-based example. And I jumped to another slide, but that's okay. I'm jumping all over the place. And here we go. Let's take a look at open-closed principle. Now I'm going to start off with not open-closed principle. And if we look at this, we can look at our little validation type of thing that we had from before. I have validate user. This time it takes an account. I switched it. The account just has a username and a password. And here's that same logic we saw before, okay? Username, password, etc. And so we come along and we want to say, well, I want to add another rule. I want to add some real password validation to this, let's say, or who knows what we want to add to this. The only way I can change this now is I have to come in here and I have to make changes in here. I have to do this and I have to move things around and make changes or whatever it is I want to do. And what happens is I run risks of breaking other things, right? I don't want to break other things, right? Now, in this case, you could argue that that's not such a big deal, right? This is what we talked about at the beginning. Finding and using good design principles from day one, right? On day one, you might look at this and go, oh, come on, it's not that big a deal. I can come in here and change this. But we don't know where this application's going. We don't know how complex it's going to go. And so by following good design principles from day one, we can get this right, okay? It's also good practice to do things on the easier examples, so we're ready for the harder examples. Let's take a look at an open example of this, right? In an open example, I have this membership validator, open membership, right? And it has the same method called validate root user. But in this case, when I declare my open membership validator, when I define it, I pass in a list of rules, okay? I pass in a list of rules. And then the validate method, all it has to do is loop through each one of the rules, okay? Loop through them and call their validate method. Simple as can be, right? And here's an example of the rules. I might have an abstract class or something like that, or an interface that has a validate method. There's a lot of ways you can do this. And then I might have a username length rule, and here's that username rule. Simple as that in its own little validate method. I might have the password length rule. Same little logic in its own validate method, okay? And then all I do is when I set up my validator, I pass in the list of rules, as many as I want to do, and I can just call it. Now, if we want to change a rule, I'm open for extension. I can create as many rules as I want, and I run no risk of breaking the additional rules, the existing rules, okay? This is open for extension. And wow, it says I have 13 minutes, and I thought I had a 45-minute presentation. So we're going to rock through this stuff. I thought I had a little bit more time. Let's keep rolling here. So let's look at the Liskov substitution principle, which says that functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. Okay? Functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. Okay? You want to think about, in your inheritance model, for example, we were always told to say, use an is-a relationship. The class that I'm creating is a base class. It is one. But we really want to think about it differently. We want to think about, is it substitutable for it? Okay? And the classic example here of this is, and I'm going to move a little quicker through these, is the Liskov substitution principle here, which says we have a rectangle, which has a height and a width, and we have a square. And if I was focused on geometry, I would know that a square is a rectangle. It is, right? It is a rectangle in the world of geometry. But in terms of software, it is not. Because I might call down to here and say, right, if I inherit rectangle into square, I can set the height and I can set the width. And quite frankly, this just introduces problems. Could it work? Yeah. You could be careful and you could set the height to be 100 and you could set the width to be 100. There's a lot of ways you can sort of fake your way into making this right. But the bottom line is it's not right. I can't use a square in the same way I could use a rectangle. So that's a quick one. I'm going to move past that and keep going because that's you know, I can sort of move on from that easy one there. Next is the interface segregation principle, and I think I can do this one pretty quickly too. Clients should not be forced to depend upon interfaces that they don't need, okay, that they don't use. What does that mean? Clients should not be forced to depend upon interfaces that they don't use. When we build our interfaces, here's an example of one, okay? I might have like a generic repository, and I have this iRepository interface that my repository is going to implement. And if I build out my interface, I might have things like a find method, right? I might have a get method, and I might have an add, update, and delete method. Okay, sure. And I've written repositories like that many times with interfaces like that. But then you go and you say, hey, but some of the teams that are using that repository, they are read-only, right? They don't even change the data. So why should they have to implement iRepository when they don't need add, update, or delete? So what if we have an iRead-only repository, which has the find and the get? Okay, and you could break this down even more. You could have a find, iFind. You could have an iGet if you want. There's a lot of ways you can break these things down, right? But I'm showing a good example here. And then I might have this writable repository, and that one has add, update, or delete. Now, if I wanted to, and I don't have to, I could even say that the iWritable repository implements the read-only repository, because usually when you do writing, you're also doing reading. But you don't have to. I could take that off and then say you could do them any way you want, right? There's a lot of ways you could put this stuff together and compose these things. That is a quick example of the interface segregation principle. And last of the solid principles is the D, right? Where it's solid, the dependency inversion principle. And this dependency inversion principle says that high-level modules should not depend on low-level modules. Both should depend on abstractions. And it says abstractions should not depend on details. Details should depend on abstractions. Okay, so let's take a look at that, right? What that really means is we want to put the abstraction in the middle. If I look at my examples here, I have this earlier, where am I here? Dependency inversion. Earlier here, we had this join method that had these dependencies, okay? Now, in these cases, I'm implementing this class, this join method in this class, with a hard dependency on the membership validator, on all these things, on the message formatter, on the notification notifier. Why is that a problem? Well, the notifier may have a dependency on something like SMTP mail, right? My membership service may have a dependency on entity framework or something like that, right? Because this is hard-coded. This is the way it's built. But if I want to have a way that I can, the problem with this now is if I change any of these things, I have to recompile everything, right? And then maybe in a perfect world, we take these membership validators and these services and all these things and not only put them in different classes, but put them into different projects. Now, we put them in different projects, they get compiled separately. So let's say I take the interfaces of all these things and I put them in their own DLL, and I put the implementation in separate DLLs. And now this implementation of this join method uses the interfaces. And now it's sort of like the interfaces in the middle. So here's my membership validator, my membership service, etc. We go down a line. And here's my version of join using dependency inversion. In this case, it's using interfaces, okay? And this project, the thing that my class here is in, doesn't care if I recompile or change the implementation of my SMTP mail to some other type of mail, whatever it is, it doesn't care about that because I put the interface in the middle. And those are the solid principles, very quick at the end. And I hope I have a couple minutes here to talk very briefly about standards. And I can do this really quickly. Naveen earlier was talking about the role of an architect and how important standards are. It's really important to have standards to help solve problems, to help with collaboration. When you have great standards, and we're sort of shifting gears here, although following good design principles can be one of your standards. The standards are great. It gives developers things to work on when they're doing code reviews. It gives them like sort of a framework for code reviews and things like that. It can be super helpful for collaboration and team flexibility and onboarding. If you have a standards and you can hand a document to someone or point them in the right direction of the standards, then it's easy for onboarding, and it's great for saying, hey, we need some help on team A over here. Can somebody from team B come over? They're going to be able to look at that code within certain aspects of it, not crazy, but they can look at aspects of that and say, yeah, I'm comfortable in this place because we have good standards. And the code looks similar, okay? It looks similar. So I said earlier, be pragmatic. Don't be dogmatic, okay? Think about standards that are reasonable for your developers. Don't be an ivory tower architect. Don't be up there saying, oh, all developers, you must do it in such a way, right? Explain to them why, right? Find standards that help them do their jobs and that make their jobs easier for them, and give them the room to be able to be creative still, right? And don't come up with principles, standards that are so rich and so hard that there's no room for flexibility, okay? And I'm gonna go right down this one. And also important to know your team, right? What do they need? What kind of help do they need? What will get in the way? Leave room for improvisation and innovation. And remember, what would you want if you were the developer? Would you want the architect telling you how to write every line of code? Absolutely not. I know I would, right? I want to have standards that make sense. And you also want to think about how you would enforce your standards, but we're going to skip that. We're going to come to a couple quick examples, and I'm going to go through these, right? We have samples. Here's an example of a standard that we have, right? We don't say you have to write every line of code. We have some naming conventions. We have policies that say you must have code reviews. You must do, you might want to have solution project organizations. We're going to use a certain folder structure for how we organize our files. That makes it really easy for when developers are swapping teams to come in and go, oh, I know where that stuff's going to be. I understand that. You might have a standard for logging, right? That's an important standard. I'm not telling you how to write every line of code, but I'm saying you need to log your exceptions into a central repository where we can find that information later, okay? And then here's an example, a specific example of how I would write a standard. And I want you to just show, and this will be where I'll wrap up the standards. This will show sort of flexible approach and the way we try to approach it. We say, and this is down here at the bottom, for data access, we will use an ORM as a first choice. As a first choice. I don't say you have to use an ORM, because if I do that, developers will come to me and say, yeah, but it's too slow. I have to use a stored procedure for something, and we have a standard that says I have to use an ORM. And my standard says, use an ORM as a first choice. And this is a standard that works for my team, knowing the kind of code we write. It might not work for you. Don't use a standard because Andy says to use a standard. Use a standard, find a standard that works for you. We say use an ORM as a first choice. And then, if for some reason that's not working, go to the stored procedure, right? Maybe you need to do bulk inserts or something like that. That's where a stored procedure would be much better than an ORM, okay? And then the next line says, when using an ORM, your first choice will be entity framework. We choose a framework like that because our developers are familiar with it. Sure, some developers may know other ORMs and they may like another ORM. But what I say to them is, it's just not that big enough a reason to allow people to just use whatever ORM they want. The ORMs are generally pretty good. Entity Framework's a good ORM. And I need that ability to be able to have people come on and learn quickly. And if they have to keep learning new ORMs all the time, it adds complexity. So again, I'm choosing libraries, I'm choosing frameworks as part of my standards, okay? And again, it says first choice entity framework. It means if there's a reason, if there's a real good reason why you can't use it, come to me, let's talk about it. Let's use the other one. And now, I think that brings me back to just that wrap-up slide. I don't know if we're going to talk or not, but this is just in case people want to remember how to contact me. Thank you. Sorry I was going really fast at the end. I think we're a little short on time. But I see Magnus joining in. Hello, Magnus. I see Mahesh. Mahesh is on mute. Thanks. I hope that was fun. I hope you enjoyed that. I had a good time.
Wow. It was
That
really
was
fun.
great.
I wish we could spend a week just listening to you talk, because that would be, it would require a week. You covered so much ground in such a short time. And so thank you for that effort. That was absolutely amazing.
Well, my wife would disagree with having to listen to me speak for a week, but I appreciate your thoughts, Magnus.
Definitely, it was great, very entertaining. Definitely loved, simple, keep it simple. And as an an architect, you need to make sure you listen to your team. That's very important, because there's so many things out there, and if we are just closed-minded in our own ways, we just don't innovate. Very well done.
Yeah. And I was specifically also touched by the dry principle. That one is one of the biggest violators in any code base, that people keep copying things around and not really thinking about what they need to maintain when they do. Like, oh, that piece worked over there, let me copy that over.
Right. And on day one, you talk about having those design principles on day one. On day one, you wrote some simple code. And on day two, you said, you know what? I just want to get some stuff done. I'm going to copy that code from day one and just put it over here for now. I'll come back and refactor it later. How many times have you heard that? I'll come back and refactor it later.
Later never happens. Tomorrow. Coincidentally, tomorrow is actually when I'm hitting the gym as well.
Yes, me too. I'll see you there. Yes.
Yeah, right? Tomorrow.
Exactly.
Very nice. Well, thank you so much for being with us. That was excellent. You're going to come back for the panel with us?
I will be. I'm not sure with the time off the top of my head, but I will be at the panel. I'm looking forward to talking. I'm looking forward to listening to what these other great speakers have. Architecture is there's so many aspects of it that I know I will be learning stuff today as well.
Yeah.
We're never done learning.
100%. So we started out here with talking about design with you now, and we're going to take this design and then move it into a more practical deliverable, if you will. We're going to thank you again for speaking with us here today, and we're going to move over to Joe.
Yeah, we'll see you at the panel. There's a lot of questions came out from your session.
That's right. I'm listening to Joe.
Yeah. And so now we move over to our good friend Joe, and he's joining us there. Wow, you look spacey.
Welcome, Joe. You look nice and ready to go.
Yes, I'm always ready to go.
Yeah.
Awesome. Joe,
Being
where
very
are
practical
you?
right
Where
now
are
for
you
the
located
Magnus.
today, Joe?
What was that?
Where are you located today?
I am in my home office in Chandler, Arizona. It is a city just outside of Phoenix on the southwest portion of the U.S.
How are things? Weather good?
Depends on your definition of good. We are in our hot season right now, which means we are averaging around 110 degrees, which I think is around 31-ish Celsius. Or
so it's hot, but it's not India summertime hot.
It's not summertime. We don't have the humidity, so it's not like you go outside and sweat. Like there's a big difference between New Orleans and us, and we don't. It's still hot. No matter how you say it, it's hot. The old adage is open up a oven, stick your head in it, and that's what Phoenix feels like in the summer. Okay.
And you guys keeping safe? Everything is good in your region?
Phoenix is a very spread out city, so we haven't had a lot. We didn't have a lot on the initial impact because we're so spread out, where cities like New York, Philly are so compact that there's a good chance of it. We are way low on the scale for incidences. We're getting a little bit higher now because the testing has increased, and we opened back up early May. And then in the last 2 weeks, pretty much everything is open with social distancing, obviously.
Of course.
I myself really haven't been out I think since this all started in March.
Yeah.
Same way. Yeah.
Okay. So you are going to talk to us today about application and web application architecture.
Yep, I am. That's what they tell me.
And this is something that you do on a daily basis?
Yes and no. I used to be a software architect for my team for a good 4 or 5 years. Now I lead 3 different teams, but I still dabble in the software architecture. Plus, speaking at conferences and stuff on these topics. But for the most part, it's not my day-to-day responsibility anymore. Although I'm super passionate about it. If you ask my architect on the team.
But you do lead your architects, right?
Yes.
You do lead your architects. So.
Yes. In our organization, I lead the architect as well as 3 other teams, but the architect reports directly to me, who I believe is actually watching the stream right now.
Awesome.
So I got to be careful what I say.
You got to be careful what you say now. All right, then. So we are queued up and ready, I suppose. Are you ready?
I am ready.
All right. It's all you.
I don't know why the toolbar is showing in my Mac, but oh well. So, hi, my name is Joe Guadagno. I am a director at Quicken Loans. You can, that looks really weird. Oh. See, trying a green screen behind just to see how it looks with this software. I am a director at Quicken Loans. I lead 3 different teams there that help with the mortgage process. You can find me on social media at any one of these points at J Guadagno, Joseph Guadagno Net on Facebook, LinkedIn at Joseph Guadagno, or if you want more on any of these topics or anything I blog about, go to jjg.me/aboutjjg, or it's essentially my full name .net. So I expect a whole bunch of followers and Facebook requests after this as usual. So, if we look at the overall set of events so far, we started off with a great introduction on what an architect is. And there's many differences around what an architect is, and every organization has a different opinion, and there's different types of architects, which we've kind of seen. We talked about enterprise architects, and then some solution architects and technical architects. Then Andy went and took it to the next level and talked about some principles. Principles are general guidance around it. I'm going to sit here today, or stand where I'm standing right now, and talk about patterns. These are ways that you can implement some of the principles that Andy talked about. And these patterns work with web, non-web, and pretty much life in some way, shape, or form. And it's really distinct. One thing I want to point out with this is that these patterns and principles that we've talked about so far today are our versions of them. One of the things I've learned in the 2 years I've been in software development, multiply that by 20 or 10, every place is different and every person has their own opinion. One of the things Andy said a lot in his was, this is how I do it. This is how our team does it. And that's an important aspect of it. If you look at the overall principles, they are principles. They're not directives. They're not mandates. These are principles, guidelines, I like to say a lot with it. The same thing holds true for patterns. Patterns in software development help you out in several different ways. And I got to move one of my screens over a little bit. They help you out by putting together the building blocks. So when Mahesh and Magnus started talking, they talked about how we build a house. Software is like building a house. You start off with a foundation, which are the principles or the guidelines to it, and then patterns for building the house. What do you do? How do you do it? Do you put the concrete first for the foundation? You put up the studs next. Do you put up the plumbing? The order of things and how you do it matters to make it repeatable. The reason why you make it repeatable is so that you don't make mistakes that you might have made in the previous. So we're going to cover some of the most common patterns that are used. Again, a lot of these are my viewpoint. Your mileage may vary. But the primary purpose of a pattern is the age-old adage of don't reinvent the wheel. Patterns exist to help you create and redo things over and over again, so you're not making the same mistakes. So let's take a look at some of them. The first one that you see is the commonly referred to as the layered approach, or multi-tier / 3-tier / n-tier. There are lots of different names. I know back about 20 years ago, we talked about how everything had to be n-tiered or 3 tiers. And this is the common breakdown for it. You have your presentation layer on top, and this is your mobile applications, web applications. These things talk to a logical tier. The logical tier is where all your actual work happens. Things like how to place an order, how to ship an order, how to deduct items from the inventory. And this layer talks to the data layer, which is, okay, now I got my inventory. Where do I save all this stuff? How do I check my inventory, etc.? One of the things I want to clarify with this is that there's a difference between tier and layer. A tier is typically designed for the actual implementation. So data tier typically has to do with, the database, the storage, where logical tier has to do with the business rules. Layers can be a lot more than that. You can have more layers that sit in there. So from a logical tier, you can have one layer that handles all the requests coming in, that does things like validation, things like that, that hands it off ultimately to another layer that goes and does the actual processing of it. So it's an important distinction. They get confused a lot between themselves, but they're really not that different in most cases. Some of the advantages of using this approach for it is it really helps with the first of the solid principle, or not really first of the solid principles, but the separation of concerns. Separating out your presentation so that you can handle your user interface. The deadly question of what about handling logic in stored procedures. I'll get to that in a little bit. That's the age-old debate. As long as I've been doing software development for 25 years, where do you put it? I'll cover a little bit of that in the event sourcing portion of this. You have the ability to minimize your dependencies. So as you start pulling out the layers of the onion, they're less dependent on each other. It makes development a little bit easier because people are used to it. It's been around and commonly used for at least 20 some odd years that I know about. Also makes your application a lot more testable, meaning that you can with the pieces separated, like if Andy's demo where you had the validator, you can test out the validator separate from the piece that actually goes to the database and saves it. And then it's reusable. This logical tier, the data tier, can be propagated to other applications without having to worry about the presentation model. There are some disadvantages to it too. It's like the changes that happen. Let's say you decide you want to add a new column. You have for a person, you have first name, last name, and date of birth. But you decided, since it's an ordering system, you want to know their anniversaries so that you can send them a happy anniversary message. You have to go and make modifications all the way up to all the different tiers. So your presentation has to have a new field, the logical tier has to have a new field, and the data tier in most cases. This also leads itself generally to having to write more code because you separate it out, which is going to be a common theme throughout lots of these patterns. And then you have the age-old debate that came up with one of the questions: where does the code go? Do I put my business logic in a stored procedure? Do I put validation in the presentation tier? Does it go in the logical tier? Where does it all go? I say it really depends. Like Andy said, it's up to you and your organization. For me, I prefer to not have any database, or sorry, any business logic in the database. And I use the word prefer on purpose. Like Andy said, we prefer to use an ORM than store procedure. Sometimes it makes sense to do things in a store procedure, especially if you're doing multiple joins, multiple queries, summarization, it makes sense. Same thing with the presentation layer. With validation, it makes sense to put the validation in the in the presentation layer. It also makes sense for it to be in the logical layer because you don't know how the data is coming in. So you stop it at both places. And yes, it violates the dry principle to some extent, but in each different layer, there's different sets of data coming through. Plus, there's also different ways to handle that data. In a presentation layer, you might want to have a drop-down list to choose a state you're from or a country you're from. Whereas in a logic layer, you don't have that. You just want to say what, just validate that it's a real country. So again, it depends on your preference. Next up is the model view star. And the reason why it's a star is because there's really three patterns here that are commonly used depending on the implementation and the framework you're using. The most common one, which Andy used and stole my thunder for, thank you, Andy, is the model view controller pattern. And it's kind of highlighted here. The idea is you have this model which sits on top. The model describes your data. So we sit in the order concept, has your order details, products, that kind of stuff. We get a list of orders from our controller, which is this guy here. Our controller sends the model upwards. That model goes to the view. The view then takes it and the user sees it. User does certain things to the model, like adds an item to it, creates it. It goes back to the controller. And then the cycle keeps going. So the controller itself has all the brains of it, what to do, how to do it, knows how to go to database, how to validate it, how to pull records. The model is just concerned with its models. So if we go to the person that ordered, first name, last name, date of birth, does the validation for that. The view says, I know how to handle this model and display it. And then the user is just there to, interact with it. Some of the advantages of the model view controller are more so to testability is probably one of the biggest. The view part becomes very helpful if you're in a larger organization and you have people that specialize in user interfaces, where you might have a person, like Andy mentioned, with the marketing department that is really good at CSS or understanding design patterns. And I'm talking design as in user interface design, where they can go and design an application that is user friendly. Because to be honest with you, most engineers that are quote unquote full stack are not great at design. We can get by our toolkits, whether you have .NET or Java, have some good out of the box stuff. But, for most of us, Battleship Gray is our default theme. One other advantage of it is that the presentation becomes more reusable. you can take out those views and have different vantage points of them, or different versions of the view, as well as be able to test out the views, test out your business logic layer, aka controller, test out the models a lot easier. There are two different variations of this. The presenter model, so let me clear this screen out. Where's my escape key? I don't have my escape key. Or I can just hit forward. My PowerPoint skills are failing. I will just, no, I don't want to end show. Sorry about that. I broke PowerPoint. Let me restart it. I shouldn't have done the annotations part because I knew I was going to get it messed up. So the presenter part, or the model view presenter, really follows the model view controller. The only real difference is the presenter, replace the controller with the presenter, and the presenter piece handles the interaction between the view and the model and the user. There's some other smaller variations of it, but that's the overall gist of it. And then you get the model view model, or commonly referred to as MVVM. Same principle. You have your view, you have your model, and then you have the view model, which does all the interactions. So it just depends on the framework. I know if you do a lot of Xamarin or a lot of WPF, Windows Forms, the MVVM model is super, or pattern is super popular in that. Then move over to our next pattern, which is event-driven, commonly referred to as event sourcing, publish, subscribe. Names vary depending on who you talk to, but I'll use the event-driven. The event-driven takes everything as an event. So your code does something based on a given thing that happened in your environment. So as the sample shows you on the right, when an order is placed, I do something. So we trigger an order place event, which goes out and charges my account, does an inventory check, not necessarily in this order, make sure that the item's there in the inventory, then goes and deducts the item from it. Once it deducts the item from it, that may in turn trigger another event called the order ready. Now that the order is ready, I know I need to ship the package, then update the order. The event-driven model is really helpful when you have larger systems that are a little bit more complex. This allows you, and this is commonly used for order processing systems or anything where you have a lot of transactions. You know, if you think of it, when you place an order on Amazon, Target, Walmart, you name it, when an order happens, there's so much that happens behind the scenes. You know, we go and make sure that the product is there. We check for shipping. How quick can that product get to you? We deduct it. We have to charge a credit card. We have to make sure the credit card is charged before it comes back. Here's where the event system comes in. We're going to talk about how that plays into the next pattern. But one of the things I talk about a lot is that you'll see a lot of these patterns throughout everyday life, for that matter. You know, think of a phone call, for that matter. When a phone rings, I know most of you young kids don't use phones anymore, you text, but when you get a text message that comes in, your device beeps. That's an event. Something happened, which triggers a response from you to go and grab your phone and look at it. We use this pattern a lot just in software development and in life. And there's many different ways to implement this pattern. Usually you hear the most common implementations are using message queues or message topics, things like Azure messaging, Azure Service Bus, Azure Event Hubs, or if you're an Amazon person, their simple notification service, the simple queuing service, event bridges, or IBM MSMQ. There's lots of different implementations about it. Messaging has been around for quite some time. With the advent of the messaging, we have kind of a piggybacking pattern called CQRS. And I know this interface doesn't really match the color scheme of the rest, but the next two slides was really challenging to get in that small space everything that was needed. So CQRS, or referred to as the command query responsibility segregation, in a nutshell, the pattern has us separating out actions versus querying. So if we go back to our order system, the fact of going through and creating an order, which is a command, should be different from going through and reporting on how many orders do I have, how many things like that. So separating out the two. Common pattern for this is a reporting database. If you have a high transaction system, a lot of times the system that's writing out to the data store is very different from the system that's reading it. And a lot of times you have a replication database set up where you're writing, I got to imagine it's something like an Amazon, they're writing out records, millions and millions at a time to a database, but someone that's looking for inventory reports or seeing what the sales threshold was for the day is pulling that data out from a separate repository. And that's a good use of the CQRS pattern. Have your commands separate from your queries. And you can see that on the diagram. If you look at the user interface, starting at the very top with the yellow, we go through the command bus. So in that order of Amazon, the create order. The command handler says, okay, create order. I need to go to charge the account, check the inventory, go through all those lists. And it's not just one item. Usually one command will fire off more than one command. So if you think about it from the event-driven, when we placed an order, we did an account charge, an inventory check, a deduction. In the event-driven pattern, these are different events. In the CQRS, these become commands. So we have an order place command, which then creates a account charge command, an inventory check, etc. So it's often that these kind of get a little mixed together, which we'll see in a slide or two. And then those commands do stuff with the different domain models, you know, the customer contact, the order, etc. And then come back to the event database. And then on the side of that, we have the event bus, which is writing off these events that are happening. And these events are typically database updates, things like that, to something else that sits in the query part. So we go down the right side of it, which I think is your left side on the screen. When we're looking for orders or status of an order, we're actually not doing the commands, which is this side. We're going down the pipeline and creating a query, going off to the data, reading the data. Another good way of looking at this is when you're on Facebook or even this chat thing. When you're sending a chat on this stream, it's not necessarily writing it off to a database. Once it's in the database, going out and broadcasting it, it's sending an event. It's sending an event off to some backend system that says, hey, there was an event that happened. Someone created a comment. That comment then goes out to a database. So a command handler is writing it off. At the same time, something else is saying, hey, publish this content for everyone to see. So there are some advantages and disadvantages to this particular pattern. It allows you to handle very complex applications. Again, you go back to that ordering system, where if you're doing a basic console app, this is way overkill. Even some standard basic CRUD applitions, create, read, update, delete. If you're not doing a lot of high volume, it doesn't really pay for this. It can dramatically improve performance, especially if you're just farming out or shipping off some of that content to others to use. It also makes security a lot easier, and the way it does that is separating some of the concerns. You have people that can query, people that can write. Most people don't need write ability. It's usually a system that needs the write ability. But it also has some pretty big disadvantages. Can be overkill, like I said, for a basic CRUD application. For those who don't know, CRUD is create, read, update, delete. So your basic like contact application. The data itself can run stale. So if you think about it, if your system is not designed, everything that appears on the left of this diagram, the command side, depending on how often it writes in that repository, the darker blue is synchronizing with the event bus, that data can become stale. So you have to weigh those balances. And how you synchronize that data becomes a challenge. You have to weigh the pros and cons of how often you want to synchronize it. How quickly does that comment need to show up on a screen, or how quickly does it need to show up on some report? In the real world, quote unquote, whatever that may be, you see the event-driven or event sourcing and CQRS patterns combined a lot. On this diagram, you'll see on the left-hand side where it says event store. A lot of the times, I should have actually flipped this diagram over, but from the bottom up this time, you have our client sending requests, and that request is going to the command handlers to generate it. So the event to create the command to create an order is going up on the left-hand side. The repository is then going off to the event bus, similar to what I said earlier. And then those different events are triggering the storage of those, where another user can come and query out those items. So you'll see this pattern mix a lot interchangeably. The next pattern up we talk about is the plugin, or if you're doing operating systems, the microkernel approach. Think of the plugin approach as you build out your application, the center ball, and your application has multiple pieces that plug into it or are part of it. You have an order component, you have an account component, an inventory component, and a shipping component. It goes towards Andy's example with the join the group. There are 4 different things to the group. He essentially created plugins for each of those. But this plugin is a little bit different. This one is actually adding in individual pieces. So if you use Microsoft Outlook or Teams, or most major applications have some kind of plugin infrastructure to it to add in the latest gifts. If you have Slack, you have the ability to add in something from Jiffy. You have the ability to add in your Git notifications via plugins. This is a very common pattern when you are building an application that you are selling. Think of Visual Studio for that matter. Visual Studio is one gigantic plugin container. Every little facet of Visual Studio, from the Solution Explorer to the Git integration, is a plugin. There's a reason why it's a 5 gig download, because it's downloading thousands of plugins to go across. One of the biggest plugin ecosystems that you use on a daily basis is the operating system. The operating system is not just one gigantic code base, but one small code base that runs multiple plugins all throughout. You have your device, your individual devices. Each device is a plugin or an adapter to it. Another common example for this is a task scheduler. You want to, at every hour, you want to run this particular thing. Well, that particular thing is a plugin. Things like Azure Flow or Microsoft Office Flow help you with that, and Lambdas help you with that a lot too. So plugins are generally used when you are building an application that you want to have extended, and usually extended by someone that does not have access to the code base, meaning I'm publishing this out for a third party use like Visual Studio, and then others can improve it. Whereas when you're writing stuff in-house, you typically don't use the plugin pattern because you can modify the code. But if you know things are going to be changing, plugin pattern works really well for you to be able to provide certain functionality to your system across the board. So like maybe an admin module that you can plug in and it gives you different rights in the screen. Those are different ways to use the plugin pattern. Now we're going to step into probably two of the most common modern plugins or common modern patterns that we use. First one is the service-oriented pattern, aka SOA, aka microservices, aka any new buzzword in the last 5-10 years. The concept behind service-oriented architecture is just that, it's service-oriented. So if you take our inventory or our ordering system that we've been talking about, you have this listed as Acme widgets. Acme widgets has the ability to provide off those services. It has an account service, an inventory service, a shipping service, an order service. These are total of 4 different services. They're all independent from each other. They don't know about the next service. And then the Acme widget says, well, when I need to place an order, I need to go and call the account service to see if the person's in good standing, if I can charge the account. Then I need to go and call the inventory service to see if they have any of the products in shop. Once they do, I then need to call the shipping service. Say, okay, go and ship these items. Now that it's there, I can update the order by calling the order service and says, yes, your order is there and ready to go. So what makes this pattern so appealing is that each of these small pieces are not necessarily small. In this particular example, we'll use small. Each of these are independent services and capabilities that allow you to segregate out the responsibilities. I just want to do account servicing. I want to be able to check up who a person is, charge cards for them, generate reports on that particular person. The inventory service is just responsible for removing items from inventory, checking the stock of inventory, validating whether something is there or not. Same thing with the shipping service. So now we're starting to peel apart an application in order to make the smaller, more fine-grained implementation details around it. So how we go about creating an account service. This allows you to also start breaking down your application, but also breaking down your teams. I work for a very large mortgage company. Andy works for a very large insurance company. I'm sure there is not one developer that knows the entire ecosystem of everything that happens. This allows us to create specialties or sub-teams within an overall larger team to break down applications and have a single responsibility. Within our organization, we're not giving you a lot of details into how we're broken up. We follow something called the release train model, which is very similar to service-oriented. We took our technology team and split it up. We have 2,400 people in technology, and we split them up based on how they do things. So in most organizations, you have a security team, you have a support team, you have an engineering team, and so on and so forth. We have that separation, but then even inside of that, for our engineering team, we split up our engineering team into 42 sub-teams. That allows us to really specialize on something. Like I focus my team on everything that are related to fees. Other teams are focused on just the documentation, how we provide documents to clients. Other teams are focused on the user interface. So not only can you do service-oriented within software, but it's also possible within an organization. And if you think about it, your house is very service-oriented. You have a group that manages the water for your house, or at least in Arizona and most of the US you do. You have a separate group that handles your electricity, a separate group that handles property taxes, a separate group that handles utilities like gas and electric. So we've broken out, the world, so to speak, in service oriented. So it's super common to see that in software nowadays, and things like Azure and AWS and Google Cloud make it really easy for us to do that. Speaking of Azure, Google Cloud, and AWS brings us up to our next pattern, which is all the buzz right now, serverless, aka the cloud, aka not on my PC. And I think the not on my PC is really the important part of this overall concept. And the idea is that this is running on someone else's machine, not the admin for the CEO, not hopefully underneath your desk, which has happened in the past, but there's someone else managing the server. In a lot of organizations, you have a data center. It's very common with serverless, where it's there, and someone else is taking the load of managing the operating system updates, security patches, making sure the network cables are there, et cetera, et cetera. This takes it one step further. So with the concept of serverless, you'll hear things like function as a service, software as a service, et cetera. They're really not servers themselves. They're mini processes. If you think about these service-oriented, these are individual entities that we have listed. In the serverless world, these are individual functional programs that are running. In the AWS world, they have Lambdas. Google has Cloud Functions. Azure has Azure Functions. These are sections of code that are running and just running one thing and one thing not only. So if you think about Andy's example where he did validation, have one little thing running validation, one thing running emails, one thing running notifications. This is where the serverless comes into breaking out your application into smaller individual pieces so that they can handle the load, and it takes it out of your application. This requires a lot of forethinking about how you're going to do it. If you think about going back to here, each of these different services can be their own serverless implementation. You can have an account service endpoint that is serverless, meaning it's just running in a Lambda to handle the request, and then the back end goes through and handles everything else. So with that being said, a lot of these patterns are here to help guide us in software development, kind of help us rebuild things in a repeatable way so that we are not reinventing the wheel, like I said earlier. But with that in mind, you look at your toolbox, and there's an age-old saying in the software industry, if the only tool you have is a hammer, you tend to see everything as a nail. So the reason why I gave you, I think it's 12 different patterns here, is there isn't a one-size-fits-all with software patterns. Just like there isn't a one-size-fits-all for principles. You have to do the collection of them. Sometimes your application might make sense to just be model view, but other times the CQRS pattern might make sense. The understanding is to create something put in your toolbox something other than that hammer. Put a screwdriver in there, put a saw in there, put a wrench in there, put all these different design patterns. And I know I described them in 5 minutes or less in most cases, but it's a good starting point for you to understand what you have across the board to see how you can use and what makes sense to apply to solve your problem. Because if you think about it, hammering in a nail, the hammer is a solution to the problem because you don't really want to push that nail in with your finger, but having the right tools in front of you helps you to solve the problem of what software is trying to solve, which is typically a problem. With that being said, I am ready for questions, and I don't know if we are doing questions or saving them for the end. So let me pull up my screen. I see one in there from a tool. I should probably hide that. And no one cares that I have bill pay today or tomorrow. Let's pull up this slide. How does MVVM compare to MVC? I'll leave all this up here so we can see. Since that one was brought up, I'll bring up this slide to kind of show it. I don't know why I have two slide decks, but essentially MVVM and MVC are very similar. The only details are really different is the controller part and the view model part. MVVM is used a lot in systems that are self-contained. And what I mean by self-contained, they're typically things like phones, or when you're concentrating mostly on the user interface, where the model view controller portion is usually done for applications that are spread out where you want to have different things about it. So one way I like to look at it is the MVVM model could be used for building out the mobile app. So if we go back to our ordering application, we might have a mobile app. So Amazon has an app that works on an Android and an iOS device. Inside that application, they're probably following the MVVM pattern where their view model is going out and pulling the data back from the physical backend repository, where that backend repository is the model view controller, which is saying, okay, I'm going out getting that service, and I'm going to return this model via a view to the mobile application. But that same view can also be done on the web application for if you're in a browser or not. I think there was another question around, let's end the show. Is it necessary to have domain-driven design for CQRS? Can CQRS be applied to simple 3-layered application? Can I apply event sourcing to my 3-layered application? Wow, that was a lot of questions all in one question. The nutshell is yes. Again, like I said, a lot of these are individual patterns and preferences. They're not hardcore solutions. So if you look at the example I gave originally with an order, especially with CQS, you can say that I want my events to trigger a certain action. So if we looked here, we have a indication that our orders placed is the actual event, then it goes back out to do it. So when we are calling here, we see our user interface can set a command to go and call the command handlers and go all the way down while still keeping this out. So from the 3-tiered spot, if you look at this diagram here, everything in yellow is the tier 1 or the first layer, the presentation layer. Everything from the command handler domain is the middle tier or the logic layer, business layer, service layer, whatever your term is. And then the last is the repository layer. And this uses events all together. So like I was saying, and not every nail needs a hammer. You can actually mix and match a lot of these patterns. You also asked the question of how SOA is different from microservices. They're interchangeable. Microservices is just trying to get it to a lot smaller content within your application. And I see Magnus.
Yes.
Is
Hello.
here.
We are here. You continue your questions.
Yeah, go ahead.
They're not my questions; they're the user questions.
Yeah,
I have no questions. I know all my content.
You got a lot of questions because you put so many patterns in there that a lot of people went crazy on the questions, that's a good thing.
Yeah, when I went to full screen with PowerPoint, I lost all the questions, so I couldn't see them all.
Of course, yeah. No, we could. I'm sure we could spend a couple of more hours just talking, just hashing this out, endlessly. We need some form of beverage to do that, I'm sure. So,
can I apply the event-driven pattern and domain-driven design? Yeah, I think I just answered that with the last question.
Yeah.
I will put these slides up on.
Take one more question up.
CQR, I hate the CQRS. The query here is only for fetching information or kind of post data as well. You typically don't want to post. That's why it's command, query, and read is the R part of it. That's usually only for the querying. If you want to post any data, you usually should have a command for that so the proper events can fire throughout. And I will post these on my blog at some point, and they'll be in the GitHub repo. But I have all my.
That one is a very interesting technique. In the scenario where it applies, it can do a lot of fun things. It can really help you scale your application and so forth using that particular pattern.
Yep.
Okay, so thank you so much for being with us. That was a lot to take in, and that's the intent, because there is so much to uncover in this field. And I saw from people in the questions that they were like wide-eyed, doe-eyed people listening to you.
Good, I hope.
Yeah, no, it is great. Are you going to stick around for the panel a little bit?
Yeah, I'll be watching that day, and so
Okay,
I'll be
good.
here.
Well, we're gonna continue. We're gonna squeeze in one more topic before the panel, and so now we're off to Cloudland.
Yeah, let's. So it looks like we covered good things. We covered, enterprise architecture. We covered, design patterns, principles, and now let's move to cloud and welcome Vishwas. Vishwas, go ahead, Magnus. That's you first.
Yeah, absolutely. So this land is now we're in my territory. I tend to build cloud applications these days. It's why my customers call on me. And in this space now, it's very interesting. I'll be interested to hear Vishwas as well to comment. But what I have seen currently in this everybody's working from home scenario is that cloud is one field which is perfectly suited for remote work because it's remote by design. And therefore, people who work on those kinds of projects tend to, it's no biggie to work from home because and anything you connect to is going to be remote in the cloud anyway. There's not going to be any shut-in systems like that. You can reach them from anywhere. And that doesn't sound exactly secure when I mention it that way, but it actually is. But the point is that in this pandemic time and everybody's working from home, I have not seen any dip at all in the business that is coming in. Currently, I'm still having more requests for my presence than I can handle, which is a nice problem to have. I don't know if you agree, Vishwas, that this field, there's a lack of expertise in this field, right? There's definitely room for more architects and more people to work in this field because there's currently a big demand and few experts to be had.
That's right.
Yeah,
I agree with you, Magnus, that this difficult situation that we are in,
yeah,
and the people who invested into the cloud in the last few years, they find themselves in a very interesting situation. I have a customer, which is a retail customer. They realized that suddenly the lockdown was happening, and all of their counselors who were taking the phone calls from their data centers in physical buildings from these downtown locations couldn't come to work the next day, right?
Yep.
And the fact that we had a cloud presence, overnight they provisioned 30,000 VMs and the whole infrastructure and gave everybody access to this. And imagine enabling a workforce like that over a weekend to work from home.
That's amazing.
And,
Wow.
that they could do that because they had invested the time in these things. So you're right. I agree with you.
Yeah.
We are beginning to see some indirect impact, Magnus, I would say. We had projects in industries which are suffering, hotel industry, airline industry. We had projects there. Of course, those projects are struggling and having some indirect impact, not immediately, not because of the cloud, but because of the business they are in. So we are dealing with that like everybody else.
And to be clear, as backend systems, that's what we're cloud backend systems, and that kind of architecture is what you are going to be talking about real soon.
That's right. That's right.
Now that there was such a rush, kind of all of a sudden, it became very acute and very important. You were talking about 30,000 VMs and so forth, and this is not the only example. A lot of people are trying to do this exact move. While cloud is infinite for any individual company, cloud is not infinite for the service providers. Doesn't matter who you are. If you're Amazon, you're Google, you're Azure, it doesn't matter. The cloud capacity that they have is not going to be infinite. There has been a little bit of shortage here and there because there's such a big rush of demand that was not really in the plans. But still, it's kind of holding together. The cloud is largely working.
Yes.
So Vishwas, welcome to the show, and where are you joining us from?
I'm joining from close to Washington DC. Yeah, Northern Virginia.
How are things there during these different
Well, things are, we had our own share of the virus. And so we've been quarantining. I myself have been home for the last 10 weeks and maybe ventured out of my house maybe twice in the last 10 weeks or so. So we were trying to do what we can to be safe. And but, I hope everybody today watching this is safe and taking all the precautions that are needed. And together we'll get through this.
Mm-hmm. All right. Well, it's good to hear that you and your family is safe and doing well. Good stuff. So it's time to talk about cloud architectures then, is it?
That's right. And I would like to switch over to my screen. Hopefully you can see that now.
And we will call you, and we will be watching.
Take the lead there. Go ahead, Vishwas.
Yep, and Magnus, just you can confirm for me for a second, you're able to see my slide, correct?
It's all good.
Very good, thank you. Okay, thank you, Magnus, and thank you, Mahesh, for inviting me today. You both are experts in cloud yourself, and have had many conversations with both of you, learned things from you. So please jump in. If you see there are questions that you can help answer, please jump in. I appreciate that. So I'm here to take a few minutes of your time, and I do appreciate all of you taking the time to attend this session. We had great sessions about architecture before me. I'm going to focus specifically on the cloud architecture. And as we were talking earlier, this is a growing field, and you may be an expert in other areas, and hopefully this talk will motivate to take your existing skills, and you might have great architecture design skills in other domains. Hopefully this talk will motivate you to take those existing skills and map them to some of the cloud architecture skills that I'm going to talk about. Okay, so with that, let's get started. This is, nobody needs to be told this. I used to have this slide, a version of this slide a few years back, when I used to say, cloud is the future backbone of IT, and I've removed the word future. Cloud is the backbone of IT. And this is the transformational change that has happened in the cloud. And in order to take advantage of this, and we are talking about a trillion with a T, $1 trillion industry that is moving towards the cloud, and imagine the kinds of opportunities and skill sets that are going to be needed. So with that said, my agenda is really broken up into 5 parts. And I'm going to touch on these areas. Of course, we could have a talk on any one of these topics, but hopefully I can give you a 360-degree view. When I talked to Mahesh first, he gave me some ideas about what the audience would like to hear. I took his feedback, incorporated that into the agenda here as well. So we'll talk about these 5 things. We'll start out with what are cloud architect responsibilities. And before we jump into patterns and technology, I want to talk about responsibilities. Then we will touch a little bit about cloud design patterns. And I saw that there was a great discussion about CQRS before. I will take a look at the pattern, but from a cloud perspective. Then we will look at some of the Lego blocks that you need to, as an architect, you need to have an intuition for how these building blocks come together. And then, of course, thinking about the cost. The cost is becoming an important factor in the cloud. And we will talk about that, give you some ways to think about that. And of course, no talk about cloud architecture is complete without automations. We'll spend some time on automation as well. Okay, with that gets started, let's go with item number 1, which is what are the cloud architect responsibilities? And before you get into the technology of it, Azure and AWS and Google and whatnot, before we go into that, let's take a step back, right? In order to be successful in the cloud, there are a few things that need to come together. And if you're an aspiring cloud architect, I encourage you to pay attention to these things as well, as much as learning these technical skills. So Peter Drucker, I'm sure you've heard of this famous quote from Peter Drucker, that culture eats strategy for breakfast. What did he mean by that? You might have the best cloud strategy, but if you don't have the culture, you're not going to be successful in the cloud. So how can you as an architect bring about a cultural change in your organization? Right? One thing you can do, and by the way, no architects succeed by just sending out an email and issuing a decree. Nobody listens to them in that manner. You have to figure out a way to collaborate with people. create a culture. So cloud is all about agility. Cloud is all about automation. Cloud is all about shared responsibility. Cloud is not about us versus them. This is a production issue. Well, did you put enough observability in your code that we could debug that at 2 a.m. in the night? So that's a developer responsibility as well. So to the extent you can talk about culture, that will improve the outcomes. Collaboration is important. We find that cloud projects are successful if you have an executive backing into that cloud project. You need to collaborate with whoever is the executive sponsor. You need to collaborate with your networking folks. You need to collaborate with your security folks. Okay? Then think about the adoption framework, and I'll give you an example of this. By adoption framework, I mean by now, there is a wealth of information available out there about how organizations should adopt cloud. So all the way from a strategy to a plan phase to a migrate phase, there's enough documentation out there. So as you develop your cloud skills, technical skills, think about the adoption framework as well. And I'll give you an example. And of course, we will talk about architecture. So this slide, shows some of the skills that I have in mind. And of course, see the skills on the left-hand side, application architecture. We're going to talk about that. Automation, high availability, governance. No cloud architect is going to have these skills, of course. The important thing to note here is that you reach out to the right people in the organization, develop some understanding. So you might have somebody in your organization who is responsible for networking, and networking on premises, maybe they're used to some sort of a micro-segmentation model. And in the cloud, of course, it is all software-defined networking. So work with them, use their expertise. Similarly, ITSM. There may be people with ITIL experience in your organization or in your client's organization. How do you build a bridge with them to see how will that self-provisioning that is working today will work in the cloud? So technical skills, collaborating, and then non-technical skills in my mind are equally, if not more important. Change management. Cloud is about a change. How do you make change management happen? Read about that. Communication, collaboration, and I can't stress enough on the self-starting part. Cloud is changing constantly. And if you don't have the self-starting mindset, you cannot become an expert in the cloud. So cloud adoption framework, right? This is a framework which is out there in the Microsoft site, about 500 or so pages of information. Talk about strategy, plan. Once you've planned, you've done an app portfolio modernization. Now you're ready to set up a landing zone. What should be the naming convention? How should you structure it? What is the organization of your business? What business units do you have? What kind of naming convention will that entail? Migrate, innovate, and of course, governance phases, and then managing observability, maturity of operations, and so on and so forth, right? So read about these things as well. All right, so that concludes the first section of my talk. Think about culture, think about collaboration, think about the non-technical skills, broaden your understanding about the framework and adoption framework. And oh, by the way, even if you're working in Azure, there is great wealth of information in other platforms as well that you can learn from. So don't limit yourself to just one set of guidance. Okay, so I'm going to shift gears, move into cloud design patterns. So there was great discussions. The prior speaker talked about CQRS and very good patterns. I want to focus on one type of patterns, which hopefully will allow me to communicate a couple of important points in my talk, resilience patterns. And this is really important from my perspective because you want your applications to be highly resilient. So the first pattern that comes to mind and is probably the retry logic. And you're probably thinking to yourself, Vishwas, I've seen retry logic. I use it all the time. Wow, what has this got to do with the cloud? Well, retry logic becomes more important in the cloud. Why so? Because in an on-premises world, you have a dedicated piece of hardware, oftentimes over-provisioned. So you don't see any of the throttling that might happen. In the cloud, you're dependent on multiple services running in a multi-tenant environment, which means you may get throttled, which means you might have a transient fault, which will go away momentarily, but you need to be smart enough to handle that transient failure. So the retry logic becomes really important. In fact, let me do this. I'm going to go to Visual Studio Code really quickly. and show you a couple of examples to motivate that right here. Okay, so let's let me find right here. I should have had that file here, but I did not. So let me just find it here. Yeah, there's the retry logic. And I just want to call out a couple of things here, and let me get this thing out of the mix. So by now, any cloud service that you're using, and I'm going to use an Azure specific example because that's where I spend most of the time, but these patterns apply to any cloud. So if you're using any Azure service today, the client SDK for that service gives you some sort of a retry policy. And if you don't have an SDK that gives you a retry policy, then you can, of course, take advantage of open source projects like Poly, which is an excellent resource for you to use. But let's take a look at the Cosmos DB example. Line 4, I'm setting up a connection policy. I'm setting up the maximum retry attempts, which means if the first attempt fails because of some throttling reason, please try this call again 3 times, but then limit the retry to 60 seconds. Makes sense? Quite simple to understand. Let's take a look at the storage example. Here, the options are a little bit more advanced. So once again, I'm creating a blob client. And here I'm setting up a retry policy, which is exponential retry. What does that mean? I'm going to try once. If I get a transient failure, I'm going to back off. And every time I back off, I'm going to increase the time exponentially. And that's a best practice, because imagine if you're writing a multi-threaded application and each one of them try every 5 seconds, then you're going to have the same throttling problem. So it's better to sort of spread the retry attempts across. Now look at the line 16 here. Not only are we retrying, we also have this ability to say primary, then secondary. So if my 3 primary attempts fail, then hey, storage, retry me or send me to secondary, and I might get a read-only experience, but at least I have a connection to a storage location. So that's the retry logic. Okay, so let's go back here. One interesting thing I've learned from my journey in the cloud is that retry logic is not only important, you need to be able to test this logic. So when I showed you this code here, go back to code, when I showed you this line 14 to line 16, this is a pretty important piece of code. The problem with this code is that it never gets executed because it is really hard for me to recreate a transient fault. As a result, this important piece of code, 14, 15, 16, 17, is going to be executed at 2 a.m., the worst possible time, and then you will not know why it executed in this manner and what happened. Okay, so it's really important to test your retry logic. So how should you test your retry logic if you don't have a way to simulate a transient failure? Well, I'll show you an example here. Right here, what I have is a virtual machine running. What I did here was I got the open source code for Redis. And in my application, I was architecting using Azure Redis cache service, but I wanted to test my retry logic. So what I did was downloaded a C++ version of Redis server, injected some chaos into that, and now I ran a client against that for 1,000 operations and seeing, oh, so my retry logic executed 1,000 times or whatever the chaos number was, and how many operations out of that failed. And that gives me a way to reason about my retry logic. Okay, and here's the client code. I think I should be able to show you the client code in a second. Let's go here. And if I can easily find it. So Redis client. And if I go in here, right here is my client code. And you can see I'm making 1,000 operations here. And then this piece of code, this is testing my retry logic. Okay, makes sense? So find creative ways about how you can test your retry logic. Now, in certain cases, you will find that it is not a transient fault, and it is actually a more permanent problem. And now you have to worry about resource exhaustion. What do I mean by that? So you're going to keep retrying, and there is not a transient fault. As a result, you're going to keep calling a downstream system. You're going to fill up the queue. At some point, you'll get into resource exhaustion, and you will cause an outage. And I'll show you an example in a moment. There's a website which talks about root cause analysis of all cloud outages. And if you look through the root cause analysis of the past outages, you'll find that a majority of them are related to resource exhaustion. And very simple pattern, and if you put this pattern in place, a very simple pattern to solve this problem is break the circuit pattern. Let's just walk through some code and to see how retrap pattern can be implemented. Okay, so circuit breaker pattern. Sorry, I said retrap pattern. I meant circuit breaker. So let's look at this code. How's the circuit breaker implemented here? So I'm going to make a call to the downstream system. I check if the circuit is open, which means I cannot make a call to the downstream system. Then I'll execute this piece of code. We will look at that in a second. But if the circuit is closed, I simply let that call go through. Makes sense? Now let's look at what happens if the circuit is open. If the circuit is open, the first thing I do here is I check if I've spent enough time waiting. See, I don't want to inundate my downstream system, so I wait for a certain period of time. I check if I've waited for that time. After I've waited for that amount of time, I take a lock. Why do I take a lock? This is a multi-threaded application. I don't want to overwhelm my downstream system, so I take a lock so only one thread goes through. One thread is going through here. I do a half open. I make a call to the downstream system. If the downstream system succeeds, I'm ready to close my circuit. Okay, so very easy to understand. 10 lines of code, but this can save you so many outages that can result from resource exhaustion. Okay, so we have talked about this. Let's talk about one other resilience pattern, and then we will move on. So uninitialized state is a very common bug or a problem, and we have seen this all over. I want to motivate a very interesting example of this uninitialized state that can only happen in the cloud. Okay, so let me bring up a code example to show you. By the way, I have gone through all of these problems myself, so you can think of this slide as learn from Vishwas's mistakes. That would not be a far-fetched statement. So I've gone through all of these problems. And let me walk you through this example right here. Okay, I'm going to close some of these to make myself more room. So I want to show you this example. In this case, what is happening is I'm bringing up a compute instance. The compute instance comes in, and then I do some initialization as part of my compute instance. And I wrote this code, and since the initialization is expensive, I went in with a best practice. What is that best practice? The best practice is right here. I go into the file here. The best practice is line 11, that if my compute instance gets recycled, please do not clean up my local storage. That's an optimization that most people will use. So when my instance was coming back up, and because I had that optimization, I needed to check if the initialization had been done. So how do I check that? I wrote a breadcrumb. I wrote a breadcrumb on the D drive. So if the machine came up, I checked the breadcrumb. I did not initialize. I saved myself that initialization time. Make sense? Now, what happened to me in this instance is that compute had a disk failure. So Azure automatically moved me to a new machine, kept my D drive the same, gave me a brand new C drive. As a result, my registry was not initialized with all the things that I needed. Okay, so my breadcrumbs logic was faulty. Of course, you can fix this quite easily. But these kinds of attack vectors are possible in the cloud, where unbeknownst to you, you might end up getting a new C drive. Okay, and you have to deal with that kind of initialization problem. So keep those things in mind. The last pattern I want to talk about, planning for resilience. And let me talk about this for a second. Just to talk about this previous slide. So there's this slide called Common Causes of Cloud Outages. And I will make this slide deck available right after this session. I can put a link on my Twitter feed, or I'll send it to the organizers, and they'll have this so you can look at these. So this is a site called the Common Causes of Cloud Outages. I simply did a search for resource exhaustion, and notice here on the right how many finds it has of resource exhaustion. So remember, I was talking about the circuit breaker pattern that causes resource exhaustion. Majority of the cloud outages are because of resource exhaustion. Okay, let's talk about resilience modeling and analysis. Sounds like a fancy term, does it not? So this is a technique that Microsoft teams use internally to improve the resilience of their service. There's a link down there. You can download that. But the idea is quite simple. Much like you, at the early stage of the design of your project, you think about security these days. If you don't, you should be. That's what DevSecOps is all about. What this technique is talking about is much like you think about security during the early stages of your application, you should also think about reliability for your application. How do you do that? So let me show you an example right here. So simply take a component interaction diagram right here. So take a component interaction diagram. And right here, what we do is we figure out all of the failure modes of this diagram. So this compute instance is calling the storage account. So this is one failure mode. I'm calling a queue storage. That's another failure mode. I'm calling a database. That's another failure mode. And notice the signs here, which says throttling right here. This is throttling, which means I can be delayed. I might have a shared access signature to my storage account, which might have expired. These are all failure scenarios. I might be dependent on an external service right here. So imagine that if you can draw this component interaction diagram, you take every failure mode, 2A, 3B, 2C, all of the ones listed here. You take these failure modes, you make sure that you have a way to detect these failures, and then you make sure that you have a way to mitigate that. That's what resilience modeling and analysis is all about. Important thing to note here is you will never get into a state where you have mitigated every single potential failure, because frankly, that's a business decision. Every time you try to mitigate a failure mode, it's an expense to the overall cost of the project. And you need to figure out what is that business justification for what resilience needs that you may bring as part of your design. Okay, so let's keep moving here. So that concludes my second part of my talk, which is the design patterns. And as I said earlier, I have only given you resilience patterns. I encourage you to look at the architecture pattern site, look at all of the patterns that apply here, anti-corruption pattern, asynchronous request reply. So keep going to this architecture center, pick a pattern whenever you have time, look at one pattern, think about it, and then in this manner, continue to widen your horizons in terms of usage of these patterns. All right. So that concludes the second section of my talk. We talked about the culture and adoption first. We talked about patterns. Now let's look at the Azure building blocks, which are sort of the Lego blocks of Azure. And as an architect, you need to have an intuition for what these building blocks are. And I know that there are lots of building blocks. There are over 200 services in Azure. No one person can know all of that. And of course, you have to rely on your teams, your dev leads, your developers, your others. You have to rely on them. But as an architect, you need to try to develop an intuition for what these building blocks are and how you can put them together in your architecture. So I want to take example of only one compute option. I can draw the similar diagram for networking, for messaging, for storage, but let's just talk about compute here. So as you know, in Azure, we have many different compute options. You have VMs, we have VM scale sets, of course. You have Azure container instances. If you've not used them, container as a service, you just create a container, don't worry about the host. You have Azure App Service, which can be run with or without containers. You have Azure Kubernetes service, which is the managed Kubernetes service. You have serverless computing with Azure Functions. And then, of course, you have Azure Batch, which gives you sort of batch-like capability. Now, what do I mean by develop an intuition for which one to use when? So here's an example. I have a monolithic application, and I want to run it in Azure. I can run it on a VM, of course. I can run it on a container instance. But maybe the preferred option is Azure App Service because all of the manageability is being done by the Azure platform, reducing your total cost of ownership. If I have an end-tier application, I may want to run it in Azure App Service as well. If I'm trying to build a microservices-based application where I have dozens of microservices, then I may want to take advantage of AKS. And I'm only showing Linux containers here. The slide needs to be updated. As of 28th April, Windows containers GA'd with AKS as well. So you could use Windows containers or Linux containers. If you're building an event-driven application, Functions is a great option. Now, let's explore that further. So people often talk about, I get an event, I am acting on it in a stateless manner, and Functions are great. What if you are acting in a stateful manner? Well, there is this notion of durable functions that you should be looking at, a very interesting capability there. So think about the options that are available to you. Similarly, if you're trying to write a batch operation, of course, you can run this batch operation inside Kubernetes, but you can also run it if the batch operation is sort of short-lived. Maybe you can run it as a function. But if the batch operation is truly a long-running operation, then Azure Batch may be the best option for you to consider. Okay, so this is what I mean by know the building blocks, have an intuition about what are the strengths of these building blocks. Let's look at Azure SQL Database for just to motivate this example of what I mean by these building blocks. Azure SQL Database, we all know and love the database service. It gives us geo-replication. It gives us automatic asynchronous replication. That's what the geo-replication feature is all about. It gives us multiple secondaries. Now, if you have to fail over, either it's an unplanned failover or a planned failover, you need to initiate that action. And then you need to think about the failback options. What do I mean by failback? So primary fails into secondary, and now primary comes back up. You're able to fail back into the primary. That's what I mean by failback. Now, you need to understand these characteristics. And then you have to also understand that when you initiate a failover operation, your connection string has to change because now you're going and talking to one of the secondaries. How will you deal with that? What DevOps do you have in place to be able to support that connection string change? Let's look at Cosmos DB. Cosmos DB, of course, natively supports geo-replication. It supports automatic regional failures. Of course, it has multi-master support now. If you've not looked at that, you have 2 locations. They can write, and then you can do deconflicting, understanding those kinds of things. And the last thing I will say about Cosmos DB here is that in this case, if the primary fails, Cosmos DB will automatically redirect you to secondary 1, secondary 2, depending on the order you've specified, without you having to change the connection string. Knowing those kinds of details are important when you're designing for resilience of your application. The last example I will give you about the intuition of these building blocks is PaaS meets VNet. So I find that lots of application architects have a good understanding of, hey, I know app service, I know containers, but do you know where app services interact with something like VNet? So to motivate this example, so as you know, if you've created an Azure SQL database or a storage, these are multi-tenant services, or you've created an app service instance, there are multi-tenant services which are available. The endpoint is available on the internet, right? That's what multi-tenant shared service is all about. Now, if you're going and working with a healthcare company and they require the data to not ever go over the internet, how do you deal with that? Well, what you do is you create an app service instance called the app service environment, which is an isolated app service instance inside your virtual network, right? That's how you create it. So you really had to choose between the two. You had to give up some capabilities to get the other one. Well, Microsoft has introduced new capability called Private Link. And if you look at what Private Link enables you to do, you can still use your multi-tenant services, but you can also ensure that the connection is happening over a private network. Okay, so that's what Private Link is all about. So this is what I mean by keeping track of what are the new capabilities and how they impact your design decisions. Okay, so that concludes my section 3. Remember, we had 5 sections to talk about. We started with culture, patterns, and the building blocks was the third one. Okay, so let's look at the cost. And this is probably the one which I'm most passionate about. I have many customers who are spending a very large amount in the cloud every month. And I think of it as my personal mission to make sure that they're using the cloud resources in a manner that is most optimal to them. And to show you an example, let's look at this case study here. So imagine that I have an organization and I have these 4 kinds of workloads, okay? These 4 kinds of workloads. So the first kind of workload is I have web servers that can see an unpredictable spike. I have certain services that will see some predictable spike, 9 to 5 high, after 5 low, so I have a predictable spike. I have some bad jobs, some data processing jobs that I run at night. And then I have some line of business applications that I have to run 24/7 because they don't get too much use, but I still have to have them because even if a small number of users are using it, they need access to that application 24/7. Today, I'm running this entire portfolio of applications, maybe in an on-premises setup, or I do a lift and shift of that into an Azure data center, and I can run them on 100 VMs, 4 core each. So I can run this 100 machines, and I can run all of this infrastructure right here. Okay, how much will this cost me? This will cost me about $658,000 a year. That's expensive. How can we reduce the cost? Let's look at some of the options. For unpredictable burst in requirements, I can take advantage of something called the burstable VMs. I'll explain in a moment what these are. For predictable spikes, I'm going to use VM scale sets. For bad jobs, which I don't care about finishing in 15 minutes, I can take a few hours to finish. I'm going to take advantage of low priority or spot instances. For my line of business applications, which don't require a high number of active users, I might containerize it. So how will these options save me some money? Let's take a look. What are burstable VMs? And if you don't know this, this is really an interesting concept. And the best way to explain this concept is, I'm sure in some point you have had a cell phone plan which gave you rollover minutes. And think of that for a moment, and that's what this is all about. You buy a VM at a certain baseline performance. For the time that you are not using the baseline performance and you are using less than the baseline, Microsoft will see that you're using less than the baseline. They will give you credits for that. And then you can use those credits to then pay for the spikes when they come up. Make sense? So that's a burstable VM. If I did that, I can save 50% of my web server cost, which is 10% of my overall cost. Okay, that's one way of looking at it. VM scale set. So VM scale set is a very interesting capability where you can spin up multiple VMs in a really speedy manner. And Microsoft actually under the covers is doing some interesting magic. Let's say you ask for 10 VMs. They guarantee you that you will get 10 VMs in a very short period of time. And under the covers, they actually provision 13 or 14 VMs because 1 or 2 VMs, if they fail, you're still able to give you 10 and you pay for 10. Okay, that's what VM scale set is all about. So you can scale up and down very, very quickly. If you take advantage of that, you save another 25% on the services cost, which is 11% savings over your annual spend. Let's keep going. Low priority VMs, now called the spot VMs. And I love this because, I don't know if you've run that command. My favorite way of provisioning VMs is AZ, command line interface. And I love this because I can say AZ CLI, give me a spot instance and only give me this VM because I'm willing to pay you this much money. And if there is enough access capacity available, they will say, yes, we can give you this, or don't give me a machine at that time, right? That's the idea behind a spot instance. But here is where your architectural skills come into play. What does spot instance mean? Spot instance means that you're going to get up to 80% of discount. But of course, there's a catch. There's always a catch, right? And the catch is that they are going to yank that machine from you with a 30-second notice. Well, no problem if you have architected it well. If you have implemented some sort of a checkpoint restart pattern where you started a bad job and every 10 minutes you put a checkpoint, and 7 minutes into that, Microsoft yanks that machine, you go back to your previous checkpoint, get another VM, start running that. Now you have saved your organization about 80% of the cost. Okay. The last thing I'm going to talk about, and let's see the cost, 60 to 80% of the cost. The last thing I'm going to talk about is the line of business applications. What we find often with customers is they're paying for the entire VM, but they're only using CPU at a 10 or 11%, okay? Which is, well, you're paying for the entire VM, only you're using 11%, does not make sense. How about we containerize your application? And if we containerize your application, we can save you another 65%. How so? You take a line of business application, containerize it as a Windows container or a Linux container, and then sort of tightly pack that virtual machine. And what the beauty of containers is that you can put resource gates around that. What do I mean by that? So I can take a line of business application, containerize it as a Windows container app, run it on top of AKS, for example, and I can put a resource quota and say, this line of business application will only use this many millicores, and these many millibytes of memory, and it cannot go outside the bound of that. So that way, I can pack on that VM or that node of AKS 20 applications if I have to. So now I'm greatly reducing the cost of running my line of business applications. So think about these things about cost saving, and this is very much an architectural consideration. It's not just a financial consideration here. Okay, so we've concluded the 4 sections of my talk here. The 4th one was cost. Let me go to the final portion of my talk, which is about automation. Okay, so automation, of course, is important, and there have been enough talks about CI/CD and DevOps and continuous integration and continuous deployment, and there have been tons and tons of talk, and many of the audiences who's here today, you are very familiar with those concepts. In fact, many of you are doing CI/CD in an on-premises world, right? This has been around for some time. So what do I mean by automation? I mean by automation, think of infrastructure as code. Think of tools like Azure CLI, ARM templates. If you are in a multi-cloud setting, think of things like Terraform, which is a multi-cloud. If you're a JavaScript developer and if you're new to infrastructure as code, think of tools like Pulumi, which is a JavaScript syntax for provisioning infrastructure. So know about those tools. Figure out what is the skill set of your organization and try to use this tool. Of course, learn about DevOps platforms. Azure DevOps, of course. GitHub Actions is gaining some real traction. Things like the DevSecOps. I'm sure you've seen this, right? If you have a public GitHub repo, you get an email saying, hey, this is a public GitHub repo. You are using a library which has a known vulnerability, and would you like to fix it, right? All of those DevSecOps options and automations are going to be really important. But I want you to think beyond that. I want you to think beyond infrastructure as code. I want to think beyond CI/CD. And I want to think about automation as a way to make your cloud journey successful. So I wrote a blog post about 2 or 3 years back. Let me just, the blog post is listed at the bottom of the screen here. And I took the picture from the blog post and I have it here. And let me explain this, and then we'll take a couple of examples and see how that relate to this here. So when people move to the cloud, right, there are 3 or 4 different constituencies who are looking at the cloud. Of course, you have the CIO, Mr. CIO or Mrs. CIO. They have certain digital transformation objectives about the cloud. They want capabilities as service. They want to evacuate their data centers. They want to remove the capacity constraints. They want to lower their time to value. So when they're looking at the cloud, they're looking at for these reasons. Of course, you have the ops people who are saying, I used to be able to do that in my on-premises data center. How do I do that in the cloud? I had great ITSM tools. I had great networking tools in the cloud, which told me exactly how my network was doing. And I want the same expectation in the cloud. I had great resilience and compliance and security compliance story. I had a single glass of management, and I expect all these things in the cloud. Okay, and then of course you have the app community. They're expecting CI/CD hybrid architectures. They want their languages and tools. They want their performance. They want self-service provisioning. So as you can see, 3 groups, they all have expectations from the cloud. And what we find today is you might run into a situation where there may be a gap between these expectations. And let me call out a couple of examples here that will bring home this point. The first example I want to bring out is Azure API Management, one of my favorite services. Azure API Management has a GitHub support built in. So you go to Azure API Management and go into the portal and enable GitHub integration. And what will happen is as you write Azure API Management policies, those will be synchronized with GitHub. And you can manage your versioning of your policies in that manner. Okay, a great capability. But I was working with an organization where multiple organizations or multiple divisions in that company were writing these policies, and they did not want to store all of the policies in one place. They all had a separate approval process. And at that time, Azure API management was not supporting this model, and that became a showstopper for them. Well, we wrote just a little bit of automation pixie dust. We just sprinkled a little bit of pixie dust of automation, created a workflow where developers from different divisions could check in their policies, go through the approval process, and then integrate with the common repository. Okay, that's an example of an automation that met the gap. Now, what happened? In 2020, Azure API management team has gone in with this model of ARM template-based deployments, which allows you some of the flexibility that we were looking at 2 years back. So think of these pieces of automation as scaffolding pieces of code. They may go away when the product teams implement that capability. But when these products don't have that capability and they become a critical bottleneck between these expectations, you can write a just bit amount of code to make that happen. Let me give you one final example related to this. Working with a customer that was in a controlled environment, they had to have their applications as PCI compliant, payment card industry compliance. One of the tenets of payment card industry compliance is something called the data exfiltration. What does that mean? If I'm writing applications, I'm writing data to a storage location, I should only be allowed to write to a known whitelist of storage accounts. Okay, that's what data exfiltration means. And at that time, there was no private link capability which allows data exfiltration. So we wrote a little bit of automation to make sure that the calls are routed to a certain set of storage accounts only. So think of automation in this manner. And I want to leave you with this one important thought. I was attending a cloud conference, and there was a panel discussion going on. I was listening to the panel discussion. The people on the stage were CIOs and CTOs of 5 companies who have been using the cloud for the last 5 years. Okay, and the host or the moderator of that panel discussion asked them one final question. All of you have been in the cloud for 5 years. If you had to take one thing from your experience and share with the audience, what would that be? And that perked up my ears, and I was thinking, hey, this is really a really important nugget of information. I should pay attention to that. Each one of those guests on that panel discussion said, automation was key to our success. We invested a lot in automation, but if we had to redo this project again, redo the last 5 years, we would invest even more in automation. So take what you want from this little incident, but it told me a lot about how these successful companies are thinking about automation. Okay, so that concludes our 5 sections. Before I end, I just had a quick call to action. So how do you become a cloud architect? Of course, think about the things that I talked about. But how do you continuously learn? Get engaged with cloud projects. There may be another group within the company that may be doing some cloud project. Get involved, volunteer your time, engage with the community. Every city that you are in has a great community. I know CSharpCorner has a great community in many, many parts of the world. Get engaged. I cannot stress enough about self-learning. The cadence of the cloud is too high for you to wait for a training class or a conference. You have to learn these things on your own. Then broaden your horizons. Even if you're an app developer, understand what is meant by software-defined networking. So I'll give you one challenge. Think about this for a moment. Remember, I was talking about the private link, right? And let me bring up that slide. I'll give you this challenge. I want you to think about it when you go for a walk next time. So let me bring up this slide here. And this is a challenge for you to think about. So I said that the private link ensures that the packets coming out of your service into storage, into SQL, will only travel over your network. Think about how that's implemented. And the answer is some form of software-defined networking. Of course, that's the obvious answer. But how does that entail? What's happening? What are the packets? Who's stamping the packet? How's that happening? Think about it. This may not be your primary area of expertise, but thinking about these things will go a long way in helping you broaden your understanding. Then improve your automation scripts. As an architect, you have to be handy in one automation tool of your choice. Will make your analysis much better. So focus on that. And then I cannot stress on this enough. Improve your collaboration skills, improve your communication skills. Success in the cloud is only going to come by you collaborating with a collection of people. So sometimes it's the non-technical skills that are going to be more important than your technical skills. And I will end my talk with this last drawing that my daughter drew. And this is so true for cloud architecture. What this message is really about is your success in the cloud. So it will be not just be dependent on your aptitude. Okay, it will not just about your aptitude. There are many, many smart people out there. But this is not about your aptitude. It is about your attitude that will determine your cloud altitude. Okay, ultimately, that's what this is all about. Okay, so thank you for giving me a few minutes to share my experiences. I'm going to come out of the presentation mode so I can see the screen back. Mahesh, Magnus, over to you guys.
Hey, that's a wonderful and beautiful design. And I loved that when I saw that on Twitter, and it's definitely is perfect fits with this cloud. Great session. I learned a lot.
Oh yeah, there were several very happy comments during your session, so it was very well received and of course very well delivered as always.
Thank you, Magnus. I appreciate it.
Yeah, no worries.
So
here we are.
While we have some time, we'll take a few questions. But before that, I have my own questions. So let me jump in the line.
Do it.
So you know how Microsoft, we do mostly Microsoft, and I do a lot more Microsoft than anything else. So there is Azure DevOps and GitHub, and my developers are always fighting. One guy who likes GitHub more always says, "Can we put this project on GitHub?" Then another guy will say, "Oh, we already have Azure DevOps. Let's do it there." So what is your preference, or is there any long-term strategy coming from Microsoft? If you have a new project, where would you go?
Okay, so that's a very interesting question, and Magnus has lots of insights into this. So I'd like to hear Magnus has to say as well, but I'll give you my 2 cents. Right. First of all, there are 3 million users of Azure DevOps. They love Azure DevOps, and Microsoft is committed to. And I'm speaking for myself here, guys. All the audiences, this is Vishwas's personal view of the situation, right? Just to be very clear. There are 3 million users out there. People love DevOps. I have many projects where we use DevOps. My team loves it, Azure DevOps. And I think Microsoft is continue to support that for the foreseeable future. Okay, that's number one. But it also makes sense, given that there are many more million users in GitHub today, it also makes sense for Microsoft to invest in one technology versus investing in 2 technologies. So you will continue to see, if you're starting a project now, it may make more sense to go with the GitHub option because that's where the future investments are going to be. Just because there are more developers there, and look at the things that they've done in the last year or so, right? I mentioned one of them. So GitHub Actions allows you to set up any CI process. Look at today, what we find is 80 to 90% of the code that you're writing is dependent on some sort of an open source stack. So GitHub has invested a lot into pointing out any vulnerabilities or known issues. And they do that today for the public repos. They announced at Build just a couple of weeks ago that those capabilities are going to be available in the private repos as well. So number of DevSecOps capabilities, GitHub Actions, many of those capabilities are going to see those landing there in that manner as well. And the other important aspects, maybe there are capabilities in Azure DevOps that are not there in GitHub. You can see those landing in the GitHub space as well. Magnus?
Yeah, no, I couldn't agree more. You are, as always, you're spot on this. We have been discussing this on occasion. I'm going to go a little bit further and say, yes, of course, DevOps is huge and accepted and loved, and for good reason. The feature set and the things you can do with DevOps is truly impressive, very inspiring stuff. Going long way forward, I can't see Microsoft having two separate things at this size available as separate products. I think we will see a merger. I know that when we do, I'm speaking in absolute terms here, but let's say that we do, and then when we do, there's going to be a really, really, really good migration path from one to the other, so that there will be a way to merge in, and Microsoft will take two great things and make an even greater thing together. There's going to be such a future at some point. I don't see, why would Microsoft have two, Word applications or two different browsers or two different anything. So I'm thinking that there will be a merger. I don't know when, but for sure, obviously, Microsoft will take very good care of the people who love DevOps and probably move that towards a brand called GitHub. I don't know if that's going to be the exact end of it or, direction, but I see that there will be one.
Yeah.
At some point.
Yep. Do we have any more questions? Yeah, there is a question about what do you think about GitLab CI/CD?
You're talking about specifically the GitLab and the Kubernetes integration?
I think they're talking about CI/CD, just used for CI/CD.
I'm not a big user of GitLab myself. I don't know, Magnus, you are. The use case that I'm very familiar with is, and that's gaining a lot of popularity related to GitLab, and there may be other use cases there. And we maybe at some point we'll do a Kubernetes talk. But Kubernetes is all about YAML files, and then there's a very nice integration between GitLab and Kubernetes where you check in a YAML file into GitLab, and that will cause an action to take place in a Kubernetes cluster, and AKS supports that model. So all your source code repository becomes the source of truth for your operational information as well. So that's a very important, interesting example. That's my only familiarity with GitLab.
Yeah.
Same for me. I don't have the privilege of being able to say that one is better than the other. All of them work, and all of them have a place here. There's not only Microsoft products, there are other build and CI/CD systems out there. This question was originally related to the Microsoft having two options, but
yeah, exactly, because
it doesn't matter which one you use. You can use any one. The point is use one and be agile, flexible, and mean and lean and deploy all the time. That's the point, right? It doesn't matter which one at the end.
Yeah. And then I think my other question is, you had a good point around the cost of VMs versus containers. And I have I'm working with a client. Every time they launch a new product, they just spin off new VMs for everything, and they have no idea, because they are all AWS. Their background AWS. The IT folks who are managing their cloud still have the old mentality of, okay, let's spin a VM. What you need on that? Okay, you need IaaS, you need Windows, you need SQL Server. Okay, here you go. So what they're doing is, rather than working, doing extra work, figuring things out, they just give these developers or whoever is responsible for deployment these different machines. So how do you, what is your recommendation to change their mindset? Like, if I go as an consultant, external consultants, what's the best way for you to kind of convince them, or say, hey, maybe you don't want to piss them off either, right? They are the guys. They'll go to their boss and like, okay, these guys don't know anything.
Yeah, no, I think I hear you, and that's, if you look at where the cloud providers, and I call them hyperscalers, all of them are hyperscalers. A lot of their money is coming from compute and storage, right? No question about it. At the end of the day, the money is coming from compute and storage. It is the job of architects like us to get out of that space. So if they're spinning a new virtual machine when they have a new application, maybe the discussion should be that, okay, I'm not asking you to rewrite the application. And, people get very concerned about a greenfield development, right? You can't go to them and say, you can write this beautiful microservices based application instead of what you have, and that will save you money. And that sometimes is problematic, because we'll say, who's going to pay for writing this beautiful cloud native application? What you can have as an interim conversation is, okay, so we'll take this application. Maybe we have a new user or a new application. Can we just refactor the application? Which means, can we do a minimal changes to the application so that it can run? So let's say a new application comes along and they need a database, and looks like they're spinning up a virtual machine with a database server, right? I don't know the specific example, but let's just use this example. Well, what are the characteristics of this database? Can I take an hour to run the data migration wizard, which will give me a detailed report of 99% of the things that you're going to do inside this database are supported here in Azure SQL database. Okay, 99% are supported. So are you doing anything in that 1% that you require a VM for? And an example of that 1% is the following. They're doing something with MSDTC, which is not supported by Azure SQL database, right? If they're using MSDTC, then you can't be that consultant to recommend them something that will not work. But assuming that you're not using MSDTC, you can say to them that, look, don't spin up on VM everything that you need. Or you need CLR-based stored procedures? Or sure, go to managed instance. And then show them how you can run it as a managed instance. And then show them, this might be quite amusing to all the listeners here today, that now we have an option in a database, which is a serverless database option, where we only pay for the times that the queries are running, right? So show them a path to a viable alternative. And if that meets the requirements, then show them the path of potential cost savings. And the two together will help you get there. And I took a database as an example. I could do the same with a compute example, right? They're running a program, they spin up a VM. Well, let's analyze this application. Look at the dependencies of these applications and see, can it be containerized? And if it can be containerized, then I can maybe run it in ACI or Azure Container or AKS. Oh, this cannot be containerized. Why cannot be containerized? Oh, because you are making a call to a Win32 API that is not containerizable. Okay. If that's the case, maybe you want a machine. So you get the idea, right? I mean, I typically progress conversations in that manner. So sorry for a long answer, Mahesh, but hopefully that helps.
That's good. That's good. I mean, yeah. There is a question from Govind Sharma here. Is there any platform to virtually use Azure and learn it for a student and get experience with it like Firebase offers?
Yeah, I mean, Microsoft Learn is an excellent platform. It's so, I highly encourage you to go look at that.
Yeah.
It's beautifully implemented. There is actually a whole Azure, there's a whole layer on top of Azure. You do read about something, and then you can take those actions right there, and it will give you this ability to try these things out. So Govind, great question. Look at Microsoft Learn. You can also get a free account with Microsoft as a student. If you're a student, if you're not a student, you can still get a free account for a certain period of time. But keep in mind, and I tell this to many people who are trying to learn Azure or any other public cloud, that if we are in this business of running the cloud and architecting our applications in the cloud, just with a little bit of money that we spend on these subscriptions, even just a little bit of money, we can learn so much from these things. So don't be afraid to have an account and be very careful about what you spend. But if you're spending money to learn these things, it is a worthwhile investment in my mind.
Yeah, and you had a good question that be careful when you're running, watch your resources. Funny thing is, I have multiple accounts with Azure, and one of the accounts 3 years ago, I started running this test blockchain, product, because we were testing it and blockchain was built. And this January, I found out that every month I'm paying $88 for last 3 years. So make
Yeah,
sure you watch where you're spending.
so there are stories like that, but just to take that question, Mahesh, you can set up alerts in your account. So you can set up alerts and say, if the bill goes above 50, send me an email. You can set up a budget.
To be fair, I don't think you could set those up 3 years ago.
Right. I just found out last because I was looking at my credit card.
But Mahesh, what you could do, I remember, about 10 years back, you can find this. 10 years back, I wrote a Windows app, a tile app, Magnus. It was a tile app that showed me my bill. So every time I went to Windows 10 or Windows 8 at that time, a tile showed me how much money was being spent. And, that was enough to me to trigger, that I was spending more money than I needed to.
Very well. Yeah, very well. So are you, we have a panel now, Magnus, right?
Yeah, let's have a panel.
We have coming up panels. So let's add more speakers.
Add more people.
To the panel. Add,
and Naveen, nice.
Naveen, you there?
Yeah.
Yep, everybody's here.
Yep, I'm here.
All right, we all set. Go ahead, Naveen. You want to lead the panel?
Sure. So welcome everyone, and welcome Vishwas, Andy, Magnus, Mahesh again. So let's start with the panel. I have collected the questions people have asked since we started this show. So first, in a very basic question. So Andy, I'll start with you. So we'll go in round robin fashion. So first question: who is a architect? Like Magnus very well defined it, but again, for the simplicity, who is an architect and who is a solution architect? Is there any difference between the two, or are they the same profile? Every company differs with the terminology. So how do you define that?
I think, and this is a good question, and it kind of goes back to something I had said about sometimes there's confusion between design principles and patterns and architectures, right? Sometimes people use these terms interchangeably. And sometimes these architect titles can be a little vague, right? And there can be some confusion. To me, I think of a solution architect as probably what would be closer as was used, I think, in one of the earlier discussions. Naveen, it might have been yours, or is more of an application architect. I think of a solution architect as an application/web architect working on building a solution, right? Usually, which is an application and maybe some backing services for it like that, which is different than an enterprise architect who really would think across the enterprise and think about, the bigger picture. But it's really open for debate. And some of these titles are sketchy. Companies will give out titles and call you a such and such an architect. And so I don't know if it's even worth getting into those specifics because they're very vague. And I don't know if the other panelists agree.
Yeah. So
well, I have a question for you, Naveen, actually, and we all can jump on this, not just Naveen, actually, it's for everybody. When personally I see enterprise architect, I hear the word or solution architect or software architect. My experience has always been that enterprise architect usually come from a non-coding background.
Yeah,
that's not true in 100%, but I've seen most cases. They are more into
I have seen people coming from programming world because they work in a company who is product centric. They make software products. So then they raise to the level of an enterprise architect. So it depends on case to case. So we cannot generalize this.
Okay, so it could be both. So, yeah, okay.
Yeah,
I've not heard what Mahesh said. I had not heard of generally enterprise architects as non-developers. Sometimes they will come though from I don't know. This is another one of those terms, but what I say is the IT side of things.
Yeah, well, that's what I mean. Is IT side.
Might come from networking background and things like that, because enterprise has a lot to do with the way these applications and these big systems, kind of work together. But I don't know if that's I think that might be less common thing moving forward. I remember seeing that more in the past.
So there are different observations. So like we just with CSharpCorner, I just completed 1 month long training for solution architecture, and that was core into IT side of it, IT infra. But we talked about what are the main pointers of the service contract, how do you transition the service, how you transform the landscape, what is ITL, all the networking basics, infrastructure basics, and even the middleware basics. So we ran this program for a whole month, 1 month, and there are 12 to 15 participants at any given time. So they asked even the repeated question, which I see in this forum again. So what is the path? Because most of the people, they are developers in our community. What is the quick path? So Magnus, this question is to you. To become an architect, they just want to start traveling the journey of becoming an architect, designing things rather than doing the daily coding. So what is the quick journey like? How will you suggest that?
I'm not sure that there is a quick journey, but I think it's directional. So if you want to be an architect, as in actually a person who has more responsibilities, actually, then you need to have a certain attitude, as Vishwas alluded to. You need to be a continuous, a constant learner. Several of us who have spoken here today have brought up learning. You are the person who would be closer to the front lines of technology, because you need to understand when new technology comes in that you might be able to take advantage of in your systems. So I was thinking when you guys were talking just now about whether or not the IT architect is something who is, or is a person, or is a role that may be, at least compared to the software and services architect, slightly in decline today, because there is a wave towards cloud, and the software and services architecture is on a rise currently. But as to go on that journey, to get on that track, what you would need to do is be a person who takes responsibility and is active and engages and does more things. The architect is not a role for someone to sit in a closet and figure things out. The architect is an active, engaging person. Communication skills have been mentioned here as well. That's core. So there is no easy and quick and dirty fix to make a developer an architect, but you can get on the journey, and that's about attitude.
Exactly. So learning plays a key role. Now, the next question, it was asked for me. So people ask, like, in enterprise architecture, how can I pick the reference architecture from the 7 business domains and make them useful for my company? So every organization has a different set of way of working. Every organization develops different kind of products. They have their own USPs. They have their own skill sets. Because that people is the power, knowledge is the power. So they have different skill sets. So every enterprise has to work to start from the generic reference model and then creating their own enterprise specific architecture. That is also defined in solution continuum and architecture continuum. So if you read the DOGAF manual very religiously, you will find that how interrelatable they are. So that is from my side. And coming to the next question, you said that perseverance, learning plays a key role, as well as the attitude, communication. These are the other personality traits which one solution architect must have. So is it a client facing role? Is it a business facing role? And actually the architect, can we see the architect as a selling person for the company or the brand? Mahesh, this is to you.
I think let the other guys take this more, like Vishwas and
Yeah, Vishwas,
like
you can
Magnus
answer.
to take this. Yeah.
Okay, so Naveen, I'll answer this, and I'll also take this opportunity to, I have to drop for a call in another 5 minutes, but I'll take this question.
After Vishwas, this, if you can take one more question for you. This was asked for you after your session. It's on the
Sure, I can. You mean Ankit's question right
Yep,
here?
and
right?
then we will let you go after this.
No,
Okay,
don't let him go. Don't let him go.
Understood. So Naveen, your question is the architect role a client-facing role? Is there a business aspect involved? Is the sales? Did I parse it correctly? Is that what you're saying?
Yes.
Right? Is that the question? Yeah. So
Correct.
I will say yes. There is that component of that, and I'm constantly asked this question that how can I become an architect? What is that journey? What is that continuum of becoming an architect?
Exactly.
And my answer is that, look, when you start thinking about, of course, coding is important, and you have to be proficient at that, and you have to think through that. But in order to become an architect, you have to think about the other cross-cutting concerns, right? You should be able to make a reasonable case for why this architecture is important. What are the business outcomes from this architecture? Why should they go with this architecture versus other architecture? How will it improve value capability of certain things? These are all architectural functions. So when people say, hey, how can I become an architect? Well, of course, become a good developer. But then are you taking the time to speak up at Meetup? Are you collaborating with other people? Have you written something about it? Have you come up with an open source idea that you can get people to get behind you? If you do these things, you collaborate with them, you improve your communication skills, you understand what drives the business, why IT is important to that business. If you do those things in a 360-degree manner, that's your journey. And these things, no question, will bring you in front of customers, will bring you in front of your leadership, because you have to make this case. Because make no mistake, if you want to work on a project, you have to go find the budget for that. You have to make a case to someone. So the best way to become an architect is to start doing other things in addition to writing code, which I'm not denigrating at all. It's a very important function. Okay, so hopefully that gives you some insight. And Ankit, to your question, if you have an existing web API, what is the best option to migrate it to? Of course, API app is a great option. If as you said, I think your question is, should I go to API app or I should go to a function app? If you go to an API app, you have a little bit more flexibility in terms of, you have some characteristics that are baked in. You can define what kind of authentication scheme you have, and just in an API app. Now, keep in mind, function app is also running ultimately under the cover. An API app or a function app are all running on the app service plan. So, under the hood, the chassis remains the same. You'd be fine with either of the two. What you have to think about is, do you want to take easy auth, for example, take API app in that case? You want to, you don't want to worry about the cold start problem, although I should say that enterprise version of function app solves the cold start problem as well. So there are some minor differences. If you are trying to build an API which is going to be supporting more protocols than HTTP protocol alone, you have other triggers that this function can be implemented, then go with function app, right? Otherwise, go with an API app. So there may be some consideration. I can actually, Ankit, if you like, you can reach out to me. I can maybe put together a small blog post to bring out the differences between the two. But these are the ones that come to mind.
Okay. So
You want to leave?
yeah.
So we gotta let Vishwas go now. I usually don't let anybody go, but this is exceptional case. Okay, thank you so much for being here. It was
He's
very
going to
valuable.
come back. Yeah, he's going to come back. So yeah.
Thank you, Mahesh, for letting me go. I appreciate that.
Thanks, Vishwas. It was wonderful to have you.
All right.
Yeah.
Thank
Take
you.
care.
So if I can add just a little bit to the end of Vishwas' answer there, it was mean or sneaky of me to let him go before I answer, but I wanted to give him the opportunity to step out. If I were to add anything to that conversation, it would be a bit about the scale of things, right? if you are running function apps on the dynamic plan, there is an inflection point where it actually makes more sense to buy your full machines, and you can run them in a function app, or you can run them in the API app. It doesn't actually matter at that point. But when you become so large that the functions are starting to cost you a lot of money, if you're running on the dynamic plan, then you should switch over.
Yeah.
And you got to figure out where that is for you, depending on how many requests you get per second, per day, per whatever. That's an important piece there. And beyond that, if you are large enough, if you're big enough, I would seriously consider putting API management in front of it. And at that point, it actually doesn't matter at all if you're running one or the other, because you have a proxy in between. But API management will give a lot of really good features if you are on the scale where that cost makes sense to you.
Yeah, and I explain one of the, our client, the way I explain is like, depends on how much water you drink. You want to go buy each bottles, or you want to go buy a gallon of water. Depends on your needs and your, money you want to spend. If it's just a little bit, you just drink, just buy a bottle. But if you're drinking gallons and gallons, better to buy a tank.
Well, there's other ways of looking at it as well. So using your example, you could say, well, the bottles of water, the cost is better or worse or whatever, right? But then you might say, but we have other concerns, right? Like maybe we don't want to add, I'm throwing this one out there, but we don't want to add plastic to the environment. So we don't want to use bottles of water. It's a different perspective. So going back to the cloud, you could say, sure, it may be more expensive one way or another from a hosting perspective, but we also have to think about maintenance costs and where do we want to have maintenance? Do we want to own those VMs and have to support those things all the time? Maybe you do, right? Maybe you don't, right? And do you want to just have, platform as a service offerings where you don't have to have those additional concerns? So I think this is another one of those questions where the answer is it depends, right? There's so many factors that we want to consider.
After all this, you're bringing out it depends? Come on.
So
I
want to go back to the previous question where you asked, Vishwas left. There's a few important things people don't talk about when it comes to becoming an architect. And those important things are, you have to have great communication skills. Okay. If you don't have people learn coding, they learn design patterns, but they don't know how to like communicate with the teams, right?
No.
You have to first important thing is because you're dealing with clients, you are dealing with customer end users, you are dealing with the business stakeholders, you are dealing with developers and the teams. So you not only you have to have a good communication skills, but you also have good personality as well as a leadership skill. I work with a lot of architects, so-called architects, and they are so into themselves and arrogant. And like, no, I can't work with this guy. So I leave. So those are important parts of this being an architect.
Yep.
I would add to that. I was thinking similar things to what you were saying. We often tell people, well, I'm not a leader. I don't have a leadership title. You don't need a title to be a leader, right? Start leading. You want to be an architect, start acting like an architect, right? Start showing that you have those decision-making skills, those leadership skills, those presentation skills, and then people will recognize that. They will recognize that, but you have to sort of, it's almost like, dress for the job you want. Now, although look at me, I always wear a t-shirt, right? Which job I want, I guess, but Magnus is dressed for success, right? And Mahesh as well, and I'm in a t-shirt. I'm
playing Steve Jobs today, so.
I think the same thing applies, though. In other words, like sort of start being the architect. Do you guys agree with that?
Yes.
I do.
You don't have to get the title. Just start architecting things, and you will become an architect.
Right.
Yeah. So it will actually, within the team or within the organization, when you go extra mile, when you start asking questions about the ecosystem and how the solution will fit in, I think it will bring the visibility automatically that this guy asks, he wants to learn more deeper than the others are. So
critical.
then there are learning paths like Google has their own platform and learning curve. If I only talk about cloud specific, because cloud is the buzzword. So Azure has its own, Amazon has its own. So what do you suggest? What for a software developers, like most of them are in our audience today? So what path it is there if they want to learn technically first the architectures about any particular offering, and then they want to get certified, and then they want to put their value within their organization that I'm certified now, I understand these things. So what is the journey if they want to take the training route? And then do you think these trainings or these certifications cover the whole holistically, uh, all aspects of being an architect, or it's just the technical part of it? Rest the personality traits like we discussed, one still needs to develop and learn from other mentors.
And I think we can go through, around everybody can add a pitch in there.
Yes,
But you
yes,
ask
yes.
me personally, certifications don't mean anything to me. I don't really care. I don't give any, whatever certification you have. If you can show me you can do the work, that's what I really care about. Hands-on experience is more important.
Yeah, it's
But I
okay,
understand. Yeah, go ahead.
but still I think the technical certification, they add sort of charisma to your resume, and as well as it boosts the confidence that
It
yes, you have.
it does. And some people, they just learn, but they don't do a lot of hands-on
Exactly.
experience. Those kind of certifications are not, they're bad. So as long as you're doing something and you're getting certified, each Azure has its own, AWS its own certifications. You just go and certify, and pretty much most of these are what you do. And there's a path already defined. I don't know about AWS, but Azure clearly has learning curves for certifications.
Magnus, what are your
Yeah,
inputs?
no, I agree with that. So I'm in the fortunate position nowadays in my career that I don't really need much in terms of certifications anymore, and need quote unquote, but I love learning. I just don't really have the time to spend on getting all the facts straight that I would need for actually ticking the correct boxes in a certification. So I haven't done much in terms of that for a while. But that's not fair because I have 20 years in this business, and and I'm an international speaker and so forth, and I have been in Azure since day one. So that's not fair. So if you're starting from scratch, you're a student now and you want to learn, and in the future you see yourself as a wonderful superstar, some kind of architect. Certification can take you some part of that journey, but it's not super duper valuable. What's valuable is the learning that you get on that path. I'd say the journey is more valuable than the actual goal. I know that in some organizations, you can climb certain pinhole ladders inside of the org by having a number of certifications, but there's a risk that turns artificial, like Mahesh is indicating. And I don't like when, I have 25 certifications. So what, right? That doesn't tell me anything. Are you a good person? Are you good at what you do? Are you diligent? Are you thorough? Because you managed to jam 25 books in your face and get some exams, that doesn't do it for me.
So there is a mandate on me. I need to clear the Google GCP certification. So
Fine.
I mean,
yeah,
that's your
something
personal
comes
goal,
and
right?
demands
But I
it.
don't think
You
if
should go back
somebody
and say
goes,
why.
Yeah,
Anyway,
I mean,
Well, I think we have something of on the three of us, maybe not Naveen, but a unanimous feeling here. I have many years of experience in software. I've never had a certification. It's also worth noting that I have a college degree, but I don't have a college degree in computer science or anything like that. I don't think any of us would say that if we saw someone's resume that had certifications, we would go, oh, well, that's no good. They have certifications. Certainly certifications are a good thing to get, right? There's nothing negative to them, but they don't really make up for the life experience that you have on the job. They don't make up for what you don't learn in a certification, like we talked about earlier, the personality skills, the leadership, the management, the presentation skills. Certifications don't really cover that. The flip side, what I would say to people is, what have you done, right? And people say, well, I don't have an ability, I don't have a job to be an architect. Well, what did we say before? And I think Vishwas was saying, you want to be an Azure architect, open up a free Azure Azure subscription and do something, build something, show me that. That's your certification, as far as I'm concerned, right?
And to add to that, I was almost forgot. I wanted to say one more thing, and that's great that you put me back on that track. Azure has a really excellent architecture center, which has a lot of big architectures, and they don't have to be big, but and then there's patterns and practices stuff in there, so you can go and study the patterns, learn about them, and look at the architectures and understand which services in this case, obviously in the Azure platform, which services did we use to build this architecture, and why did we choose them, and which patterns are we implementing here. Go and study. It's like basically it's azure.com/architecture or something like that. It's right there. There's a lot to dig into. So go and learn about architecture. You know what they say, if you want to become a great chef, you study recipes. This is the same thing, right? So learn about it and be passionate about it, and you'll become an architect.
Yeah. One more thing I just want to add on to that, because you got me thinking. I got you thinking. Find those resources, and you know what else? Find someone that that's doing these things, and ask them the questions. Ask for their opinions. She might have some great information for you about becoming an architect, or like the decisions they make, the thought process, right? Get a mentor. Find someone who has the time that can help you. And there are people like that. Like, I don't know Magnus really well, right? I know Mahesh a long time, right? But
you don't know Magnus?
I don't know Magnus, super personally. Like we've met, and I know his background. But the point is, how much public speaking does he do? I'm going to put him on the spot here. He probably has people that he wouldn't mind, not to the whole world, but he would help. Mahesh, you would help people. I would help people. You don't have to find the three of us, though. That's not the point. Or Naveen, who I don't really know well at all, right? People will help you is the answer, right? Don't you guys agree? People will help.
Yeah.
Okay.
If you're earnest and honest and passionate and engaging and you have a personality, people will help.
Exactly.
I'm really, really sorry to have to say, but if you are a very withdrawn person who likes to sit alone with a computer, I don't see you becoming an architect. I really don't. You have to be with a lot of people to become the architect.
Well,
Okay. So
yes, I think we are going to close our panel here. We're going to continue this panel after this session. Okay, let's welcome Vidya. So Andy, if you are available, everybody, if you're available, we have panel after Vidya's session. Love you to have you back, because it looks like we have a lot more questions to be answered.
Great, I got time.
Let's everybody welcome Vidya. Vidya is one of our solutions architect, cloud architect, and genius behind a lot of programming books he's written. Vidya is going to talk about microservices architecture. Microservices are growing. That's the next wave of cloud computing.
Oh yes.
Magnus.
So kick off Andy and Naveen. Bye guys. See you in a minute.
Bye-bye.
See you, Naveen.
Okay, so
Vidya, welcome. How's everything going? Where you basically joining us from? You wanna a little bit introduce yourself?
sure.
And we are excited to have you here.
Thank you. So I'm joining from Seattle, Washington. I live in Redmond, and everything is going very well with this pandemic thing. I hope everybody is keeping safe. So thank you so much for organizing this. I think this is very much needed for the community and utilize this time to learn. And I'm really excited to talk about microservices architecture.
Awesome. Thank you for being here, and just go from it. And I'll be joining you after the session, and we'll have panels after that.
All right, sounds good to
All right.
me.
Okay. Thank you, Vidya.
Thank you. So the topic today I'm going to talk about is microservices architecture, also known as MSA. Uh, this is sort of a new buzzword in the crowded streets of software architecture, and it is becoming really prominent to learn about microservices architecture. Um, Before I really dive deep into the session, I want to give you a little bit background about myself. So um, I have like 18 plus years of software industry experience. I'm working as a principal architect with T-Mobile. I'm also a CSharpCorner MVP since 2013 and Microsoft MVP since 2014. I'm also TOGAF certified architect, certified Scrum Master, have almost a dozen Microsoft certifications, published author of these 5 books, and a technical reviewer of these over a dozen books as well. So the agenda I have, the key takeaways from this session I want everyone to have is what microservice is all about, how it differentiates from its predecessor monolith, what sort of patterns companies are implementing, what sort of mindset and culture is needed, what are the pros and cons, and I will share some of our journeys at T-Mobile as well. And I will take some questions as well as I will see and we go through. So before we really get into the weeds of microservices, it is very critical and important to understand what is monolith or even a SOA architecture organizations has been building REST APIs with. So since REST APIs or APIs are built using MVC pattern, you can think of any MVC application um, which is having all your API code base, and then you have your POJOs, that is plain old Java objects, or POCO, plain old C# objects, and you are writing all those controllers, models, views, your repository pattern and everything within one solution or project. When you do just a layered architecture that you divide your cross-cutting concerns in different layers. But entire project, entire bundle is being built together, and then it's deployed together. And you will, most of the time, you will end up having one large monolithic database. And mostly it will be a relational data store. Call it SQL, Oracle, MySQL, whatever you have. If any application is written with these settings, and then this is primarily a monolith application. Now, there are some benefits because what I learned is that architecture, there is no good or bad architecture. Architecture is all about choosing your trade-offs. Maybe based upon the trade-offs you are okay to receive with and live with, your architecture may make sense for most of the time. But are there better ways to do it? Yes, of course, but then there are more growing pains with that. So let's learn about what are the pros and cons of monolith first. So the first benefit which I see with a monolith is that you have fewer less cutting concerns because everything is built together as a one single bundle or deployable unit. You have less cross-cutting concerns. Having said that, if you build your logging layer once, that will serve all your APIs in all your API controller, let's say customer, order, payment, address, notifications, everything will work just fine. Now, next one is you have less operational overhead. The reason is because you are controlling everything as a single unit, you have less to control, you have less to really operationalize. And once you have operationalized it, just one thing to look at and really be with it and keep it up and running. So it is less complex to deploy and less overhead to manage it and operationalize it after deployment. Performance, because all the services will be living in the shared memory space, you are not making any calls or REST API calls over the network, which happens if your services are deployed in different containers or distant apart in different regions and whatnot, then you are not getting into the trap of network latency. Hence, performance is always better in monolith than in comparison to microservices. When we talk about benefits, we always have to consider and talk about disadvantages or cons as well. The biggest disadvantage of monolith is it's deploy all or none. Having said that, when a new change needs to be published or pushed to production or production-like environment, or call it non-production environment, for example, staging, whole service stack needs to be deployed. I have been in those situations when I'm making a very small change, but I have to redeploy entire REST APIs altogether to the cloud because that's how it was built, because it was following monolith architecture or SOA. Now, scale all or none. Scalability has been the biggest concern in industry always, and the more customers we have, the more we grow. Scalability is like having growing pains. So what happens with that thing is, since all your controllers, all your APIs are built once as a single unit, so you have customer, order, payment, inventory. Think about these four for now. What you are doing, you are deploying all these four together. But when we at T-Mobile, we launched a pre-order for Apple iPhones in 2019 in September, October timeframe, whenever that time comes, let's say, or any new marketing promotion happening when you are allowing customers to pre-order something and people are going crazy about it, like Apple products, for instance. Now, does it mean that we scale entire T-Mobile stack of 23 domains because we have to support that pre-order event in the night? No, because we are into microservices space and microservices architecture across domains. What we did, we only scaled those services which were prominent for that. For example, payment. For example, catalog, that you can go to catalog, search the product you want, what color you want, what configuration you want, pick that, place the order, make the payment, and you are done. So payment, our catalog services, and order management. And not inventory even, because it's a pre-order. So we are not shipping anything to you until it becomes available, right? So you have choice to really scale only those services which people want at that given time. If you are in monolith, then you have to scale entire stack up no matter what. And you have, even in that case, scaled up customer service, order management service, address verification service, your notification services. Everything is scaled up, and that is more cost, more burden, more operational overhead. Now, the other disadvantage which people have been noticing with monolith is about single point of failure. Sometimes it is also known as SPOF. Just take the first initial of each word. And that's the biggest problem in software architecture. Navy SEALs say that 2 is 1 and 1 is none in high availability concepts. I will repeat it one more time for you guys. 2 is 1 and 1 is none. Having said that, always have at least 2. So do not have a single point of failure. If a server is down, entire functionality is broken. Having said that, if there is something wrong even with one service, because all those are sharing the same memory space, what will happen is entire web services can go rogue, and we call it noisy neighbor situation as well, because one service has started taking a more thread and resource consumption where you have deployed your web services or APIs, in this case, on cloud or wherever, and then it will slowly bring all the resources down, and even other services won't be able to respond. Now, so I think we learned enough about a monolith. I wanted to give you some background about monolith, its pros and cons. Now let's really dive deep from this point onwards into microservices only. Now, what happens is with microservices is that, first of all, what is a microservice? You can take a lot of keywords here, and those keywords are that microservice is a tightly scoped, loosely coupled, strongly encapsulated, independently deployable, independently scalable, even independently testable application component. So these things are microservices, where you take one thing and then you just live with it, you just work with that. Now, what happens here is that the global microservice market is anticipated to be accreting to $33 billion by 2023. So that's the thing. All these things you see today, like AI, IoT, anything you talk about in today's world, because everything is at the end happening through REST APIs over the network. Everything is using some sort of REST APIs or APIs, and all the organizations are today adopting to the culture of microservices architecture. Now, when we work with microservices, it is very important that how do we find a single deployable unit? How do we find that which API will live in which microservice by itself? And that's the trick, and that is where the old concepts since 2003 come into the picture of domain-driven design. Now, domain-driven design has a keyword in it called bounded context. What bounded context says, bounded context can be described as an explicit boundary within which a domain model exists. As you can see here on the left-hand side, I am showing a monolith architecture, and that is where your application look like. Think of any MVC application or any web application could have been built using Angular or whatever is the framework of your choice for a front-end technologies. Now you have here a UI, and that UI is now talking to multiple controllers which are being built together as a one single project of multiple controllers. So you have a customer controller, payment controller, inventory, order, shipping, billing. All these different controllers are living as one single unit in your project. And then they all are talking to one monolithic large database, which is a relational database, of course, where all that primary key, foreign key thing, joins and all that you do. You have, of course, I'm not showing few layers here, but those are understood that there will be a repository pattern and your business logic layer and data access layer and your logging and security and all that good stuff you will have, of course, in your layered architecture. Now, if I really want to give you maybe 10, 15,000 foot view at a high level, how this thing can be transitioned into microservices architecture is look at the right-hand side now. So you have your application, a UI, your front-end thing, and then that front-end now has been talking to multiple small, independently deployable, independently scalable microservices. Having said that, if you want to really visualize and you are hands-on developer, think of taking your customer controller out from that one project and making itself a new project. Means it will produce its own deployable unit, it will build and publish by itself somewhere to an endpoint, and you will hit that endpoint to talk to it. And not only this, you will also have its own dedicated database. It could be relational, it could be non-relational. We can talk about it later, but the keyword here is it will have its own separate database. Means you have even broken down this big, large monolithic database into multiple small databases. That is what microservice architecture is. So I hope this makes sense. Over the period of time in this presentation, I will talk more about it, and keep posting your session, your questions in the session here. We will see what we can do about those. Now, I want to really give you some real world examples that how microservices are connected and utilized in the world today. Now, this is something which I'm showing here how microservices in action will look like. Now, if you see this entire screen on the left-hand side, I'm showing a composite UI. This is, I think, a very old user interface, the real web page of Amazon.com. Now, why I picked that example is because Amazon is really good at doing it. Netflix is doing it. We at T-Mobile are doing it. Many large organizations call it Uber, Facebook. Everybody is doing it. But the key point here is that how it works actually. Now, if you see this entire screen on the left-hand side, which you are seeing here, and I have done some red framing for you guys, is that these are 7 sections. So 1, 2, 3, 4, 5, 6, and 7 at the bottom. This is 7th one. Now there are 7 sections in this UI. Now consider that all these 7 sections are showing some specific functionality or capability on Amazon.com. And all these functional areas supposed to retrieve data from some backend, of course, right? You depend on some backend systems to pull that data out. If you are really building a small application, your backend is just your data store. but large companies, they depend on payment domains. Now, at T-Mobile, we have our own payment domain, which is in-house payment domain. We call it DPS, Digital Payment Services. Similarly, we have Digital Billing Services. We have DFS, Digital Finance Services. And then those domains talk to further, backend systems. So our Digital Payment Services talk to further, some payment acquirers. For example, WordPay. For example, maybe some bank which process the payment which we receive from the customers. So when we take your credit card information, we pass it down to our digital payment services team, and then they pass it down further to the payment processor, for example, WordPay or a bank, for instance. So these 7 sections are actually connected to these 14 services over here. Now, these are the backend services, total 8, and then these 6 are the UI composition microservices. Means this section, if I see the second section from the top, you see that component composed view model. This has one microservice, and that microservice has the capability to talk to one or more backend services. Means we call it scatter and gather pattern. In microservices world, it is also known as aggregation pattern. Means one microservice will be invoked by the UI, and that microservice will go to the backend, make multiple calls to different backend systems, bring data back, massage it, scrub it, and give a JSON response back to the UI, and that's how UI will work. Now, this is how microservices are composed. At T-Mobile, we do the same way. Amazon does the same way. So this is a pretty proven pattern in software industry, and all the organizations which are really high-performing software organizations and have leveraged microservices architecture. Now, I hope you understood what was monolith, how it looks like. I gave you the 2 screens of the image of monolith and then the microservice. I will keep showing you microservice architecture here, so it stays longer with you. Let's talk about some of the advantages of microservices. So it brings a lot of advantages, a lot. So first example, the most loved one in industry is the scalability. You do not have to scale everything. Many times people think I have cloud, I can scale whatever I want. Yes, of course you can, but do not forget that cloud is always pay as you go. The more things you scale, which you don't need maybe, your cost will keep recurring. You will pay more money to the cloud providers, right? So scalability is the biggest thing because you have flexibility in your own hands to only scale what you want to scale and nothing else. As I gave you one example of the Apple iPhone launch in 2019 and how we scaled only some services and not everything. So if you see here, you can scale only the service which is in need at that given time up to whatever level you want. Now, second thing is easier deployments. Why easier deployments? Because every service is independent of itself. So if you want to make some changes in customer and you have ensured, because everything is exposed by some API contract, as long as you are not breaking the contract with your consumers or the clients, you are fine to make any changes and deploy it or launch version 2. There are all that good practices and principles and best patterns available to follow along. So if you make changes in customer, you only deploy customer and everything else remain untouched. You don't deploy that. Now think about the time it takes. Think about the effort it will take for test and certify that you can deploy that change. The only practices you need to bring in is a very heavy investment into unit testing, a very heavy investment into good DevOps practices, because it takes a few things when you go with microservices architecture. Now, the next one is problem isolation. I think I already explained it. If something goes wrong with customer service, the rest of the service will stay untouched. There will be nothing happening to those because of problem isolation. That problem isolation is actually achieved inherently by microservices architecture, because microservices architecture by itself, innately or internally or naturally follows single responsibility principle. Just FYI, single responsibility principle is the #1 principle in solid design principles. Also, when people work on microservices architecture, it really develops or generates a deep domain knowledge. As I gave you some examples at T-Mobile, we have different microservices teams and different domain teams, of course, then only you can do microservices architecture. What happens in our space is we have teams like a digital payment services. So that team now owns a payment domain. So they have built a lot of deep knowledge about how PCI payment card industry works in this case. Now, the other one I want to talk about is polyglot programming. A polyglot means that you can take advantage of multiple programming languages. Since every microservice is different by itself, think of that whatever microservice you do, you can develop those microservices in different programming languages altogether. Means there is no foundation or restriction on you that you have to use only .NET Core and Service Fabric, for instance. If you are comfortable, you can write inventory service using Java Spring Boot, and then you can use a MySQL, whereas customer service is written using .NET Core, Service Fabric, and a SQL Server. The third one can be written using Python and Oracle, whatever you want. However, there are some problems with that approach because you have to maintain multiple programming languages. Not only that, you also have to maintain different knowledge bases. And if somebody leaves that team and microservices built using Python or Java, Spring Boot, or .NET Core, and you are not familiar with that thing, then you have acquired a learning curve, and then you have to work with those things. Now, I think we talked enough about advantages, and I hope and trust that that gives you a very good insight about why companies are really going behind microservices. And as I said earlier, architecture is all about choosing your trade-offs. You are always aware what risks you are falling into, what sort of pains you are going to accept that, yes, I will live with it. And that's why, a great freedom comes with great responsibility. So if it is giving you freedom, there are a lot of responsibilities and of course, pains. So the biggest disadvantage or a pain point I can say is a cultural change. I have not seen any team or any organization just waking up one fine day out of the bed and say, okay, today we are going to do microservices architecture. There is no such thing in this world. And if anybody does it, you will fail, miserably. So do not do it. It's a cultural change. Your leadership, your CTO, CIO, your VPs, your directors, all of them has to be aligned and agreed that yes, we are going to do microservices architecture because these benefits are more valuable to us than the disadvantages we have in hand. And we are okay to live with it because we are customer facing organization. We are building a line of business application and customer comes first. Business agility is key for us. And we want to live with microservices architecture. And it's a heavy investment, let me tell you that. So it's a cultural change, first of all. You have to change your mindset to adapt that culture and then get into microservices. As you will be breaking your multiple services which were living and built together maybe by one cohesive team into multiple services, small microservices, it is expensive in a way. You have to spin multiple projects, you have to spin multiple pipelines, you have to have multiple DevOps people, multiple Scrum Masters for each team, and things like that. So you can multiply all those factors, and then you will realize, oh, yes, it is more expensive in a way. Since I talked about expensive and cultural change, it is complex as well. Why it is complex, I will tell you in a very easy manner. I will let you live with this phrase that microservices has more moving parts. The more moving parts you have, the more complex it is, because there are multiple services, as you can see on the image I'm showing on the right-hand side of the screen. You have multiple services, multiple database systems, and as you might have realized by now, if you have any background in database systems, is there's no primary key and foreign key relationship here because they all are far distant apart databases. Not only that, they are different data stores as well. There is no guarantee that customer information is stored in a relational data store. Chances are it could be NoSQL because you read a lot of information about customer. When you log into any website, you log in, what do you see? You see your customer information, your profile comes back. And that is most of the time it's NoSQL because that thing is read heavy. So whenever we are read heavy, we use NoSQL for that. Now, since we talked about all these three bullet points on the top here, the fourth one, of course, is less productivity. It is less productive in a way because you cannot quickly deploy things faster. You cannot quickly make changes and test everything together. So that's why it is a little bit less productive. But I have seen teams, even we at T-Mobile are at that stage when our productivity is going high because we adopted that culture very well. We have placed best practices and principles and culture and approaches and that mindset in place, that which is making us to achieve now productivity the level we want to be. And we can proudly call ourselves a high performing software organization. So there are some best practices you need to live with and really adapt to really be productive. But at initial stages, for few months, for few years even, you may end up with less productivity. So the other one is communication between services. Remember the fallacies of network computing. There will always be latency. There will always be hiccups between your REST API calls you are making to other container services, Kubernetes, web APIs you have deployed on cloud anywhere, or the REST endpoints, just call it that way. Now, those things will keep happening. So communication between services will be a problem. You have to really think far. How do I design services that if one service is down, what do I do? And I will give you a couple of examples how we are solving those problems at T-Mobile. Harder to do integration tests. I do hope you know the test triangle. The number one, if you put the triangle like this at the top, of course, at the top are always the UI tests, your functional automation tests. It is not advisable to have so many UI automation tests because if you change something in UI, your test will start failing miserably. Now, number two comes down to integration tests. And that is where the pyramid becomes a little bit wider. And then at the bottom, which is the most wider part of pyramid, is your unit tests. So that is where you put the unit test means if you do microservices, you have to really do amazing job in writing unit tests. And of course, you can do integration tests, but it is a little bit harder to accomplish because of making calls to the other services and whatnot. But it's only hard, it's not impossible. So just be aware of that. Now, with microservices architecture, as I said earlier, since there are so many moving parts, you have to really begin with your architecture with the right approach. Sometimes this statement may come like a little bit in a challenging approach that can somebody create architecture which is well defined from the beginning? Answer is no. You cannot do that all the time. So what we do is we think about all the right pieces, right approaches, put proper thinking in place, just be a little bit more diligent how you're designing things and make those decisions what to pick. For example, in architecture, there are few decisions which you can change and there are few decisions which you cannot. I will give you one example. Can I change my caching architecture? Yes, you can. I'm living with now Redis cache. Tomorrow I can go with Gemfire, right? That is easy. But how about changing a programming language altogether? I started with Java Spring Boot. I wrote entire microservices having few 100,000 lines of code. And now you want to change that programming language from Java to C#. This is very hard. You should not be doing that. If you do it, you will end up having a lot of money wasted because you did something in previous language and now you want to rewrite it. So there are things like that which you can change, which you cannot. So be aware of these things. And then the next one is, I want to give you some insight into, I hope you have become more interested now to think about how people are doing it, because as I said, nobody can wake up and just begin with microservices architecture unless you are a brand new company who is going completely greenfield. You are starting something brand new, then you can begin with it. But most of the companies do not. They slowly migrate their SOA or monolith applications to microservices architecture. So first step is that do not switch from monolith to microservice all at once. Do not do it. There is no way you can transition overnight into microservices from your long-lived monolith or SOA application. So remember I told you that you have your MVC application where you have different controllers, customer, order, payment, notifications, all these controllers you have. Now just take only one controller out. Take that entire code, models, its logger, its repository, business logic layer, whatever you have, take it out into a separate project and then start building it. Having said that, we are trying to accomplish divide and conquer. So you have to inspect your monolithic system to see what it hurts the most. which one is the one which is having more pain point, which one you deploy often, and then you are deploying the entire website or entire web application or entire REST API stack you are deploying. So take that thing out, start building it separately, and then slowly transform that part into a microservices so you can deploy only that without impacting or touching your rest of the API controllers, which are still living in the monolith world. And once you are successful here, you take the other piece out and then the other piece out. So take the steps like a crawl, walk, and run. Do not try to accomplish big bang that you want to accomplish everything all together unless you are greenfield. Now, there are few patterns and principles and best practices I also want to share with you that whenever any organization is doing microservices, owning microservices becomes very critical, that which microservice will be owned by who, which team will own what. And since you have so many moving parts in microservices architecture, what happens is, unlike monolith, of course, what happens here is that you will end up having multiple teams, and that's why it becomes more complex and less productive, and cultural change, that each team will own 1 or 2 or 3 microservices in this case. Now, so if you have a payment team which owns only payment microservices, and if you guys are thinking that what is so much in payment that we have to have a separate team, and how big of a team that would be. So I will give you one more term here that is called two-pizza team. A two-pizza team is a term which Amazon, I think Amazon provided that term long ago when they started. And two-pizza team means the size of a team should be able to be fed by 2 large pizzas. So think about it. If you have 2 large pizza, how many people can be satisfied with that? I would say 7 to 9 people, plus minus 2. So that is exactly the size of an API team or a front-end team. If you remember that image I have shown earlier of Amazon.com, where you had 7 sections in the UI and 14 microservices. So in many companies like Amazon, even we at T-Mobile do the same. Even your UI is divided into functional capabilities. So somebody owns only payment part, somebody owns only account management, somebody will own order management, and they build only those components in the UI. And then they talk to those microservices team, which provide you the capability to serve the functional behavior to the UI. So your API is the technical side of it, your UI is the functional side of the house. So coming back to the point here, if you see, team 1 is owning payment and order, and team 2 is also owning order and billing, means order service is now owned by 2 teams, which is completely unfair and nonsense. If you also see here, a shipping service, nobody owns it. There is no team which says I own shipping service. So when you divide your teams into microservices land, be aware who owns what. And there has to be clear definition of owning it. And then the ideal will look like that. So any services can be owned by any number of teams depending on the budget and the size of the team and how you are evolving in the microservices culture. It will take time. It's not easy to spin multiple teams. At T-Mobile, we have a few dozen teams who work together to make applications work. And then what happens here is you can also debate how would I choose which team owns what. So the more experienced developers and leads and DevOps resources can own more complex microservices, maybe 1 or 2 together, but they should not own more than 2, I would say, because then it becomes more complex for them. And smaller services can be combined together. Some services which are not changing often, for example, cart service. What do you do in a cart? You add item to the cart, you delete item from the cart, you can increase quantity in the cart, you can save later. These are very limited functionality a cart have on any e-commerce website, right? So cart service is a very small, lightweight service, maybe not many changes happening. So any team can own it. You can slide it to any team and that team can start owning it, right? But at the same time, each team has to have their own CI/CD pipeline, DevOps practices, dashboards, monitors to really monitor and have the pulse that each service is up and running at all the given times. Now, as you can see on the right-hand side of the screen, the service ownership is called as STOSA. a single team owned service architecture. If you want to learn more, you can go to CSharpCorner. You can read my article about it and then learn more about STOSA, or single team owned service architecture, where I have described it a little bit in more detail about it. Now, when we really divide microservices, and as I said earlier, there are so many moving parts, it becomes very critical that you really decide how microservices will behave together. So this screen is a Netflix's screen, if you have not recognized so far. So what happened in Netflix is they show you different banners, right? So they show you watch it again. They show you everyone is watching. They show you continue watching, right? They show you all these things. Now, think about how this data is coming, how Netflix lays out this data, or how even we at T-Mobile show you all that data which renders on your screen. If you go to let's say you ordered an iPhone or any phone you ordered, you go to order details page. We show you so much information there, even what credit card did you use, what is your billing address, what is your number, what phone number do you have, what is your address, where are we shipping it to, what device did you order, can you track it to UPS or whatever, right? How do we show all that information? There is no one microservice we are making call to. I have designed architecture where we are making call even to handful of microservices. So you have to really be aware of how we are pulling data from, where that data is coming from, and what are the consequences if one data is not available. So the example I'm giving you here is, what if a microservice which is showing you everyone is watching goes down? What will happen to your Netflix screen? Does it mean you will say that entire Netflix is down? If it was monolith, maybe, because what you do in that case is you expect 200 response from the REST API for everything altogether collectively. But in microservice world, this is not possible. You cannot rely on 200 coming from every single service, and then only you will present the screen or data to the customer. We are living in a world where customer is the king. Every company is going customer first mindset, customer obsessed. You have to do something on your own so customer doesn't feel the pain. And as I said earlier, you cannot have a single point of failure. Remember, 2 is 1 and 1 is none. So all microservices are deployed in some sort of high performing, highly available, highly scalable containers in Kubernetes or Azure Service Fabric and wherever in the cloud or on-prem, depending upon your hybrid architecture, of course. What happens here is, if Netflix feels a glitch or a hiccup to pull data from everyone's watching microservice, they will start showing you trending now, even though they still show you that. Or what's new, or you may be interested in watching this thing. And by the time you, with your remote, you will go up and down in the screen. Where is everyone is watching, or where is continue watching and your profile name, as I'm showing at the bottom. It takes only few milliseconds, few hundred milliseconds to have recovery of that microservice which was down, because by then your load balancer will start transferring data to the next container deployed in your container yard, maybe Kubernetes or whatever you are using, or Azure, and then it will start receiving response back, and you will see, oh, here is the banner I want to continue with, right? So that's how things happen. Now, let me give you a few more examples about it. Slowly we are building. So there is something in industry today is called 2-second rule. We at T-Mobile also follows that. What 2-second rule mean is that every single thing should happen in 2 seconds. Means your website should load in 2 seconds, order should have been placed in 2 seconds, payment should have been processed in 2 seconds. And if I want to do whatever, I just do it in 2 seconds. Is it really possible? So first of all, what is 2-second rule? Let's understand that. So 2-second rule is a very loose coupled or a loose principle that a user should not need to wait more than 2 seconds for certain types of system responses, such as application switching and application launch time is the common one. And that's why many people who expertise in a user experience analysis for websites, they want to see how quickly your website launches, which section is on which side of the website. Like they see, a usability of your website. If your website or blog or whatever takes long to launch, you lose interest. We are living in the world where every human being is having less and less attention span. Our the time span for attention is going short and short. We have no patience left. And that is fine because there is so much information flooded around, and that's another problem. We have so much to digest and assimilate and really pick and choose which one is right and what I do with that, right? So 2-second rule is really prevailing and taking part in it. But having said that, how do these high-performing software organizations do it then? So let me give you one example. Let's say I am placing an order, and this is a real email from my own personal email ID to Amazon. So what if you have ordered anything online on a really nice website, for example, Amazon, or whatever you use for your own purposes? If you see, what you do is the moment you add an item to the cart and you say place order or buy now or whatever it says, you will see, just like a flick, you will see order confirmation page, right? Now, let's break it apart. What is happening in the background? What is happening in the background is, do you think that your order can be placed just like that? Just on a click of the button, and they took your order and they will process it and they will ship you the item? No. What they do is, what are the steps involved in this domain? Now understand that. Once you have placed your payment information and you place the order, what has to happen in that case is, they need to verify whether item is available in the inventory or not. That is step one. If item is available, let me take the credit card information and verify that credit card information entered is correct, and then secure the payment authorization, right? So all the e-com companies like we, T-Mobile, are also e-com. We are in retail also. We have B2B, we have B2C. So we are pretty wide software company in telecom space. Now, what happens next is, no e-com company can charge your credit card until they ship you the item. They do not charge you. So what they do, they only hold the payment authorization of that much amount onto your credit card. Means if you have $100 limit and you are buying a $50 item, they will hold $50 on your credit card limit until they ship you the item. And once they ship it, that amount will start reflecting in your statement on the credit card. That's how companies do. So they have to get do the inventory check, secure payment authorization for the amount which you are buying an item for, then send that information to the shipping company, shipping domain. Can you ship it to this zip code which this person is asking this item, right? And then place the order, and then wait for 200 response code from all these services, and then only show you the order confirmation page. Now, you might think I can accomplish it by firing asynchronous API calls to multiple things, and yes, that's how it happens. But many times, what if your inventory service is down? Think about it. What will you do? Will you keep retrying? Yes, there are retry patterns in resiliency. Resiliency means an application which can fail fast, which can self-heal. It's all resilient architecture, right? Now, does it mean they will wait for inventory service to keep retrying after every 200, 300 milliseconds, or maybe after 1 second? Then you are on the screen for 2, 3, 4 seconds already, but you receive nothing. And what you do, you get fed up and you go away from that. Or maybe your system will hang or whatever can happen, right? You lose interest in that. But this is not how high-performing software organizations do. What they do is they show you immediately order success. And what did they do? They put that thing, once it started failing, they put that in a queue. That queue will keep retrying. And once they receive the response, they will process your order. So this email, it has happened with me a couple of times, not just one time. And I do know how it happens and how it works in the background. So what happened here is that they processed the order just to show me order confirmation. When they went in the background to inventory, maybe by the time they had a last known good number of the item which were living in the inventory when they were taking order from me, maybe that item was gone. I'm sure Amazon has the capability to try to ship that from different warehouse, if not in Washington or nearby. They can send it from Los Angeles, from Oregon, from anywhere, right? Nearby, of course. But if it is not available in any warehouse, then they will politely send me an email like this: order cancellation, that we could not fulfill your order is canceled. And anyways, they didn't charge me, so I don't need to bother about it. But why did they do it? They did it because this thing is okay, because they tried in the background to fulfill my order, but they could not. But they win my trust at the beginning that, oh, this website is too fast, and they always keep multiple items and inventory check handy at runtime when you are placing the orders. So they do all these good stuff just to be sure that they are really following 2-second rule. At T-Mobile, we do the same thing as well, and we do certain things to really make sure that what happens. So I want to also talk about a couple of patterns here, which we at T-Mobile also following along. The first pattern is a bulkhead pattern. As you can see, bulkhead is a term actually which comes from the shipping industry, like boats, ships, cruises, all these things. And it means is it's tolerant of failure. That's what bulkhead does in ships. So as you can see on the image I'm showing on the right-hand side, which is a boat, you see those two vertical partitions which divide the boat into 3 sections. What happens here is if there is a water leak or a damage in one section, the water will not flood into the entire boat. Rather, it will lock itself into that small section. Every ship which is sailing today in the ocean or even being built is being built with this mechanism. So this bulkhead approach really works well for ships to lock the water body within a closed room with really airtight shutters and doors, and so water locks in there and it does not flood into the entire ship and have it sink into the ocean. So having said that, how do we bring that pattern to the software field? Let me give you a few examples here. So there are few problems which we have in industry, in software especially, is propagation of failures. So let's say if one microservice or one service go rogue and it starts failing, then what happens is it started consuming resources more and more than it required to, and then what happens is the other services started failing as well. This is also known as noisy neighbor situation, because one service is taking so much resources that it's so noisy in a way that other services cannot live in peace or cannot do their own thing. And it also comes to unusual demand. So I will give you one example of how we solved that problem at T-Mobile. So think about the left one. In left image, I'm showing microservices A with connection pool for X and Y. So there is only one connection pool. I'm talking about bottom left section, where there is one large connection pool talking to two microservices X and Y. Now, let's see what example I'm going to give you, which is a live example. So at T-Mobile, I'm working now with a B2B team, which is business to business. So we serve large enterprise customers, military, government, education, small enterprise customers as well. Now, at T-Mobile, the consumer line, like I am also a T-Mobile customer, you can have up to 20 lines. If you are a normal consumer, like a household, you have family members, I can add up to 20 lines in there. Whereas for B2B customers, you can have up to like few thousand lines, right? So let's say I'm a brand new customer and I want to utilize T-Mobile services, and I want them to spin me 1,000 lines and give me all Samsung phones or Android phones or Apple or whatever, right? So I say, okay, give me 1,000 numbers, which I will give to my employees. Now, we at T-Mobile for Business or B2B team I belong to, we do not process that. It goes to the billing team. Billing team will provision the number and create the billing account for them, and then provision those numbers and work with the different backend system. Then digital payment services team will take the payment processing and whatnot. So how do we do it is we take that order and then we process it in the background. So it's a bulk processing basically. That's the keyword I wanted to accomplish here, but I wanted to paint the picture for you that how we at T-Mobile are doing it in the background. Now, think about there is a microservice which we have, right? Microservice X, which is working fine for any customer who has like 20 lines or so, because it's very easy for us to spin and it takes like a few seconds to have all the 20 lines spinned and provisioned and payment to be processed, billing information to be passed to different domains, receive response back and show success, right? Now, what happened in this case is when we do this and you have now a bulk processor, if we use the same connection pool for that and create a separate microservice, which is bulk processing, now that connection pool will have more resources to be provided to microservice Y, which is bulk processing, than microservice X. And if our 20-line customer come, that person will be in pain because connection pool provided all the threads and resources to the bulk processing service. So what we did, we have two separate pools for microservice A, X, and microservice Y, means for a bulk processor and a normal processing services. And that is what we call bulkhead, a pattern where you divide the things. Now, the second pattern is called as CQRS pattern, which stands for Command Query Responsibility Segregation, which means that you are separating reads and writes separately to two different data stores. And whatever you write will be synced or replicated to the read data store through replication. As you can see at the bottom, all the changes are being synced to the read replica. And just FYI, read replica is always NoSQL. That's the very ideal design of a database system to have. Now, I think I talked enough about microservices architecture. I also wanted to share a few things with you that those days are gone when people were living with, North Star architecture. I do not believe in North Star architecture anymore. There is no such thing. Companies are always evolving, markets are always disrupting, new patterns keep evolving. So we at T-Mobile always look for new things, and same every other organization is doing or any other architect is doing. So what happened is, as you can see on the screen here, we talked about monolith, then we had front-end and back-end systems with layers, of course. Then we talked about microservices, where you had one API gateway, monolith front-end, of course, and then you had multiple APIs. Now, we at T-Mobile are here. We are not only doing microservices, we are doing micro front-ends. Means we do have a base application. Think of a container which has a header and a footer and the menus and all that. But in the middle, you will load the micro apps or the micro front ends you will load for the customer journey, whatever it is. So we do have multiple micro apps for payment, for account management, for upgrades, for checkouts. We do have different micro apps which we load in our main container application. And then we have multiple microservices which are capturing it. So micro front end is always customer journey specific. For example, a customer is on the website and that person wants to make the payment. So we do not load the payment screen. Rather, we load a very small single deployable unit, a very small micro app which has only payment capability in it. And you can only make payment there. You can do nothing else. So that is where we are going, and that is what the future of architecture look like. And that is where we are, and we keep evolving. Micro app ownership is very important to understand. How do you own it? So if you have multiple micro apps, you will have, of course, styles, forms, validations, and API calls and whatnot. Do not own horizontal, rather own vertical. So always own the app vertically means one team, just like remember how microservice architecture was. Always own entire stack top to bottom. Do not own horizontal of multiple micro front ends. So having said that, do not own styling of 3 apps, rather own one single app top to bottom. With all these good, I think, advices and some patterns I tried to share, I will end this with a thank you note. And I hope you enjoyed it and you learned something new about microservices architecture. This article, by the way, is also published on CSharpCorner. You can go and help yourself. There are many other people who are writing on the same thing on CSharpCorner as always. So go utilize the resources, make yourself aware, and thank you so much once again for listening.
Thank you for talking to us today. That was very, very informative. I was just sitting, I was drinking it in. That was great. Thank you.
Yeah,
You're welcome. Thanks.
that was great, Vidya. I mean, I got a lot of things clear for me today on microservices.
Absolutely.
Great.
I'm gonna yell at some of our teams, say, hey, we gotta move to microservices.
All
Do
right.
it
Sounds
small
good.
pieces at a time,
Yes.
Absolutely. So
That
how are
was-
things over in Seattle right now? I'm missing it. I've been there for MVP Summit and all things.
I know.
Excuse me. Yeah, we definitely missed the conference. We missed the summit. Vidya is alone holding the fort there in Seattle.
Yes, trying to.
So we have some questions here. From we'll start with the audience questions. Looks like we have few minutes, and then we will have. Are you staying for the panel, Vidya?
I can.
Okay.
I don't know. I have to see.
Let's start with some of these questions for microservices. I think where's Simon? Simon, you there? So there's a question about how SOA, service-oriented architecture, and microservices related to each other.
So what was happening in SOA is basically they are not related. In SOA, what was happening is teams were having some sort of service bus or enterprise service bus. That's what SOA was doing. With microservices, we do not rely, or companies do not rely on service bus. They are going away from those patterns. Rather, what they do is that they will build some sort of a queuing mechanism and then events and streams to really pass messaging between the systems. So if you have heard about Kafka or Azure event notification hub and things like that, so every microservice will not push the change into a service bus, which will carry it across the domains like SOA does, but you will just publish it to a Kafka event stream, and then there will be a subscriber which is different domain, and they will go and listen to that event and bring that data into their system. So that's at a high level a difference between SOA and microservices, and they are not related.
So I have a question, right? You said in the end of your session that you need to own the whole, vertical, soft, whatever you're building, everything, right? Does that mean that full stack developer become more priority now than I'm the backend developer, I'm front end developer?
Many companies are going that way, but I will give you my perspective and very honest answer. It is very hard for anybody to really master both the things because technology is growing so fast. However, what they can do is they can really have strength in one area, for example, backend or front end, but they should be aware of the other side of the house. But I really believe that I don't believe that anybody can write both end to end in today's fast-paced line of business enterprise applications.
So in your team, you still have people who are just more experienced and expert in the UI part, and make sure that they also know the backend side of it.
Yes, that's correct. Yes. So we are bringing that culture of full stack. When we hire, we look for full stack, but we also do know that it is very hard for any human to be master of everything, and that's not what we want. We want to invest in the strength of people. So if somebody is already strong in backend, then we use that and we pair that person in a team who can be a senior engineer or principal or dev lead or whatever with front end, and then these two people continue to own that entire stack, top to bottom.
Yep. So Andrew has a question. What is the better way to reference data between bounded context? I was wondering with that as well when you showed me hey, this is different databases, and then obviously if I don't want to change my one big database into multiple smaller databases, can the microservices architecture be applied there or no?
Yes. So that's what I was saying earlier, like take baby steps, crawl, walk, and run. What you asked me is sort of a session by itself, that how to transition from monolith to microservice. And that is one of the approach which you mentioned. But when you are doing it, you can bring your controllers out from your solution or project, but keep the database layer same and your repository layer same, but deploy only the API endpoints to different containers. That is level one. But do not live with it. If you continue to live with it, you will have some different problems in future. The reason is you cannot deploy them separately, because whenever you deploy something, you have to test entire functionality, because maybe you make change in the database and that change is part of one large monolithic database. So that's why you will have more ripple effect, and the principle of microservices, like independently testable, you will get away with it. When you need to scale it, you cannot do it. What if you have customer information, and customer information is always read more than entered often? So think about, if like I'm a T-Mobile customer, or you are any telecom provider you have in your continent, how many times have you gone and changed your information? You always read when you log into the account. So customer information is always read heavy and less write heavy, right? So what you need to do is you need to do NoSQL. So slowly do step by step, do the microservices controller level one, keep database same, and then slowly take databases also apart, and then break it into smaller databases.
Yeah. And then Andrew has a question, this right here on the screen.
What is a nice way to reference data between bounded context? So basically, that's a very good example. So very good question. Let me give you some background. I will take a few more seconds here. So first of all, what is bounded context, right? So bounded context is where your functionality lives, and how do I find bounded context? Let me give you one real world example for that. What happens? So let's say you are living in a SOA or monolith application, right? And you have to you are building a functionality to send email to a customer. And you already have a customer controller. You already have customer controller.cs class. You have this model and all that information available to you. And now new requirement came that we want to send an email to customer whenever order is placed. Most of the time, believe it or not, 90% developers will write that functionality in the customer controller itself because they think it's a customer information. But per bounded context, it's not customer. It's a domain by itself. It's a communication and notification domain. So if you are a smart dev and you are thinking with domain-driven design approach, you will create a separate controller by itself, no matter there is a one small 10-line function written to just send email. Maybe you use SendGrid on Azure to send email free of cost, right? It's a very lightweight function. You can copy paste from internet anywhere and start sending email. So how do you find it? Do not look who is using that information. Look for where it belongs to. Now, customer is passing credit card information. Who it belongs to? It belongs to the payment domain, not to the customer. So similarly, put that lens through, and you will be able to figure out how to differentiate between data between the domains. Also, one more thing, it's not very easy at times. So do some sort of a joint application design sessions, talk to other fellow architects and analysts in your team, and then understand and agree upon where we put this data, in which domain it belongs to.
All right, great. Naveen, you go ahead. You want to start the panel and continue with questions?
Yeah, hi Vidya, on the second
Naveen.
part of the panel. So, and welcome back Mahesh and Magnus. So we had questions, so we will continue where we left. So we talked about architecture, different architectures, microservices, SOA. We talked about cloud, enterprise architecture. So when we create this architect, do we need or use common set of tools, and is the architect who is aspiring architect, they need to learn those tools? So what are the common tools which are used to create the architecture? So Vidya, to you.
So, well, I mean, I do not know any architect today who is using those old, like there was RUP, relational unified process and things like that. So I do use tools. I use Visio. I use Lucidchart. There are multiple tools available which can be used to create the architecture. But I do not want to prescribe or say that this is the best tool to use. Whatever your company has, use it. But I will leave you with one thing, that at T-Mobile, what we are doing is many architects do not create sequence diagrams. So it is very critical for team to understand. And what I have learned so far is that architect's job is to be very effective. If the problem most of the architects have is that whatever they do, it never sees the light. It just goes somewhere in PowerPoint decks, and somewhere in the repository it will live. But developers doesn't know even what architect has done or built. But I am the kind of architect who will go and work with developers and tell them, hey, if you are working on this thing, I already created a sequence diagram for that. Go and use it and tell me where are the gaps and what you discovered when you are developing it. So we both collaborate with that because I want my artifact to be utilized by the developers. So when I'm working with T-Mobile, when I was with B2C team for prepaid stack, I owned entire vertical, as Mahesh was saying earlier, entire vertical for architecture for payment and order management. There I created like few hundred sequence diagrams for all the different customer journeys on these two domains and pillars. So there are free open source tools. So we use PlantUML. It's a very easy to use tool. You just write plain English, draw arrows and all, and it says, okay, UI calls API gateway calls this microservice calls digital payment services, response comes back. Is it synchronous, asynchronous, and all that? And that's how we do it.
Okay.
So
And
come back, Andy. I think this is good. I think Andy and Magnus, and then I'll share. What are your most go-to tools every day when you are doing architecture? Either it's diagramming or writing or building. Just 3, 4 tools, just names.
Whiteboard.
Yeah,
yeah, yeah,
Visio, if I want to keep it, right?
Yeah, I mean, for me, Visio is I live in Visio, uh, and then I also do some, some I use combine the PowerPoint and Word as well. Depends on who can do what can do what. Like PowerPoint is these days being more amazing every day. They have nice
Mhm.
icons.
Yep.
So yeah, we have
So
to just figure it out. I think architecture is something like there's no unified tool.
no,
Uh,
not really. I could add one more, or one aspect more. If you're doing a lot of cloud architecture, where the cloudy pieces are interconnected, a lot of different services. Microsoft is in fact building a bunch of architectural diagrams and relationship diagrams into the Azure portal now. So you can basically go and select your things and literally see exactly what is running in your environment as a diagram. And those are getting better and better. I'd say they were not great to begin with, but they're getting better.
Okay.
And the coolness about that is that is not a picture of reality. That is the reality. You can literally click on, oh, there's a VM or whatever the thing is. You can click on it and see the stats for that thing pop up right there, and that's pretty crazy. And I wouldn't. That's a nice tool.
And
Andy,
I know one more tool that's getting famous. That's draw.io.
Hmm.
So more and more people are using it because it has different add-ons to it. You can create BPM charts, UML, whatnot. So Andy, to you. So do you use except whiteboard? Yes, that is any architect's first duty to pick up the marker and stand on the whiteboard. So
yeah, I was going to say that Magnus was when he mentioned some of the online stuff. I was thinking about the Azure pricing calculator, which isn't really necessarily an architect's tool, but it's good to point out that there's a pricing calculator that can be pretty helpful. I don't know if I put it super high on a list of like tools. The next, I would say the tool is conversation. I know that's maybe not what the answer you're looking for, but nothing beats conversation, getting people together, which is hard to do right now, that's for sure. And discussing things and letting people ask questions and sort of debating might sound like a strong word, but just that back and forth of like, well, what do you think? What do you think? I disagree, and debating.
yeah.
Yep.
So for enterprise architecture, wherever it's concerned, so all the designs, all the matrices, RNRs which has to be created, contracts, they all go into a central repository. So they had to be stored in a particular format. So we use Visio, we use Word documents to explain the Visios. There are two type of architecture diagram, that is HLD and LLD. Most of us, I believe, we use these words on daily basis: high level diagram and low level diagram. So when we take a deep dive, then question comes in: how do you distinguish HLD? I think HLD is for just selling the solution to a larger audience, while LLD is to put it to implementation. So what do you think about that, Mahesh or Vidya?
Well, these days, right, we are going away. More and more software architects and the teams and the companies going away from detailed diagrams or detailed architecture diagram, because the agile is there. In agile, everything is a story, and storyboarding has become a big deal these days. So you draw the story and then you run with some actors or some kind of role playing, that these are different you know um, personas in those, and then you just write down a little story and everybody works through that. So that's a all new projects I'm working in, with even any clients and companies. There's not really a lot of architecture diagramming involved.
So Mahesh and team, I will give you my perspective. I do agree with your answer that yes, But at T-Mobile, we have so many moving parts. There are like 23 domains we have. So at times, whenever a new initiative is originated from leadership side, what happens is we do HLSD, high level solution designing sessions. In that, the only idea is to cross collaborate with our dependent teams to know what the dependencies are. And all those domains come together. They agree upon what are the timelines when we can deliver it, what sort of support is needed from each other, and show the lay of the land and the landscape, how we are fitting into that space. And then we break apart, and then we get into low level design, which is more like what Mahesh was alluding to, that like more detailed, diagramming, and then showing their own architecture, how would we do things. And I see there is a question from Yash on the screen, that is a good idea to use microservices architecture for a small project. I do not know whole details, but when you said small, I believe it's a really small. So my answer is no, don't do it. You won't achieve anything. So microservices is good when you have multiple moving parts.
And I think microservices is good for when you need scalability, right? When you just have so many customers and your server may just, crap out because of load and all. Yeah.
So
if it is a small and line of business or customer facing application.
So you have two things here, right? So you have good design from day one, kind of a thing, right? That's always a good idea. However, there's also premature optimization. So you kind of have to find your sweet spot there. What is your ambition for this? It's a small project now, and it's going to be a small project forever. Right. Then the answer is absolutely no. Make it easy, make it quick, make it not dirty, but cut some corners. If your ambition is to grow this thing hugely, lay the foundation work for expanding this to a microservices project. Possibly, if you're good enough as an architect to put those sort of boundaries there already, that's a good question. But don't go and deploy it as many multiple things now, but use an architecture that can support it in the future.
Yep. Go ahead. Naveen, more questions? You want to take some more questions?
So I don't think we have any more questions here. So
we have a lot of questions in the comments.
But they are specific to programs and all. I can take one or two if the time permits us.
No, so
I have a question.
So yeah, go ahead.
Yeah,
I would love to talk to you guys and get people's opinions on containers. And I feel like containers are overused or oversold. It's something of a buzzword, right? Like we have to, everything has to be containers. Now, we all write different kinds of software, and we all know as architects that there's different solutions for different problems. But I feel like everyone is talking about using containers where they might not be necessary. Even things like deploying to Azure App Services with containers. I don't know. I'm just wondering where you guys are on that topic.
Yeah, this is an organizational question rather than a technical, because a lot of organizations are not capable of running a full-scale containerized environment. They don't have the skill set, they don't have the people, they have the buzzword, and they think it sounds cool because containers is the new black. And so they're going to try to run containers because that's what you're supposed to do. And that's definitely typically the wrong approach. If you have a team, a good solid team with experience of running a containerized environment, sure, go ahead, do it, or take those steps. If you have no containers today, right, you're starting out and you're like, we're gonna change to a microservices whatever approach, and we heard that containers were good, let's do that. Know that your first containerized little pod or what have you, the first thing you run, that's gonna be hella expensive and really, really big for you to do. The 25th one or the 50th one, that's gonna be cheap as nothing, right? Because then you're already doing it. So you have to be very respectful of the fact that there is a really significant step in to this kind of an environment, and know what you're doing. If you don't, be careful.
Yeah, I want to take a 1 minute, just one. I mean, not 1 minute, even for 10 seconds. That Alan will not be able to make it. He has some car troubles.
Oh.
So he could not, right? You agree? I mean, Magnus, you saw the email?
Yeah.
Yeah. So if
Unfortunately,
anybody's waiting for Alan, sorry about that. He will not.
maybe he can record and we can publish his video at some point instead.
Yep. Yeah.
Yeah. So we
So
have a
I think I see a lot of. So Andy, when I go to these companies, we are working with American Water and some other smaller companies. They have already made up their decide, like this is how we're going to do it. So and then I would recommend, for example, one of the project we recommended that you don't really need containers because first of all, it's going to about maybe 3,000 customers at most, and they're all internal. So, and it's just one application. It's better to build just one web API, and we exactly know. So there's not going to be scalability issue and all that. They are going to use containers for some other parts, right? So it depends really.
Right.
But I've seen that organizations are using both approaches. Depends on, in case of Uber, it's probably better to have containers because scalability is major concern. Same with Netflix, same with T-Mobile. All these companies, they are hard to live without.
T-Mobile. Most companies are way smaller than that, and
Right.
and there's an urge to use the coolest tech, which doesn't fit the problem always.
Yeah, that's why I wanted to throw it out there as a topic, because I think a lot of people keep coming, and bringing in that word and say, well, we need to go to containers. At one point I saw, it was a presentation about deploying containers to app services. And these were for single applications. These weren't for like microservice type applications. It was single applications. And I said, well, why are we even showing how to do that? Is that the best practice? And they said, well, no, it's just that a lot of people want to know how to do it because everyone's asking, how do we deploy containers to app services? But they're like, you don't need to use containers to go to app services, and it probably overcomplicates things. And, So interesting, kind of good to hear different people's opinion as well.
So, Andy, I will give you my perspective.
Yeah.
Mahesh already said it that T-Mobile is doing it, and yes, we are. I think we are one of the company which is running the largest number of container footprint in the world in PCF, Pivotal Cloud Foundry. We have over 70,000 containers up and running. Now we are migrating to AWS, most of those in Kubernetes. So this container word actually came into the picture or light with this microservices thing, especially. Now, if I am deploying an entire monolith, then where would it go? It can be deployed on Azure App Service, as you clearly called out, because it's one monolith thing, and it runs in a EC2 in a virtual machine in Azure terminology or EC2 in AWS terminology. With microservice, it's a very small service having just one single responsibility, maybe few hundred to few thousand lines of code compiled into a small DLL or jar file, and you deploy it to a container, and then use some sort of, which is less expensive than running it into an EC2 or a VM or deploying as an app service. So it can run there, and then Docker containers has images. You can take that image, deploy it anywhere, tear it apart, modify it, deploy it again. And then third thing is, you can use any sort of container orchestration like Marathon or Kubernetes in this case, and have multiple nodes, multiple versions of those images behind. And it also offers a load balancer in front of it, which can automatically send traffic to multiple nodes where those containers are deployed. So cost is low. It's perfect for cloud native and microservices architecture styles, but not for the one where you started example. And I think you were right there.
And I think one other challenge with the traditional deployment app services monolithic is that, Andy, which I run sometimes too, that sometimes you have to rely on other teams and they take forever to build those. And that's the reason these came. If I'm a developer, I have access to my cloud, I can just go and quickly deploy and just run and launch it.
Correct.
Otherwise, if you want EC2 instance with database and everything in it, then you have to go to your IT and they just, okay, approval process literally takes sometimes 3 months in some companies.
Yes, that's correct.
So we have a question. As an architect, what should be the principle to discuss requirement, design diagram, flow, and how and from where we should start coding an infra part? So basically, how the architect should get engaged with the customer, and then we'll take the question it was appearing on the screen.
What do you mean, principle to discuss requirement? I mean, we can all answer that. I work with, so as a consultant, I've been doing for 23
Yeah.
years. What I've been lucky is that I work with so many new companies, and first requirement is really sometimes depends on the company to company. Sometimes they don't even know what they want. Literally, I'm working one of the largest company. They're worth, I would say 5 billion. They do not have requirement document. Say they want an app for this thing. Okay, then you sit down with the stakeholders and business owners and just start asking them questions, and then you go meet also the end users, right? So end customers, you go meet them and see what problem they're facing, and then you kind of, right now these days what we are doing is we build a simple POC first, like literally go within 1 month we build some kind of working, show it works, show the end user and the business owners like, what do you think of this, and then go from there rather than writing detailed requirement designs. So that process is much faster than you going spending 2 months and writing requirement document and all those things. It depends on company to company really. Some companies may already have requirements process.
So you mean like the first of all, we need to get into frame of asking questions and then gather as much information as we can get without sounding stupid or idiot to the customer that he's asking too much or unnecessary questions. Then, so I believe that comes with the time how you frame your questions in a very smarter way. I have learned that because responding to RFPs or EOIs, RFIs, that thing make you smarter, that you ask one question where you get four answers in return.
Yeah.
So that is one part. And in addition to that, there are some other traits where you just allow the customer or prospective customer to speak so that you can capture the challenges they are facing, and then converting those challenging into the positive discussions, how you can pitch in your services or products to the customer to overcome those challenges, or just say there is a delta and this product can fill up that delta with additional benefits. I think that is what I do, but I would like to hear from others as well.
So I can give you my perspective. So it depends on how that organization is set up and what is their style of work and how big or small that organization is. So as Mahesh started, it's all agile. Those days are gone when we believe we will end up having one fine day, perfect requirements. Requirements will never be perfect. That's what I learned. So waterfall time is gone. It's all agile, right? You evolve. Every day is a new day, but you have to follow some agile principles. At T-Mobile, what we do is, and somebody asked that question as well, what is the size of a team architects suggest or something around the size of a team. So at T-Mobile, in all the teams, we do have a product owner role. This role is becoming very prominent in industry these days. Yes, the question is, how do you determine the right size for a project? So there is a role in industry today, product owner. Scrum Alliance also has that role, certified Scrum product owner and sort of things. So that product owner is basically an intermediary layer between the business, who are they are the stakeholders, they represent user and customer, and product owner is part of the development team. So product owner will listen to the epics and features which business is putting into the backlog, and then we pick that item into our backlog, we break it apart into user stories, get prioritized per the business need and the marketing and the customer facing teams, where the funding is coming from and the requirement is coming from, and then development team will work on those user stories per the prioritization. So if any team has a product owner role, I think it's a very important role, regardless of what small or big project is, because they can really represent the customer, what the customer is. And you need somebody, a stakeholder in your team, who you listen to what customer wants. So for example, when I was working with payment architecture, and we had questions about anything, like do we show a 2 digits for credit card or do we show entire year for credit card? Like sometimes you can say my expiration is 0522, but some credit card will say 05/2022 as an expiration year, right? So we asked the product owner, what do you want? And sometimes even they didn't know. So they will go back to business owners and ask, okay, what do you want? Do you have a wireframe which we can use? So that's how we do at T-Mobile.
And that's correct. And to add to that, I think the role of project manager is going away.
Yep.
I see more product owners in every
Yep.
company than project managers, because
Correct.
project managers were usually non-technical people. Their role was to manage the resources and time and make sure tracking in business owners' finances. But now product owner is technical and also working as project manager.
It's a skill set too. Let's not, oversimplify that. I think that there are good product owners and there are people that are not skilled at being. I mean, they may be the product owner. They may actually own the product, right? But that doesn't mean they're good in, let's say, an agile team kind of perspective and working with, like you said, we're moving away from project managers, but there's a skill set there that isn't always easily replaced. Now, I'm a fan of agile, right? Which doesn't really have project managers. We have product owners, but there's a skill there, and I just wanted to point out that it's important to find the right people in the right positions.
Oh yeah, definitely.
Yeah. So can I throw something in sideways into this conversation as well, because it's associated with exactly what we're talking about here. Vidya, you were also mentioning the ownership of this, and I believe others have commented on this as well. Who owns this? We're talking about the product owner now, and we're talking about the ownership of what is running, sort of, right? Or it's a piece of the project, or it's a whole system, or doesn't matter. But the point there is, when you're talking about ownership, it leads to the question of accountability. And people want to be professional if they're working if they take their job seriously, they want to be professional, and they should be enabled to be professional. And I've found one really sneaky tactic to ensure some really good practices in projects that I work on, because I have seen the opposite. And let me first just quickly mention what the opposite is. The opposite is no one is responsible, which means that the cost of what's running, let's say a cloud project, will go forever up, because nobody owns the resources and nobody cares about them, and nobody will shut them down or right-size them or even care if they're running perfectly or not. So nobody has responsibility, no one is accountable, and there is no responsibility, and therefore the cost will go haywire, and performance will not be there, and the customers will not be happy, regardless of how much money you throw into Azure or whatever cloud you're using. So that's the bad version. The good version of the same is to enable people to be accountable. And one really good way to do that is to budgetize things. And as a business, you set a budget for a project and you follow up on that budget, because if someone is responsible for the cost of something, they're all of a sudden going to be very, very interested in optimizing it. They're going to be very interested in having performance metrics in place to follow up if this is performing according to what it needs to do, and shut down test environments over the weekends and all other kinds of really nice practices that comes from this magical thing of allowing people to be accountable with a budget, right?
So, Magnus, so we at T-Mobile are doing the second one. Every team is given a budget and accountability. We have our own asset catalog where every single container, website, application, portal, platform, tool, product, everything is listed down with the director and manager name. But when it comes to accountability, we at T-Mobile are having a rich culture of DevOps. So we live with the motto of we build it, we own it. Nice. And so that's how we do it as a team. And every team is sort of like, as I gave an example earlier, like a two-pizza team, like 7 to 9 plus minus 2 people. And they own one particular small microservice or platform or product which we are building for our customers.
That's good. That's good. Yeah, those are some really good practices that I've also seen common enough to be successful, that you mentioned there.
So there is a question on screen. How do we know that the architecture you're designing is going to work, and who will be building the POC, and do they have to sit down with a developer to get the POC done? Yeah, I do this a lot. That's what I really do. My most projects are, I don't work on, long projects. I go in corporations where they need innovation, they have new ideas, they need help. Then so POC, yeah, you work with developers. As an architect, you really don't write the coding. I mean, I don't write code anymore. You do have developers, they will do. But how do you know architecture will work? And you guys can jump in. Well, you read a lot, you learn a lot, you build already, you have experience. So if you build a house for 10 years, you keep improving new house building every year, you're building a new house, you already know it's going to work, right? If you look at the buildings, when they build these tall buildings, they are like 70 stories. How do they know that this building is not gonna fly when this wind comes? Because they follow certain proven architecture, and that's what architects really do.
Yeah.
You guys can go ahead and jump in.
No, this exactly speaks to experience. This speaks to the skill set you develop over time, where you are able to sort of see things when you're talking to the customers, we are putting the pieces together, and you're discussing the technology options. You're able to see things, and if you have enough ability, charisma, leadership skills, and even power to put in place the right fundamental approach from the people who are building it, secure coding and all these kinds of things that they should be doing, then it's going to work.
Yep. Yeah. For me, actually, it starts from you are engaged with the customer. So you capture the requirements based on your questions you framed, and that comes from the experience. And then you start visualizing the big picture, where your solution or the challenge, how do you overcome it? So whatever your solution is, it's a service, it's a product, anything. How do you make that product part of that whole ecosystem based on assumptions, based on risks, issues, mitigations, all that we call it trade log. So that combined, you need to have that working in place, and then experience tells you that whatever you have designed is going to work. And then obviously POC would be there in software projects. There are POCs, lots of customers ask for smaller POCs, working demos, before they want to decide, or before they want to go into details of any software product. But this is how it is. So for me, it's combined of your visualization, how you think that your product or service will fit into the bigger ecosystem.
Yep.
I have a question on the screen. Who will take that?
I can start with that, Mahesh.
Go ahead.
Yes, please.
So
And then we can follow up in that. Maybe we can just take a quicker question, one person each. Go ahead.
So this question is like, how do you know when you are over designing a system? So first thing is, you need to always understand who you are designing it for. I think that's the key, right? So it's as good as if you know you are building a car, you do not need to put aeroplane tires in that car, because you are just building a car, right? You don't need aeroplane tires there. So always know who is the end customer. Like we at T-Mobile, whenever we are building something, we always keep our 85 million customers in mind. That's how we design systems. So always know who is the end customer, and that number will always keep going up. So know what is the scale going to be. And then third thing is, in Agile, there is a principle, no BDUF. No BDUF means no big design up front. I will repeat it, no big design up front. Having said that, do not just lock your design that it will work only for 1,000 customers because I have 1,000 now. You want more money in the business, you want money to excel and grow. So make it scalable, make it, a fault tolerant, but take steps in such a way that it is auto scalable. You have those policies in place that it can auto scale. Don't lock into something which is hard for you to evolve in future. But at the same time, do not just spin a virtual machine, which is like a Godzilla machine, just to serve 2,000 customers, right? So these are some principles I would say keep lenses in mind to think about whether you are over designing or not. I think these are some guardrails you can use and follow along.
Yep. This question for Andy.
So I just want to add one thing to that is, and I agree, those are great points. But one thing I say is, don't design in a bubble, right? Work with other people and have a culture where you're challenging each other in a friendly and supportive way, but where we have a place where we can say, hey, is this going to work? Or someone can challenge and say, that seems like it's too much, because it's really easy. We talked about design principles early on. It's really easy to slip on those things when you're on your own, because it's like, oh, it's just me. I can do a little bit more. I could do that, right? You need to have that buddy system or that support system of other architects, other developers to remind you of your principles and remind you to stay at a certain place. I just want to throw that in.
Yeah, and that's what said, become a leader, right? Don't become a boss. Leadership is not about telling people what to do, but getting everybody involved.
So just one more thing I will add to that, since a lot of people are listening and I want people to be beneficial with how real world companies are doing it. So as Magnus said, like, it needs a lot of experience to build things. And also me and my peer architects, most of the time, we discuss among ourselves, but I also do not want people to get into analysis paralysis mode, that you keep analyzing and do nothing. So with your experience, you will know what you need to do. You learn the domain, you know the team culture, you know the landscape, you build something and present it. Don't just, and discuss ideas there and tweak it and fix it. Other thing which we at T-Mobile follow along, and that is another role of architects, is to provide governance. So we at T-Mobile have a mechanism in my team at least, that we have an architecture governance forum where we have large meeting invites sent to all the people in technology group of ours. And then we go in a big room and sit, and online link is also there to join. And anybody can bring any topic they want to discuss. Somebody can bring, okay, I'm thinking about this design change. What do you think? Is it available for change or not? Or what are your 2 cents on this? So governance is also a key thing where you can go and collaborate with people, as Andy said, and then don't do it in isolation, and use other people as a soundboard, and then you get better at it.
Yeah, there's a question. Magnus can take it, or Naveen, one of you can take this one.
I can't hear you, Naveen.
So question is, most of the companies does not have an application architect, and its lead developer usually do everything. How do you move to an architect role? And I think, Andy, you answered this really well. Go ahead, Magnus. And
yeah, I mean, it's not about it's not about the little pin on your shirt, or a little plaque on the desk or on your door. That's not what architect is. If the lead developer is the one who is architecting this, because that person is ambitious and driving things and taking charge, and hopefully being a good leader, an inspiring leader that puts people in roles that they can fill and lets them evolve, right? If you have a blocker, if that's what this is leading to, that there's a lead developer in the way and you can't get past that person, you should consider moving to another team. There's always going to be, bad apples or bad people in your way. If you want to, right?
Yep, we will. Naveen, you want to pick a couple of more questions, and then we will kind of close it. Take 2 more questions. Do you have access to all the comments?
I can't hear you, Naveen.
Is Naveen frozen? No, he's not frozen.
No, he's not frozen, but I can't hear him.
Maybe he's reading.
No. So can you hear me? Yeah.
Yes.
Yeah. Okay. So about this question, I believe Magnus earlier has said as well that it is all about your experience and not just the title you carry. So if you are in a very good shape and very good condition to ask better questions and to visualize the whole solution, then you automatically become an architect. Because architect is something who designs, who visualizes, who does the whiteboarding, and then puts all the ifs and buts, all the ecosystem questions, list them down, get the answers. If not, then put the assumptions around it. But at the end of the day, delivers the solution what is required. So next question, do we have any other questions? Or
Yeah, there's questions here. We already covered those in these.
So what we could do is we could sort of start to close this out with a question which is not technical, but it's more about the. I think that it's appropriate to talk about the things that are less obvious, because it's quite obvious to get certifications or do these things. Those are the obvious targets. learn more and study architecture and these things. But we have all alluded to throughout this day or evening here, depending on where on the planet you are, it's about the communication. So a good friend in our industry, Mr. Hanselman, had this lovely comment about him and his wife, that they have a geek to normal relationship. And that's a funny, but it's funny because it's true, right? Technical people are a special kind of breed of person. And non-technicals, also referred to as muggles, are people that don't understand that. Now, the architect needs to be a person who can translate between these two. The architect is someone in the middle here. And so experiences around what does it take to be a person in the center of the, basically in the eye of the storm, right? In between the business owners, the end customers, and the technical people, and none of them understand each other, right?
Yeah. So he let others talk and understand each other. He stitches the whole fabric of the solution or our service. And basically, for any proposal, I believe it is the architect who drives the core system of the proposal, because sales people, they just add the marketing stuff about your company, and a financial guy, he will just put the cost around the services, time and material, whatever it is. The architect basically thinks around what are the challenges, how we convert into the benefits, how to remove the risk, how to make the best assumptions so that still product is or service is sellable to the customer and he accepts it. And then at the same time, he has to manage the cost of the overall development as well. It cannot be like Vidya said, you cannot just put a aeroplane tire to a car. So he has to think about the economic boundaries of the solution as well. And then at times, a customer approaches and he asks, what are the 3 best scenarios in this? Then he has to produce 3 scenarios, and then he has to give his experience take that I will go with option B. That is the most viable. So these weightage basically comes in handy when they technically evaluate the different solutions or vendors across the board. So that is my 2 cents about that.
Yeah, and just somebody asked me, yes, all these sessions are going to be available on YouTube and CSharpCorner also. For CSharpCorner, we'll upload them within, I think, next few days. So check them out. We also have other events coming up every week, and every month we have one conference also. So next conferences are going to be on startups. One is coming on startups, and other one is coming on blockchain. So if any of you who are joining us today are interested in getting involved in startups or blockchain, or even I think we have a conference coming, Women in Tech. So each one, there's different conference, there are more sessions, and with that, I think I would like to thank everybody for taking their time from busy schedule, all the speakers, all the organizers, Simon and the team, marketing, social media team working behind, started working for past few weeks. Thank you so much, everybody, and everybody for joining us. Magnus, you go ahead last. Anything you want to say last?
Well, this has been truly been a pleasure. I think it's inspiring to see how many people out there are listening to us, and how I think software architecture, again, what I said initially, right? This is now a very highly sought after profession. People want to be in the midst of things, and they want to be special in their field. I think with software architecture, that is it's a very big goal to strive for, to be the architect, but it's also immensely rewarding once you get there. I wouldn't want to do anything else, probably, hopefully, for the rest of my career. It's a great job to have.
Correct.
Thank you all for listening and joining us today, and for asking all these great
questions. And you want to add something to that, and then
I'll just say see you soon.
Are you falling asleep?
No. I'll say see you soon. Like, we will be appearing pretty frequently over the webinars. So we have interesting session lined up, and we plan more on the architecture front again. So,
All right, guys. Thank you so much. I think we're going to close this now.
Thank you. Bye.
thank you. Nice day. Bye bye, everyone.
Happy me.
Ooh, that was